I've shut down Microsoft Teams, shut down everything, totally focused on the to have you here. Well, it's 8:30 in the morning in the UK at the moment, which is really nothing compared to our good friends in Boston. So the first speaker today is going to be Michael Davies, and Michael is in Boston as we speak. He's an MIT professor over there. He's also a CEO for a couple of companies, and also a professor at the London Business School over here. It's going to be fun to hear what he's been up to. He's been doing things in this area for a long, long time. So that's fun, that's good. I think we might also have Antonio joining us this morning for a couple of seconds. Whoa, there you are, Antonio. Good morning.
Hi, good morning. How are you?
Yeah, it's good to see you. It makes sense for you to be joining me because you're in the same time zone. You're in Lisbon, so
yeah, it's a perk.
Yes, West European time, wet time. It's been raining here in England all morning. I hope it's a little bit more decent over where you are.
Better here. It's sunny.
Okay, cool. So we've got some interesting people that we're going to be talking to during today. We've got Michael, as I mentioned a few seconds ago, and Antonio, you and I have spoken about him several times before. We've got Mikko, who is CTO at Huawei. He's going to be talking about a lot of the technologies that they have over at Huawei. They have a lot, and I asked him also to talk a little bit about the tools that they make available today from Huawei to help people do machine learning things and so forth. It's going to be interesting. I think Antonio, you're going to like that because it fits into a lot of the stuff that you do. Because I think typically with your platform, people typically combine things, don't they? You have sort of multiple elements, and you're kind of orchestrating from your platform. Would you say?
Definitely.
So I think that's going to be cool. Andrea, who's speaking after that, Andrea Paroni is chief editor at Nature Physics, and is going to do a little parallel from condensed matter physics into, I was going to say, Donald Trump's campaign into how we think about these things in sort of a statistical approach to modeling, audience modeling, media modeling, etc., etc. It's really quite fun. What type of a parallel he can draw from it. I'm a physicist myself, so it's always fun for me to read a little bit about physics. It's fun. After that, we've got Anthony, and Anthony is at Rosenblatt, and I warmly recommend to all of us that we continue to be very good friends of Anthony. Anthony on a good day is cycling up and down Portobello Road in London, enjoying life, and on a bad day he's a lawyer who takes care of his clients, and you do want to be one of his clients, I assure you. And he'll be talking about the interesting aspects about how liability moves from one person to another, and I think it's hugely applicable to the things that you're doing, Antonio, because if you use a powerful platform like your low-code platform and something goes wrong, then is it the fault of the software developer who did something on top of the platform? Is it the platform? Or is it the people operating the platform, people using the platform? So those are the types of legal questions that Anthony is specialized in, which is really quite cool. I hope you never run into, I hope if you ever meet Anthony, I hope it's either with a good cup of coffee on Portobello Road, alternatively with him on your side of the table. So that's fun. And Bika's going to be talking about imaging and lungs. So she did a PhD and stuff like that in looking at nodules and things in lungs. People call them lung spots. They're these sort of 1 centimeter big things that people can get. And most of them are perfectly okay. Some of them are not. And she's working on automated ways of determining what's good and bad in there. And of course, as of early this year, she's been 100% working on COVID, like everyone else who understands lungs. And she herself has, of course, already had COVID. Her whole family has been there. So she's lost a bunch of colleagues, so she's frontline. And yeah, that's Ambika. And then we'll be pulling together everyone for a panel discussion at the end of that, which I think is going to be fun. And then Philip's probably going to come early for that panel discussion because he wants to spend some time talking to Ambika. Philip's balancing a couple of simple things, and in terms of low code, it's totally again applicable to what you do, Antonio. He is trying to work out budget-wise how Boston and Sweden and Frimley NHS, places like that, how they should spend enough money on AI now, while spending enough money on COVID, while spending enough money on everything else that needs to be taken care of, hip replacements, everything else. And he sees AI as being fundamental to us being able to afford healthcare in the year 2030. Because if we continue to go down the path we're going down right now, then we won't be able to afford healthcare. It doesn't work. So we'll have to either become much more precise, fast, efficient. Alternatively, we have to reduce the amount of care that we provide. And if you look at the technologies that you're an expert at, Antonio, this is like home territory for you. So it's really quite fun. Then after that, we've got Sami, and Sami and I worked together. We got spot time at Nokia. He was a big boss for everything to do with intellectual property over there, which of course includes not only patents, but also business secrets, ways of doing things, and copyrights and many other aspects as well. So that's what Sami is going to be all about. And the situation we have now is revolutionary because companies are very quickly moving up the value chain. They're very quickly trying to use their software development teams as really quite chunky, capable things so that they can focus on doing the business at the top end. And when they then build things that, or come up with things that should be protected, then the question is where the protection lies. The architecture of where the protection could lie has changed. And certainly that's, again, you and I have spoken about these things, Antonio, and you must have many customers who wrestle with these questions.
Yeah.
And so this is really your stuff again. Then after Sami, there's a very strange man called Mr. Allegra who's going to be talking. What are you going to be talking about, Antonio?
So I'm going to be talking about how AI is being applied and can be applied in the future to evolve how people do software development, and how AI can help guide, automate, and validate software developers' work. And I'm going to be talking about what OutSystems is doing within internal research and development in collaboration with universities, but also I'm going to talk about what other companies are doing, what's the state of the art in many different areas, different tools, so that people get a sense of what are the big challenges and what are the opportunities and what exists today around this area.
Nice, nice, nice. And after you, we have Sally. And Sally is publishing at the moment. She's just written a couple of books, so she's just messing around with those things. But that's a hobby. Her proper job is to be one of the big bosses over at Forbes. So she's head of Forbes Technology Council, and she'll be talking about a number of projects and about how people are looking at those from wealth perspectives. She's got a couple of interesting angles. I think you'll enjoy her very much. And after her, we have Rose. Now, Rose is doing a simple little thing. Rose is boss for something called Educate, and Educate is a thing that is modeling how people learn. And okay, so is that easy? Okay, so use AI in order to model how people learn. Then you use AI to model how people teach. And then you combine the two so that you combine the way that people learn with how people, and then you start studying the efficiency of teaching and learning. And that's what her team is doing. She's got loads of people working on this, and it's absolutely fascinating. So she's going to be talking about that. And after that, also on the people side of things, we have Michael Short. And Michael has been working with PokerStars on deploying AI technologies inside PokerStars. And PokerStars used to be a company, and they actually bought a company from me once upon a time. And PokerStars is now just a brand by a very big company group. But PokerStars in its own right is a multi-billion annual dollar turnover business. And it's really quite fascinating how they structured the whole thing. And Michael's been bringing in AI into quite a few different areas within that business. And I asked Michael to talk about the human side of it, because when you try to innovate, when you try to do new things, you run into very many situations, not only hierarchical, but also process-related things and so forth, which are very challenging. And he's going to be talking about how everyone that's taking part in this can think about those human aspects of innovation and how to somehow create innovation without stepping on other people's toes. And it's and I'm sure, Antonio, again with you, if people have been developing in traditional code, there's nothing wrong with traditional code, but if people have been developing on that basis for a long time, and then you sail in and say, whoops, by the way, we can make this 10 times faster, then you will step on quite a few people's toes. Antonio, how do you handle those things usually?
So that's really interesting, and actually I'm going to talk a little bit about that, because we're now trying to take from 10 times to 100 times, and there's always resistance. And I think you need to have a people-centric approach to it, and you have to have more of a, how can you help augment those people and how can you kind of communicate to the benefits they can receive, rather than from a process efficiency focused communication. And I think that typically works is work with the people, show them what they can do, show them the way, and show them that they have an option of taking advantage of some capabilities you might have, or some others that they might not choose to do that. So it's a lot of times it's a lot of a user experience challenge. So the way I mainly tackle these things is by working a lot with business stakeholders and with the people, but also with product designers to make sure that the product can be used in a way that is not kind of scary or kind of a non-engaging way with different types of users, novices, experts. Experts typically are sometimes the hardest to bring along.
So I can imagine. I can imagine that, especially from the perspective of if someone has built up an expertise over 25 years, and someone then comes in from the side and says that particular expertise is not needed anymore, then people are looking at quite a fascinating learning curve. They quickly need to take the experience they have from the way that they worked before and use their experience in this next world, but not the actual knowledge bits, but their method of working, the way that they think is applicable. But they need to sort of relearn a lot of things anyway in order to. And you're saying, so your goal is not to make things 10 times faster, so you're gunning for 100 times faster. I like it. 100 times faster is bigger than 10 times faster, so that's a good number. That's got to be a good number. I like it. Another person who would like it a lot is Malika. Malik is going to start talking at 15:30 at 3:30 UK time. And so that's after lunch in Boston. So great. So that's when she started. Malika is a cloud specialist. So she's a cloud migration specialist, but she's also a specialist in the area of both artificial intelligence and also financial services. So she sort of combines those three. She's a bit of a celebrity in a couple of social media circles in the UK. She does some really fascinating stuff, and I think you'll enjoy the way that she looks at AI in financial services. She's actually, yeah, she's got a lot to say. Looking forward to her talk. After that, we've got Hans, and Hans is at Mendix, and he's going to be talking about ways of using artificial intelligence to generate code automatically. And which is kind of fun, because directly after Hans, we got Henry, and Henry is going to talk about how you can use artificial intelligence to automatically test code. So if we have, and Antonio, you have this capability as well, that if you're using AI in order to generate code, and then you use AI in order to test code, then ... you get quite an interesting situation. So that's what Henry wrote his PhD on these things. I read his PhD. It's a really nice piece of work, I must say. And so he's got a lot to say. That's going to be fun. And after that, Edgar. And I first started working with Edgar when he was in France. And then he moved over to Dallas, worked with Texas Instruments over there. And Edgar and I did a couple of patents on chip level things with TI, and a guy called Harry Backman was involved and so forth. That was really good fun. And then beyond that, Edgar is now in Menlo Park, San Francisco. He's dialing in from there. And he's boss of AI and virtual reality and augmented reality for Facebook. And it was quite funny when we did the speaker training for him. A lot of the stuff that Edgar was talking was purely video based, so that's really quite brutal. I'm going to take Michael in now, and let's the three of us talk for a couple of seconds. And in fact, I can see that Henry's there as well, so I'm going to join Henry here for a couple of seconds as well. Let me just run through the agenda first, and so these are a couple of the guys here, and so after Edgar, we've got Eddie Short from Telefonica. He is responsible for deploying AI throughout the Telefonica group, which is all of Latin America, Spain, and I don't think they're in Portugal, are they? I don't think so, but big in the UK as well. So that's fun. So that's going to be a good crew. And then after that, Katie, and Katie used to work for the Obama administration, did all the numbers for Barack, and after that worked with Mark Zuckerberg for a few years, and now she runs her own company over in San Francisco as well. It's a non-profit organization, but it's a fascinating one in the area of medical. So that's going to be fun. And so we have a couple of the speakers who are just sort of saying hello here right now. In 10 minutes time we'll be starting, but I can see that several of us have already joined in here. So we've got Anthony, we have Henry here, we have Michael. So Henry, how does it feel over in Finland? You're near, it's quite late your time already.
Well, it's already 11 a.m. so I'm awake now. So it's good here. Also, it's been quite nice weather here, and everything's good. And this topic is really something I'm really interested in seeing where the whole day takes us.
It's going to be a trip. It's going to be a trip. Michael, I trust it. You're not doing this from MIT or from Endeavor Partners. You're doing this from home, I hope.
Yes, I'm doing it from sitting in my office. I haven't. Yesterday went into my company office for the first time in about 6 weeks, which was to discover that me and my CFO were the only two people in the building, as far as we could tell.
Wow. And Anthony, have you been out for your cycle ride and your cup of coffee in the morning on Porterville Road yet, or still taking it easy?
Not yet. Just having a cup of tea at the moment. I'll try and get out there a bit later today.
Very civilized. Nice. So so Antonio, are you? I think you're a hardcore. You take a cortado in the morning. Is that your standard morning?
Yeah. So yeah, I actually vary a lot. I have periods where I just do a large cup of coffee, brewed coffee. Other times now I'm just taking espresso.
Okay.
Take espresso. Yeah.
So Henry, looking at all these guys, oh, Andrea, hi Andrea, it's great to see you as well. So we have a sort of couple of threads running through these. We have the sort of medical thread, we have IP threads, quite a few sort of angles on this. Andrea, you're going to be talking about sort of quite small things, I think.
Well, yeah. Well, we'll see that. I'll talk about, I guess, ultimately AI in physics and in science, and sort of give a bit of a perspective, which is perhaps not really from an industry side, more from a scientific side.
It's nice. Looking forward to it. It's going to be fun. And Michael, you have quite a big picture thing that you want to go into. What we could do, we're at 8:53, so we still have 7 minutes to go. And Michael, after you, we'll be talking to Mikko as well, Mikko Terho from Huawei, and you have some history with Mikko, I think.
Indeed, we were co-conspirators on when we were trying to bring architecture discipline to Nokia.
I'm ex-Nokia, so I can feel the pain.
It was a fascinating learning experience.
I can imagine.
Yeah.
And so it's And just so everyone knows, Michael and I, we met a few years ago, back in 1992, and we rolled out the first data networks on mobile networks ever in New Zealand, and the first services on those. Michael was the big boss on that.
Don't steal all of my thunder, because
Okay.
specifically on that topic, with pretty pictures and all of the rest, I thought of reaching out to you for a photo of you from 1992, but I wasn't sure that you would have one that was available in digital form.
That's fun. That's fun. Those are good moments, fun moments. Great. Okay. So I think we can actually, I mean, typically people overrun. Well, what if we underrun? Shall we just break all the rules and just and let why not? Why not simply let Michael start? You've got lots to say. So I think I'll disappear into the background, and guys, see you later. And let's just reel back. And Michael, if you can take over the show, and let's break all the rules and start 5 minutes early. How about that?
Okay, how very Swiss of us. As a master of the technology, there's something I need to do to make my slides actually come up. I've set up share screen. There we go. So what I want to do is talk about the state of the art of artificial intelligence. I asked, believe it or not, I actually asked Peter to be able to kick this program off. Yes, it is just about 4 o'clock in the morning here. What I want to cover is a pragmatic and a personal perspective on what the state of the art is, and to provide a lens through which people who are participating can look at the contributions that many accomplished people are going to follow me throughout the day. And I want this to be a conversation starter in which, hopefully with a bit of luck, I challenge some of your thinking, I make some connections, and hopefully you learn a lot. I don't know if this applies to the rest of you, but in my case, this is very much not a canned speech. This is the first time I've laid out this hypothesis, so I'm particularly interested in candid feedback. I've thrown out my contact information here for anybody who wants to reach out to me, and I'll repeat it at the end of the presentation. And what I promised to deliver for Peter was 3 things. First, why you must adopt AI to survive and thrive in this post-pandemic option. Now, I think to some extent with this audience, I'm very much preaching to the choir, but I'll lay out my particular perspective on that. Second, which is more my primary focus, is what are the challenges we face, and my personal pragmatic perspective on what we need to do to create real value from AI, which is actually not worrying about AI per se. And third, by way of conclusion, I want to talk about what I personally happen to be doing to try and advance AI, in particular education, and as an entrepreneur, harnessing AI to accelerate innovation in healthcare. So I'm going to bring 3 complementary perspectives to bear. I'm going to bring the perspective to bear of somebody who's worked as an advisor. In particular, most recently, and I'll elaborate on the why for this, strategy work for clients who are becoming digital explorers, trying to create significant new value from digital technologies and AI. Secondly, I want to bring the perspective to bear of an academic and author, and I'll elaborate on this, but in particular, you get to hear it here first. This is the first public announcement of a new forthcoming open enrollment online program at London Business School called The Business of AI. Think of today as the soft launch. There'll actually be a formal launch in the next few days. And as part of that, I'm also writing a book on what you must do. I've had to revise it to take account of COVID-19 to survive and thrive and deliver prosperity from digital technologies. And last but by no means least, although we have had to slow things down, how me and my co-founders are exploring state-of-the-art AI for clinical trials in the home. So those three perspectives, some advising, an academic and author perspective, and a perspective as an entrepreneur trying to create real value for this. Oh, and by the way, in the context of this presentation, whenever I say AI, I mean machine learning. Other people may look at other facets of this, but what I want to do is focus relentlessly on that and largely stay away from the debate about weak AI versus strong AI and other forms of AI. I'm focused on the pragmatic application of this technology in a way that dominates in real-world applications. So with that important constraint. So why do I want to accelerate the adoption of AI? The appropriate adoption of AI for apposite applications. Well, first, AI is a matter of life and death. I'll start with that and put that statement down literally in some medical applications, and some of the subsequent speakers are going to pick that up. Secondly, the adoption of AI is the key for many businesses to whether or not they survive and thrive. There's a set of digital technologies whose value has been demonstrated by the advent of the COVID-19 pandemic, even to people who were real skeptics about it, who otherwise would not have been adopting them. And it's now become clear that being a digital laggard is actually what I would call a corporate comorbidity. The effect of COVID-19 has enabled the digital leaders and the leaders in the adoption of AI to accelerate their position and improve their economics, while the laggards have fallen behind, and there's a high association between being a digital laggard and actually going bankrupt. And AI is one of the 5 key digital technologies that are the basis for enabling us to create some widespread prosperity, along with smartphones, cloud services, the Internet of Things, collectively a platform. It happens that I've been passionate about the potential for AI, and that's actually how I began my career. I spent most of my 20s working on what were then state-of-the-art technologies. A few years ago, I was asked by Thomson Reuters to look at the implications of digital technologies for knowledge work, and that scared me shitless, frankly, and actually led to me going, wow, I should actually rethink what I do professionally. I was scared shitless. I'm glad to say that I have since become cautiously optimistic. I've come to believe that digital technologies and AI can create widespread prosperity, harnessed appropriately. As I said, I began my career in AI. My second degree is actually in what was then called robotics, cybernetics, and microelectronics, and specializing in particular in the way we did AI, which is very different. It has no overlap with the current machine learning approaches. In expert systems and in discrete stochastic simulation, applying this to AGVs and material handling robots and rule-based and heuristic approaches to scheduling, and some of the earliest work on machine vision, which we tackled in ways that are fundamentally different from a technology foundation to the way we do machine vision nowadays. And recently, after a 30-year detour, I found myself drawn into working on the potential for autonomous robots in subsea automation, the impact of AI on businesses, and on business and technology strategy for AI businesses. That turning point was a very simple question. I am indebted to James Powell for asking me to look at this. I was asked by Thomson Reuters to say, what is the implication of digital technologies for the knowledge work that's at the heart of their business and of their customers' business? 2 big takeaways. Machine learning is transforming the economics of creating information, which is pretty much what they did. And secondly, pretty much anything that can be will be automated. And I found it interesting to go back and look at what I defined that was and what caveats I would now apply to that. The caveat here being anything for which we can get the requisite data can be and will be automated. And that's sort of at the heart of why I'm such a passionate advocate for the power of this as a technology. Why? This is really the answer to that first question. There is no routine and narrow task for which the required relevant and robust data is now available or can be made available that will not be able to be addressed by machine learning in due course, and probably very much sooner rather than later. And this is not just back office admin work. It's not rote stuff. It's not even just knowledge work, which is the first thing that had people sit up and go, wow, actually, this is a really very powerful technology. But it's things that we have long regarded as uniquely human. And the examples that I find most striking here are we can use AI to understand our emotions, to detect emotion in voice. We can use it to visually gather information, mapping people's faces to gauge what their emotional state is. And we can use it to create artifacts that convey emotion that is so lifelike that we cannot avoid responding to them. Cogito and Affectiva are MIT spinouts. Soul Machines comes from Auckland University, and collectively they can actually enable us to be interacting with digital avatars, digital humans, whatever you want to call them, in ways that mimic things that we long thought of as what makes us unique, because it's around routine and narrow tasks. And most of what we do in the economy is routine and narrow tasks, so that has really deep and profound implications. It does still have some profound limitations, though. No modern, and this is outside the scope of where I want to go mostly, because I want to focus on what we can do and what the barriers are there. It's still true that no modern machine can match the ingenuity of any 3-year-old. As I was writing this, there was a reflection for me on the ingenuity of small children, as I am the parent of several daughters, the youngest two of whom are 4 and 6. And if you really want to understand the ingenuity and the destructive capability of a 4-year-old and a 6-year-old, have them spend nearly 2 weeks quarantined with their father because their mother, who lives about a kilometer away, has been diagnosed with COVID-19. They discovered new and novel ways to create chaos and increase the entropy in my life. And the good news is we all survived and we're all still alive. So we've got AI. AI is great at narrow routine tasks and, in essence, statistics using history. Now, you can debate about whether or not this is stretching the definition of the boundary of statistics, but it's at least one helpful way of thinking about it. And it is extremely poor at generalizable learning or dealing with out-of-context questions. This idea of out-of-context questions is something I'll come back to. And for those of you who are familiar with it, in terms of the DIKW hierarchy, where you start with data and you make that meaningful as information, and then when you can actually interpret it well, you have knowledge and wisdom, we're pretty good at data information. We cannot rely on AI now or for the foreseeable future to actually provide us with knowledge, let alone wisdom. And that actually, ironically, is part of the key to unlocking its value. We are nowhere near harnessing its full potential. So we've got a very powerful general purpose technology. And why is that? Well, the adoption and diffusion of new technology inevitably takes time. That's just inherent in their characteristics. Nothing happens overnight. Electricity took 60 years, steam 90, the printing press a couple of 100 years for widespread application. And for most applications, the adoption of AI is following what's known as a pro-bit model, in which potential users carefully weigh the costs and the benefits, taking into account the risks. There are some exceptions to that. I'll elaborate on those in a moment. In particular, applications that are invisible to the user, which are following an epidemic model. And yes, this means that I'm using epidemic in exactly the same way as we use it in the COVID-19 context. You become infected with an idea, and as a result of that, there is a behavioral change. And underpinning this, some profound challenges. Knowledge and wisdom about AI is not yet widely enough shared. There are people who know how to do this effectively, but that's not generally dispersed. And in particular, there is a shortage of people who have the relevant experience and requisite specialist skills. Peter's brought a broad cross-section of them here together today, but we are the outliers because most people in business, let alone in the general populace, don't have the requisite practical experience and specialist skills to make effective use of this as a technology. And actually, I think, and I'm really interested in other people's take on this, there's a particular problem with AI, which is it's perceived by many people as sort of being magical and mysterious. And its very opacity is one of the things that makes it difficult for people to figure out its practical application. That's not an insuperable barrier. As I will elaborate, very few people actually have any idea how a smartphone really works. That doesn't stop them making effective use of this. And we've got to find ways of getting AI adopted without everybody having to know how it works internally. We're seeing both type 2 errors, false negatives, AI not being adopted for applications where it should be being adopted because the potential payoff is there. We're also, unfortunately, also seeing some type 1 errors, false positives, which have their own pernicious effects. So the key challenge for AI is now in adoption and diffusion. And what are the big issues? No clear causal model. You can see a correlation, but you don't know that it's actually necessary causality. And there's some particular issues about driving AI models too hard, which tend to find a way of getting an outcome that looks like a correlation with actually not having a robust underlying causal explanation for it. The learning that you create is not generalizable. It's extraordinarily difficult or impossible to transfer models. You can transfer learning about models, but it turns out that the AI models tend to be extremely specific to a particular problem domain. The combination of the challenge you're facing and the availability of the data and other characteristics of it. There's a lack of transparency. I'll come back to this in terms of one of the key things we're going to have to confront if we're not going to have just high levels of adoption, but actually appropriate adoption. The results can be untraceable and hard to reproduce. They typically require massive amounts of data. Now, this is an area in which there's been a lot of innovation, but this is a particular problem with some of the false positives that we see. The payoff is, for many people, uncertain. There are now people who can demonstrate and point it to it, but actually, and I've been digging pretty hard on this, although there are a few well-established use cases, for many potential applications, the benefits remain unclear, and we don't have enough people. In particular, we have few people who both understand the problem domain and the technical capabilities, and even fewer people in top management who understand it well. Yes, this is one of those occasions on which we get to blame top management, and it really is in many cases their fault, with the exception, of course, of anybody who's from top management and who's contributing to this event here today. One of the things that has led to is that businesses' adoption of AI is very dependent on the heritage of the business. Are they born analog or born digital? And this is something that I find myself, as I was pulling this presentation together, having to remind myself, because it's such a different world. I talked about two different models for adoption and diffusion of technologies. Probit models, where you have different valuations of the technology depending on whom the user is. And adoption is driven by heterogeneity of preferences and priorities. In the epidemic model, mere increased awareness leads to increased adoption. And you've got homogeneous preferences and priorities, simple, well understood goals and directions. When it comes to born analog businesses, data is typically important to only a few company divisions. They often operate in silos, and they've become very good at doing what they've been doing for a while. So quite rationally, they fear change. They have a lot more downside than they have upside. So slower adoption rates. Born digital businesses. There is a universal embracement of the usefulness of data. Company divisions are often extremely collaborative, and from their perspective, hey, I'm in this for disruption. So rapid adoption rates and diffusion. And I sort of take it for granted that AI will be embedded at the heart of the operations of almost any new born digital venture. And that's a really important distinction. Most of what I have to say is focused on the issues that arise with the adoption and diffusion of AI in incumbents, in established enterprises, where the real challenge lies. I talked about the exceptions. There are some examples of epidemic adoption according to the epidemic model. These are the ones which require negligible behavioral change. And my classic one is voice assistants and smart speakers, where once people actually figure out there's not that much utility to it necessarily, but enough. In one key month a couple of years ago, between Black Friday and the Christmas holiday, the rate of penetration, the rate of adoption by US consumers went up by about 20%. It was nearly 1% per working day. And the US installed base now exceeds 50 million households. So it's about half of all households. Take it completely for granted that somehow invisibly sitting in my home, I have a technology that I can just talk to. And it's interesting how that shapes habits. My 4-year-old and 6-year-old can't figure out why there are things in the house that they can't talk to. They take it as a default. And we saw a similar phenomenon a decade ago in the early days of touchscreens, when people assumed that you could make something work by tapping on a touchscreen, and in many cases you couldn't. We're about to see a generation who have the same expectations about being able to talk to everything in their lives. I highlighted this, but I want to come back to it because I think that this mindset about AI is actually something we've got to overcome. We don't want to emphasize its magical, mysterious properties. We want to be deeply pragmatic about it. But I can use it for this purpose to do this. How does it do it? Doesn't matter. Do you know how a steam engine works? No. Do you know how an electric motor works? No. Most people don't, and they don't need to. And this is an Arthur C. Clarke. Any sufficiently advanced technology is indistinguishable from magic. Very few people actually really need to know how AI works internally. We need to understand its characteristics. We need to be able to see what outcomes it produces. We need to be able to explain how changes to the data that's going into it will produce changes in the outputs. We don't need to know about how the guts work. This has been compounded because this is just one of a whole variety of challenges that are confronting top management. For many people, life has been brutally unfair. Just at the point at which I got to the late stage of my career and expected to be in charge, all the bloody rules changed. Along came, in the course of just approximately the last decade, smartphones, modular cloud services, which fundamentally changed the economics of IT, the Internet of Things, which hit one-on-one just about 10 years ago, AI, in this particular context, the machine learning and deep learning revolution, where the key benchmarks as recently are, when it comes to speech, 2010, to image recognition, 2012, and autonomous collaborative robotics. We've got a whole host of people out there trying to make self-driving cars work, and the first successful navigation, the DARPA-X challenge, was less than 10 years ago. This is several times as fast as the most rapid adoption of any other such general purpose technology. And again, I like my science fiction authors. Ian M. Banks, a Scottish author, described an outside context problem as the sort of thing that most civilizations encounter just once. And when they tend to encounter it, they encounter it in rather the same way that a sentence encounters a full stop. And this has been compounded by COVID-19. Along comes a virus that, while I'm dealing with all of the challenges that digital technologies are reaching on the economy and the threat from digital disruption, I have to deal with the highly disruptive epidemic impact of a pandemic. And in particular, the way that it has enormously reinforced the relative importance of digital technologies. We saw rates of change in adoption, diffusion of these technologies, which were orders of magnitude more rapid. And I don't think there's any going back. Everything we know about the adoption and diffusion of new technology says we've now, COVID-19 infected a lot of people. And as a result, we infected a lot of people with an understanding of the potential power of digital technologies and of alternative ways of working, and of how actually we can organize what we do in ways that are better. And thus far, one of the biggest challenges we face is, perhaps because of some of these reasons, far too few businesses are yet creating significant new value from AI. I'll come on to why that's so important in a moment. I found it helpful to think about the way in which you become digital excellent in sort of a set of stages. At stage 0, you're analog. You are just not even trying to become digital. And there are still some businesses and bureaucracies out there for which that is true. Now, these numbers have changed somewhat over the last few months, and I should probably update this slide to reflect the fact that nowadays there are some things you can still do, but candidly, if you've tried renewing a driving license or doing a whole variety of things, you will have discovered that many of the very analog parts of the world have just thrown up their hands in horror and said, I can't do that. The great majority of businesses are focused in this journey on just saving time and money, or at most enhancing the current core business. And stage 1 and stage 2 doesn't actually get you to creating significant new value. It drives down your cost base, saves you time and money, or it makes your interaction with consumers, your customers, more effective, which might gain you a bit of new revenue. But you don't target new customers, you don't launch new products on that basis, and you don't come up with creative new business models. And that's where the real value lies. If we want to come out of this and actually create new work and drive growth and have prosperity, then it comes from being a digital explorer, in making that transition. Ultimately, moving towards building platforms to support a digital ecosystem. And relatively few businesses have yet made that transition. And the rate at which this is happening is actually disappointingly slow. Perhaps if I was more of a realist, not necessarily slower than I would have anticipated, but it can and should be much faster. We're also, on the flip side, seeing some type 1 errors which are hazarding adoption. There's some recent research out there that suggests that 40% of the startups who claim to be using AI are not in fact doing so in any way whatsoever. And I'm really interested in people's honest, candid, off the record, if need be, in a private conversation. Estimates by me and by my colleagues at LBS and MIT who work on these sorts of issues, based on what are always off the record discussions necessarily with knowledgeable business leaders, suggest that nearly half of all the AI pilot programs should not be using AI at all. The business problem would, for example, be better addressed by conventional data science approaches, or even in some cases, just simple frickin' regression. The budget for an AI pilot was, however, available, and that creates a concomitant problem. The characteristics of the data sources, which tend to be data hungry, means that you should have used a conventional data science approach on it. You don't really have the data to use AI in anything other than a very suboptimal way. And that leads to well-warranted skepticism about the actual benefits on the one hand, so we're hazarding our own adoption, and it diverts scarce talents and resources away from the opposite applications. The good news, and this is probably the big key takeaway from my overall presentation, a set of real-world learning, and I try to distill things into one set of, I think it's 9 points. Don't focus on the technology, even though it's not absolutely amazing. We should be shifting the innovation trajectory amongst people who are producing AI platforms and services significantly towards increasing ease of use. We're already powerful enough. The adoption diffusion problem is one about ease of use. And rather than start with the technology, begin with the right problem and the right people. Start with the team. It actually takes human intelligence to unlock the potential. And then go after the largest potential payoff, explore iteratively how you connect that to relevant and robust data sources, and then run low-cost experiments.
Cool.
two other big takeaways from the experience. One, it's taught us that in most applications, the great majority of the effort actually needs to go into the data engineering, getting the data in. And the other critical area of focus is the other end of the process, making sure that the algorithms are not just apposite, but they produce appropriate outcomes. We've got to embed an empathetic, an ethical, and equitable perspective into the very heart of the way in which we harness these technologies.
Michael, we have a couple of questions for you.
Sure, fire away.
Do you mind if I'll bring Matt into this, if I may? Matt, you've been looking at. We've seen questions being fired all over the place. Are you weathering the storm? What do you see? I think you're on mute, Matt.
Hello, Michael. Really interesting. Thank you. I just wanted to start with by asking, how much do you feel that experts override the decisions that are made by machines, or is it the other way and we tend to kind of blindly trust the outcomes? And how do we get that balance right?
I see a couple of things happening. I see really quite different ways in which experts interact with AI-based decision-making in born digital businesses and born analog businesses. If I am in a born analog business, what I see all too often is experts where they see a result which is counterintuitive, rather than exploring it and trying to figure out what's going on, rejecting it on the basis of their making a judgment decision that this is wrong. I can't name the company, but I saw an instance in which there was some incredibly robust analysis done that took a question about mortality and changes to the rate at which people are going to die that was very well grounded. At the end of the day, top manager looked at it and said, you know what, we get it, we're just not going to act on it. In born digital businesses, which are very, very much data-driven, there's an assumption that I don't let my judgment override what the data tells me. It will lead me to being intensely curious and trying to figure out why and testing the different scenarios. So I don't reject it. It makes me go find out why it's doing that, right? And it leads to exploration rather than rejection. And it's quite bizarre how different the two sorts of organizations respond to that. Did I answer your question?
I agree. But it's the classic question of if there's a difference between the math and reality, pick one.
Yes, yeah. And people who work in these areas in businesses go, I accept the result. Why?
I think my colleague Ian has a question, so I'll just add him in.
Perfect.
Hi, good morning. I'm Michael. Yes, again, a most interesting talk and presentation there. But a question from Henry, or an observation from Henry very much. Isn't this case of AI being magic difficult to adopt and slowly spreading in management, the same as any innovative tech, like innovator's dilemma? The same with steam engines or other magic. So I guess really what Henry is saying there is kind of how best do we ensure that senior management and other decision makers appreciate the potential value and innovation that AI can offer? How can they move their businesses forward?
I think there's a huge amount of truth in that. It's inherent in the characteristics of most technologies that it just takes time for people to become aware. Here's the issue and why this is so important. These are, relatively speaking, extraordinarily general purpose and powerful technologies. If I'm going to use a historical analogy, you can run the numbers, and the short to medium term economic impact of the combination of digital technologies is give or take an order of magnitude higher than we saw the impact that either electricity or steam had on the contemporaneous economies. Secondly, it's happening 6 times as fast. So as a transfer function, I've got a transfer function which is running conservatively 30 or 40 times as fast. There is no generation of management who's had to deal with the fundamental economics of their business being stripped away right in the middle of the career. And it's fascinating. There's a Kiwi phrase which I hope translates, which is "cry me a river." And I found myself using it in the following context. If you don't happen to already be within 3 or 4 years of retiring, then you're going to have to deal with this shit.
Wow, that's amazing. I've just brought Mikko Terho on board. So Mikko, from Finland,
hello, good morning.
welcome.
Hey.
And I believe you know each other quite well, Mikko and Michael.
Yeah, we know each other. Actually, three of us know. So that's probably the only reason I'm here is Peter. This is my last pro bono stint during my holiday. Now I hope that calendar is empty next 2.5 weeks. So.
Well, Peter, I have a couple of slides to wrap up on. Should I quickly cover those off?
Well, we're just coming up to 9:30. We have a panel at 11:30. Michael, do you mind taking those slides in that panel at 11:30? Do you think that's possible? Are you going to be awake?
I may or may not be there for that. So let me take them. They'll take 2 moments.
All right, sure. Go for it.
I was going to talk about how you and I met, Peter, and how we figured out smartphones were good, but it took 15 years to make them easy to work. 2 things I want to highlight, which I'm currently doing. We will be launching in the next few days a new online open program at school on the business of AI, very focused on how you actually create value. And I'm also the co-founder of a startup which is leveraging AI to actually accelerate drug development by processing very rich data streams in the home locally rather than tracking them all back to the cloud. So we didn't have the right data sources, so we set out to figure out what data would we like to have to be able to run the algorithms on. And you're wondering why it's called Wicked Smart? Well, because originally it was a smart home startup where we were going to apply this processing power just to try and figure out what made rich people in apartments happy. Turns out that there's a very different application of it, which is in drug development. So that's wrapped up what I have to say, Peter.
Cool. Really cool. In that case, I'm going to be brutal, and I think I'm going to disappear and leave the floor to Mikko. And so, Matti and Michael, thank you very much. Matt and Ian, I think you'll be back for the Q&A for Mikko. And Michael, if you're awake, we'd love to have you on that panel.
Okay, we'll see, cool. Peter.
See ya. The floor is yours.
Okay.
Let's see. I'll just add the. That's I think where you're heading.
Yeah. Thank you for the director. So now this is what I expected. So
perfect.
I'm very happy to have my half an hour speech, and as I already said, I'm an ex-Nokia person in Huawei, and my story is about Huawei AI available in Europe. My call to action at the end is very small, but I think the best call to action, if you want to cooperate with Huawei Atlas, is just contact the so-called Huawei representative office in your respective country, and we are investing very heavily on AI. I'm sure they find a person who is in charge, and don't be kind of annoyed when the person in charge pops up that they are really to serve you, and despite of the first encounter, I'm pretty sure they arrange the things the best. This has been one of the surprises when I joined to Huawei. I started to question that why do customers buy from us complex systems and all kind of things? And one of the answers I got from the Scandinavian carriers is that they got the answers pretty soon from us. So I think that for an organization like us and with an Asian flavor, our turnaround time is surprisingly low. I mean that usually everyone clears their mailboxes every day and answers come to the customer the next day. And one of the reasons is that we have 180k people, and we are saying that we have 80k people in R&D. And a little bit to tell that we are all over. And for the career business, I think that the easiest fact bite is that if Huawei goes away, 1/3 of the internet goes away. So 1/3 of all bits that travel in the internet at some point of their travel, they hit Huawei equipment. Enterprise is our new investment area. This is also where the AI is located. In some locations, it's called like a Huawei cloud business. And the funny story about the enterprise is that inside the enterprise, we also have Huawei Power. And the Huawei Power came into life that the Chinese engineers, they connected our base station power system the other way around, and it turned out to be a better inventor than the solution done by the current incumbents on the marketplace. Now it's very big, I think 5 billion business for us, just these powering systems and solar fields. I mean automatically controlled solar power plants. Consumer, our situation is tough, but we still maintained, due to all kind of anomalies in COVID-19, to be the world's largest smartphone vendor first quarter 2020, because everyone was low. We expect to be anyhow in, I would say, good financial shape, and the markets in Asia, they are not so disturbed as our markets in the West. Here are some numbers about Huawei, and numbers are very important for the top management. When I started at year 2013, they said that our target is to reach this $100 billion mark, to be larger than some of the American companies. Now we are that large. And here are some numbers. And last year, almost half of the business came from the consumer or smartphones, the R&D part I am working on. So this is now under heavy pressure on some markets, Europe and US. The things what are different from Nokia is that in Nokia we had a thing when it started to go down, that the R&D percentage should be 8% and not more. In our company, it goes first that the R&D percentage is above 10, and rest of the business can be something else. In 18, it was 14.1% of the revenue. And then on this type of global scale, the kind of the benchmark is the EU Industrial Scorecard, where we are number 5. And then we are also quite significant in Europe. We have 12K people, 2.5K in R&D and R&D centers, as I show in the map. We have two very focused R&D centers via Stockholm or Sweden, where we do wireless infrastructure or mobile infrastructure, and then Finland, Helsinki, Tampere, where we do projects or technology projects related to consumer devices. And currently in Finland R&D, where I'm the site manager, we have two locations. One in Helsinki, where we have 290 people. That's the old Nokia Research Center building. And then in Tampere, right in the middle of the university, 80 persons in a new building, and the teams are imaging and audio. They are the old Nokia Microsoft teams, or some part of the old Nokia Microsoft teams. And here are my teams in Finland. Device concept, they do, I would say, form factor innovation, material innovation, quite comprehensive programs. PDE is testing for manufacturing. Security is the cyber security for mobile phone, the trusted execution environment, and so on. We have also contributed a lot to Linux security. When I have a secret software lab, antenna lab, RFIC, and audio and imaging, I said. And the units that in our part have AI, they are audio, imaging, and then with EU cloud service, they run the services that are in Huawei phones, Teams, video, audio, and they are working on recommendation engines using AI, and then they are using AI to filter kind of not allowed or undecent content out from the network. We have also explored a lot on AI on cyber security, so that the AI detects like anomalies in the system, and where we can investigate that is where an security incident. But the topic I am going to talk about is the Huawei accent or introduce or Atlas AI processors, and we have our own AI processor like the TPU of Google, IBM True North, and so on. Here are some performance numbers. There is like a big chip and small chip, and the medium chip is used in the DDK or the development kit I am going to show. I think NVIDIA introduced even a newer processor, so we may have better numbers, but these are our numbers. And the uniqueness or our own IP is the so-called Da Vinci Core, which is this type of quad processor which can be configured on a fly. So the best performance out from the system comes if you are able to program really low level this device, but Huawei engineers try to do this for you. And it can be used as a scalar unit or vector unit, or then this type of cube unit, depending on the micro instructions that are given to the core. And here is this type of hardware-orientated picture for the development kit processor, those who are interested. The development kit in itself contains Raspberry Pi style extension pins, so you can use Raspberry Pi peripherals to build the initial MVP or your demo and get started AI on your own industrial or other topic. And here's just the view of the kit, and most likely if you contact the representative office, their offering is to start working with your problem and give you the kit and when you go. And here is one more illustration, and then the programming environment we have done is at this point of time called Mind Studio, and here is little bit more how that is configured. The software on the NPU or the neural processing unit that is available in open source in GitHub. One more picture, and here is more precise instructions to work on the device. And one more of this example of the facial recognition. What you do, you connect the camera, and when you prepare the system, and then you run the algorithms on the box and get the results you are after. Then the Huawei AI stack that is named to be MindSpore, or actually there are very, very many names, and then this largest AI processor which is used for training is called Accent 910, and then there are other solutions like the Accent 310 for the development board, and then at the left there is a chip called Kirin, and the Kirin is the mobile phone complete SoC with much more functions, but that usually also contains one or four of these cube processors, and it can also be used for AI. Probably the mobile phone AI is easiest, not really, is easy to start, but it has a different website than the other solutions. The websites are at the end. And we try to facilitate that everything would be easy to do when you are following the instructions. That is, I guess, pretty much the way the Asian culture works, that follow the instructions and get the results. Here are kind of targets, I would say, for our architecture, what we try to do for the customer, like automatic tuning, automatic parallelization, and automatic differentiation. And here are a little bit more pictures about the solution we have done. And here we try to make a normal coder to be able to use AI or to use a mathematical expression. And then if you want an ultra high performance, then you have to go to this accent native execution engine. I haven't had yet the stamina to do that. And this is probably a little bit better picture about the software. And to put it short, there is TensorFlow support, PyTorch support, and Cafe support. And to my surprise, in Asia, the Cafe seems to be more popular than TensorFlow. And then in my own unit for image processing, we are mostly using TensorFlow, or almost exclusively using TensorFlow for those problems. And then if there are kind of academic partners or these type of people who are deeply interested in, I would say, hacking and AI, then for the layer that is called CANN, like the chip operator library, where our Atlas business unit, we have development monies to develop improved chip operators to optimize the performance for specific applications. And then our offering from the cloud or starting from a cloud is very similar than the Google offering. Here are some examples about the medical processing you can do on the platform, and then kind of the web user interface for the data preparing tools. Same way here, and here is introduced the automatic labeling for the data sources. And then here is similar feature mining that is kind of automatically put into the system, so you can go forward. Then model training can be done in this Huawei cloud or in this MindSpore system. There are a number of preset models you can try to use for your own problem. And then there are tools to measure the performance you could get. I think the subjects they are comparing is fast AI on AWS and Alibaba Cloud. And then there is this type of Mo mixing tool to to test and improve the models automatically. Here are some other screenshots of the tool set. And when I think that the strongest point of the system is that there are also ready-made edge products that can stay on the field. So this is like end-to-end solution to build very big AI systems. And we have ready-made libraries in the area of image processing, traffic control, and these type of applications, like the road traffic infrastructure called ETC, where we have ready-made solutions for all the current cases that the communities are deploying. And then we have created an AI marketplace, as every respectable vendor should do. Here is one example of the rainforest sound classification, and another example to identify flatbeds and dump trucks from each other. And then there are some automatic driving related things. We also have an automotive strategy where this is built into a product called MDC 800. And our strategy, at least in the Chinese market, is to build all electronics and power except batteries that are needed for electrical cars. All this stuff is, of course, available on Western markets if you have interest. And here I just show one picture about the mobile phone. So the dual NPU here is 2 Atlas processors or Da Vinci cores, as I outlined in my presentation. And when I think that this text is very small, so for consumer device, the thingy on the right, the correct keyword is high AI or consumer high AI. And for the left side of things, the correct keywords are MindSpore open source and Atlas AI product family. But my recommendation for those interested is to contact the representative office, and if you are still interested in October, I can be sent email mikko.terho@huawei. Not October, August. So I don't have that long of a vacation, but I'm in a need. Yes. Okay. Hope it's
It's a fascinating presentation, Mikko. And I was thinking about sort of the cultural things that you and I have gone through. So we worked together at Nokia during the early days, and the atmosphere in Nokia back in those days was very much just dead and let's go do it. That type of atmosphere. And then I've worked for a couple of big banks. I've worked for a couple of different types of companies, and we've been doing separate things. And now coming back to Huawei, and in this post-COVID world, do you find in this post-COVID world that in a way companies are beginning to behave the way that people behaved at Nokia in the early 1990s? That people are just doing it. Things that were impossible 6 months ago are now happening in 2 weeks.
Yes, we were very well prepared, I mean Huawei, for the COVID-19. And the difference to the other companies I have been that we have never had any I would say, management meetings where people travel. We always have a web option or the cloud option. But the good things what happened is that our software team were under certain type of internal security ideas, which we tried to say that could be changed, and I worked on that 8 years, and now with COVID, those pleasant changes happened in 2 weeks. I mean is that also for the high security areas, we can now do software work remotely, which has been a request of many European developers. So at least that was on the positive side. But many of the teams, they say that this is negative to team spirit, that they really want to work together, and many of our problems are complex. There is a long desire to be back in office. Not in my case, because I'm this type of solo expert, but two kind of things. Software people like it. We other people want to innovate together. So,
Nico, just quickly, and thank you very much. I've played around a little with Python and Julia and sort of image recognition, and it's sort of surprising how easy it is to, this concept of adversarial attacks and how you can take an image, change it so that a human can't see any difference, but it can fool a machine. How worried do you think we should be?
Well, I think that for an expert, it is still very easy to fool the AI systems, but the expertise level of those people who put these questions to me, they are quite high, and I don't think we have any special remedy for these, I would say, adversarial pictures. And I don't think anyone at this point, I haven't seen this type of open source of this type of adversarial pictures. That is probably one of the biggest problems that we could jointly work on to generate this type of adversarial pictures that the system should avoid, that these are full stories that discard them. That is a very good topic to work on. Almost anyone can find a good example. One of the very good examples are these T-shirts with traffic signs.
Yes,
they cause hell of a problem.
I can imagine. Andrea, I can see that you've joined us here. Andrea, good to see you. Andrea, Mikko, cool. So, Andrea, we've kind of waded into your time here a little bit. There was so much fun stuff to listen to. Mikko, if you are available at 11:30, you're very welcome to join us on the panel. I suspect that you're going to hit the beach instead and just enjoy your vacation.
No, the sauna is just downstairs. I have to take 30 steps and go to swim. So
okay,
that's my preference.
That's the challenge.
Fantastic.
So, Mikko, in that case, I say thank you. Enjoy your sauna, and really, really great to see you. Really, really wonderful to see you.
Yeah, and I also wish best to Objectivity and its efforts on the area. But try to find a customer you can work Huawei with.
Okay, we will do that. We're going to do exactly that.
Thank you.
All right.
Okay, thank you.
Thank you. Thank you very much.
Hello.
Right. Here we go. So it's getting serious now. Andrea, it's really welcome here. I've got Matt here as well. There are going to be loads of questions about your presentation, I guarantee it. So it's really good fun. I'm going to add the presentation to the stream here. And Andrea, it's probably easiest if I simply disappear and if Matt just disappears for a little while, and then we play it from there. So, Andrea, the floor is yours.
Thank you. So, firstly, I hope everyone can see my shared screen, my slides. Wait, let me check if I can also simultaneously check. Yes, okay. If there is any problems, Peter, maybe ping me on my mobile because I'm in full screen mode myself.
If there are any problems, I'll just jump in here, and I think Matt would do the same. Matt, are you ready to give us a hand if we need to? I think you're ready.
Okay.
All right, cool. No worries. We're here in the background, I assure you.
Perfect. Thank you very much, Peter, for inviting me to this event. I suppose my presentation is going to be a little bit different. Firstly, because I actually, don't have a background in AI, and I'm sort of offering more of a perspective from somebody that sees a lot of AI through the prism of physics research. I am the chief editor of Nature Physics, and I think it's fair to say that actually, we talk about black boxes in AI and computing generally. I would say science journals are the ultimate black box. So before sort of delving in any further into my perspective, I thought I'd give a very quick summary of what it is that we exactly do, so you have the context for interpreting what it is I will say later in my short talk. So Nature is it's 150 years old as of last November, and it's essentially a publisher of scientific results which has a dual purpose, and it's been like this ever since it was first founded in London in 1869, and that's the mission which I will read actually. The mission is to place before the general public the result of scientific discovery and to help scientists to learn about advances in all branches of natural knowledge. So that's on the one hand helping scientists talk to each other with their latest results, and on the other, and I think this is a key to the historical strength of Nature, is to help celebrate these results so that the wider public can appreciate them in the same way it might appreciate, great art, great theater, great architecture. This is a more recent issue of Nature Physics. It's of Nature, which went out last Thursday, and this is our website last night. As you can see, we cover everything from what's going on in Mars, COVID, of course, physics. And I might quickly advertise as a Nature briefing, which it's just an email that you'll get every day, and it's free, and it's very good if you want to keep up with scientific results. Now, just, we have a very proud history, and I just want to go through it. Again, this is to give the context for...
Andrea, just a second. I lost your screen there for a moment, and I don't think... let me just see what's... do you mind? I'm just jumping in here.
Of course not. Sorry. You lost my screen, really? Okay.
Yeah, let's see if I can get that back.
Where did you lose it? Oh, is it back?
There it is. There it is. Cool.
Okay, perfect.
Just for a second, I lost the screen. Sorry, I do apologize.
That's fine. Cool. So as I was saying, I think it's helpful to give...
It's gone black again. Why is that black?
Again? Why is that? Maybe it's just very slow.
Now it's working perfectly beautiful.
Okay.
Now it's black. Now it's black. Now it's not black. That's strange.
Is it jumping up and down?
Yeah, it's black at the moment. Are you doing full screen, or are you doing?
I am doing full screen.
I would probably not. Maybe not do the full screen version if you.
Okay.
There you go. Yeah, just run it from there, and that's easiest because we can see it really well. We can see it really well.
Okay. All right.
Cool. All right. I'll let you go. Keep going.
Thank you. Peter, just to say, if this problem continues, you can just fire them up from your computer or from Izzy's computer, and we can go from there. I sent them to you this morning, just in case this problem continues.
Definitely.
So as I say, the history of we've published a lot of great science over the years. That's the point, and I think we're seeing AI is now reaching that kind of level as well. So to give you some examples, we've published discovery of radioactive decay. The discovery of an ancient hominid by Raymond Dart that basically helped us understand really a lot about where humans sit in sort of the history of their evolution. In the early 30s, James Chadwick announced the discovery of the neutron. We also more recently, this is now slowing down on my side, excuse me. Yes, the most famous paper that's basically associated with Nature is the discovery of the structure of DNA. And it was actually 3 papers in a row. Watson and Crick most famously are associated with it, but also Maurice Wilkins and Rosalind Franklin did much of the work that they based their discovery on. In the 80s, we had the discovery of Buckminster fullerene. And in the early 2000s, the sequencing of the human genome was announced. So we're talking about really sort of huge scientific discoveries that had global impact and led eventually to quite big technological breakthroughs. We've also, of course, had some big misses over the years. That might include, for example, the Krebs cycle, which we rejected when Hans Krebs submitted it, the beta decay process by Enrico Fermi, and my personal favorite is Ivan Pavlov's obituary, which we published while he was still alive. So it came as news to him. Final sort of slide on what it is that we do at Nature. We have full-time editorial staff that will assess and vet hundreds of submissions. We'll then send them out to peer review to specialist experts to help us assess the technical validity. And then we will help edit them and make them as sort of accessible as possible and publish them on a global platform that then gets picked up by the popular press and the media. So we really aim for, Nature publishes weekly, and we really aim every week to publish, some big discovery, be it a giant dinosaur or some, possible cure for cancer, or, as we'll see, developments in AI. I should also mention that I am myself the editor of Nature Physics, which is kind of like a slightly niche little sister of Nature. We focus on the most important results in physics. We don't really care so much about what biologists think, provided a physicist finds what we publish interesting, we're happy. But the principles are essentially the same as those I've just described. Okay, so with that done, I'll now move to AI itself. I think Michael gave a very, very nice introduction to well, really, I suppose the economic, the social, and also ethical implications of AI that they've had over the past sort of decade and will have in the future. And he mentioned quite rightly that AI has firstly, the term AI is used very loosely. I will also interchangeably talk about AI, machine learning, interchangeably. I probably mean machine learning more than AI. Also, cybernetics, AI, all that jazz started really, I think, in the mid-50s with the development of computer science. I will pick this story up from the perspective of a Nature editor, which is really really this happened in 2015. We started realizing, a few colleagues, myself and a few colleagues, that actually we're beginning to get some submissions where the actual numerical techniques being used to analyze the problems are to do with machine learning, neural nets, and so on and so forth. And so we published what's called an insight, which is essentially a collection of reviews which cover all the big ground that's being discussed at the time in the scientific community. This, if you remember back 2015, there wasn't really much discussion yet in the public sphere, outside of engineering and science circles about artificial intelligence in the way that there is now. People talked about the Internet of Things, they talked about big data, but it was a kind of there wasn't yet this sense that, as we have today, that it's totally revolutionizing sort of how we do business. But we really started noticing a change in 2015. That's what I'm trying to say. And this insight that we published, I think, had a very big influence for scientists as well, who suddenly realized, okay, this is also a thing. We can actually start presenting our work within the context of artificial intelligence. The year after, sort of a very, I would say, significant milestone was published, which is DeepMind, Google DeepMind presented results of AlphaGo, which could learn how to play Go basically better than the world champion of Go. And it was, hark back to IBM's Deep Blue beating Garry Kasparov at chess. Well, here we have a far more free game, if you will, that a computer could essentially learn using the techniques of sort of deep neural nets and beat the best human player in the world. This, I think, in 2016 had a significant impact. There's this working paper which I came across a few years ago by an Oxford researcher, Jeffrey Ding, and the reason why this had a very big impact, it's interesting if you think about it in today's context of the current geopolitics. AlphaGo being beating the world champion at Go essentially acted as a Sputnik moment for the highest levels of Chinese sort of research establishment. It was at that point that it became a high priority for the Chinese research establishment to get serious about AI as well. That's not to say they were not already investing heavily in this, but the point is, I think it had some sort of an effect that, oh my God, this technology, this is now an arms race, and we're in it. Focusing more on physics, and this is the thing that I think Peter is interested in hearing from me mostly. I think it is an interesting development that. So how shall I put it? In physics, we're used to using what are called generative models. So that is to say, we typically have a model, a kind of a caricature of reality, that you can even use to generate synthetic data that actually mirrors quite well what's going on in your experiments. So as I sort of, I'll quote this article by Jeff Byers, a researcher in the United States. So physicists are accustomed to dealing with large data sets, yet they're fortunate in that the quality of their experimental data is often very good. Now, the onset of big data has led to an explosion of unstructured data sets with a far more complex structure. And this, the point of this perspective was that physicists need to change their mindset. And we're really starting to see this sort of actually being applied to modern research. I'll give you some examples. I think it's helpful for me to quote from this article directly so that you have an idea of where I'm coming from. Yes, so the point is, in the physics of data, I've highlighted this thing. You think of physics as very clean experiments. You're measuring, have a very clear scientific question in mind, and you're trying to understand, for example, I don't know, how a magnet goes from being magnetic to non-magnetic, and so you will interrogate. You'll measure the magnetization as a function of temperature. That's a very clear experiment. If you're Amazon or if you're Google, you're just collecting billions of user interactions, of clicks. You have a hugely unstructured data set. And actually, you don't really have a model for understanding, how things are correlated to each other. It's a far more messy situation. This is actually very uncomfortable territory for the average physicist. There is no model. Now, as Jeff Byers says at the end of his perspective, of course, physicists can do anything, so they can still deal with this. A very nice example of how this has been used in physics is, if you consider the example that I have of a magnet basically is a huge sea of electrons. The electrons interact with each other in highly complex ways that are mathematically intractable. You cannot possibly solve the equation for understanding all the electron correlations in a material. We, in 2017, started realizing that, well, people are using techniques from machine learning to actually get a grip on this problem, and they can sort of use machine learning architectures such as fully connected and convolutional neural networks to identify different phases. So when the electrons are all correlated in one way, there may be it's a magnet. If they correlated another, maybe it's a superconductor. These techniques can now be used routinely to essentially predict the properties of materials. This is quite a big step change in the sort of capability that material scientists now have at their disposal. Yeah, this paper made it on our cover. There are other examples which I think are actually a little bit closer to maybe what is it, excuse me, quote unquote, real world scenarios. So, for example, in astronomy, where again, you know, you're taking a what's it called, a telescope, looking at up the sky, looking at, you don't really know what you're looking for, and so the analysis techniques that have been developed in astronomy and in particle physics, which require enormous volumes of data, it's now a huge part of these communities' efforts. Again, this is happening in, I think this is a white paper from High Energy Physics in 2018. There's also a very recent white paper for astronomy. These fields are completely embedded machine learning techniques are completely now embedded in these fields, and they're actually at the cutting edge of developing the sort of tools that for example, Mikko also described, things like TensorFlow. All of these techniques are now increasingly, they're just part of the scientific analysis toolbox. We, again, just to illustrate how much things are moving, we even felt compelled 4 years after this insight I mentioned, we now have a journal which is dedicated to we call it machine intelligence because it's dedicated to machine learning, to robotics and AI. It also explores the impact on society and industry. And it's a platform to discuss the ethical, social, and legal implications that we'll also hear from other speakers later today. You know, you'll notice this journal was launched only last year in 2019. So we've gone from a situation where in 2015, well, this seems interesting, there's something developing, let's publish an insight to see whether scientists find this interesting, to 4 years later, we have a whole journal dedicated to the area because scientists are, because there is now a fully fledged community that needs an outlet to publish its works. The final point I wish to make is really one that I think has so far not been fully appreciated. And that is the following. It could well be that the biggest beneficiary of machine learning techniques is actually science itself. You know, we heard a lot we heard from Michael this morning about implications, you know, for business, for economics, for society. I've just described to you how, well, yes, these techniques are also used in science. The point is, it seems like some of these techniques are actually radically improving the capability of various scientific fields. I put here one example, which describes up to 2 billion times acceleration of scientific simulations with deep neural networks. With deep neural networks. The picture I show is essentially weather forecasting. So simulations that take 1.5 months to run on a normal computer. These guys show they can do it in a matter of 110 million times faster with comparable accuracy. This, for analysis of turbulent flow, so weather systems, you can think of plasma fusion, all sorts of various physics. If you can reduce your simulation times by this amount, well, that I would say is the definition of a game changer. With that, I think I'm at the end of my 20 minutes. Is that right, Peter?
It's brilliant. It's absolutely brilliant. I have I have one comment I'd like to jump in with. Let me just add, this is Anthony who's going to be talking in a second. So I'll just add Anthony to this call. And I'd also really like to add Matt, because Matt has a bunch of questions for you as well. If I could just make one little observation first, then that's that. So we have been looking at a couple of things within objectivity in terms of how the world is changing around us right now. And you can look at this from the perspective of penetration rates, or you can look at this from the perspective of market caps or sales or what have you. The thing that I'm using here is just the market cap. So in 2008, the market cap of the top 5 public cloud companies was $14 billion. And in 2015, it was $114 billion market cap for the top 5. Now in February this year, the market cap for the top 5 was $660 billion. 1 trillion total if you look at all of the main companies. Incredible growth. And from an objectivity standpoint, we've been seeing people moving from being purely on-premise with the way that they think about software to being on-premise / cloud. And they're not only thinking about software development and how to maintain software, also thinking about data and how to maintain data. And Michael spoke this morning about the need for required, relevant, and robust data in order to automate things and so forth. Cool. That incredible acceleration we're seeing is actually something that you're seeing in the field of physics. That was a long way of getting there. Would you agree that there's this incredible acceleration right now in AI and in the use of these technologies? It's just unbelievable how big this acceleration is.
No, well, that's correct. Yeah, and I realize I perhaps should have actually shown some plots like that to illustrate. Just if you do a search of the volume of papers with things like machine learning, neural nets in the title and the abstract, yeah, the growth is similarly, exponential. What's very interesting is that this step change, at least in areas such as condensed matter, fundamental physics research, it really seems to have occurred in the past 5 years. It's gone from, it was almost a distinct field where maybe some people in computer science, that were really deeply into that stuff were plugging away. All of a sudden, a lot of these tools are being adapted for very, very fundamental physics problems. And in turn, they're making sort of, they actually make big headway for possible applications on top of that. I think that's essentially my main message. And the other issue is really just noticing how, I think it's fair to say nature, ultimately we reflect what is going on in the scientific community. The very fact that we are now, we went from, that DeepMind paper is essentially, I would say, in the same pantheon of great papers like the DNA paper, like the discovery of the neutron. It's at that level of, wow, this is changing, this is moving the dial of what, technology can do, what humans can do, even augmented by machines. And off the back of that, we're just seeing, I think, we're reflecting a real change in how the field is, well, how much importance is attached to the field, put it that way.
It's amazing. We have time for, I think, one question, Ian and Matt. I just want to note that Matt is a heavy-duty mathematician who went into software, and I very strongly suspect, Matt, that you're going to boomerang straight back into physics in the future again. Matt.
No, it was fascinating stuff, Andrea. Thank you very much. Just to expand a little on what you said, on my bucket list are things like some of the great unsolved mysteries, and I hope they get solved within my lifetime. And how much do you think that AI can truly help us with things like what is dark matter, or do neutrinos actually have mass or not, or what is this thing we call gravity?
No, I think in that regard, and I'm sorry I didn't have time to delve into that. I didn't really, but that is, I think. so it's hard to give a sort of a definite answer. What I can say is the following: is these sorts of questions require large-scale collaborations in order to be addressed. So we're talking about really big international laboratories involving hundreds of scientists, engineers, and also the management is a problem in itself. Now, what we're seeing is should we say, the analysis of the data, the computing problems that these experiments raise are, I would say, a far larger proportion of the workforce than they have been in the past. So, when it comes to the detection of gravitational waves, for example, yes, the technology, the scientific technology, to make the experiment was remarkable, but the analysis side was in itself something that was not possible 20 years ago. So, we can't predict what discoveries will be made, what questions will be answered, but I think we can be confident that they will be answered with the help of, massively powerful computational resource and algorithms.
Thank you.
Fascinating. We're just coming up to 10:30. Anthony, you're nearly ready for the show here. Ian, you've been looking at all the questions. Are there any particular questions that stand out for you?
I think there's a key. Again, Henry's raised a very interesting point regarding the presentation. It's obviously we're doing a lot of analysis, interpretation of the data we're seeing. There's an inherent risk in some of that data because quite a lot of the models are black box. So do we really understand, and can we understand what they're telling us?
Yes, I think this goes back to the issue of distinguishing between generative models and ultimately discriminative models. So the scientific method is based on the idea that you have a model, a hypothesis, you test it, and if it's a good hypothesis, you should have been able to predict the test, the result of the test. Now, the machine learning approach it flips that on its head. It's almost like an anti-physics in this regard, where your data provide you a mechanism. You're actually inputting the data into your computer, and then you let the model fluctuate around the data, as it were, and sort of using Bayesian techniques and so forth, you then converge onto a sort of an appropriate model for your data. I think the issue of black boxness, if you will, is one partly to do with people are a little bit unfamiliar with these techniques and them. And the second thing, I think, and I hope that this will come up in the next talk, I think there is an awful lot of thought being put into counterfactuals. So essentially this idea that, okay, you run a particular neural net and you get an outcome. What needs to be different for that outcome to be different? For example, a simple example is, I don't know, you're asking for a mortgage, and they input all this data, your financial data, and they give you a result, which is, okay, we'll give you a mortgage of this amount. What needs to change for that amount to change? I think this counterfactual mindset is one which is increasingly being adopted and appreciated, so that you can somehow, open the black box a little bit. I hope that goes some way to answering that.
It does. It's a fascinating thing. We have a panel at 11:30. Would love you to join there, Andrea, if you have time. It would be fabulous if you could. Anthony, we're delighted to have you with us here. Anthony, it's probably easiest if we just disappear and let you have the floor here for a little while.
I'll put up my slides quickly, and then obviously if there's a problem with the slide sharing, you can jump back on and let me know straight away.
Sure. Are you opening your slide deck?
I'll just do that now, and then you can tell me whether that's all working at your end or.
Or if you can do this screen sharing, that would be wonderful.
So is that? Can you see my slides?
It's there. We see
them?
them. Okay, we're going to start backing out, and it's wonderful. Okay.
Great. All right.
Thanks.
I'll just stop sharing them now whilst I introduce myself.
Good.
So, Peter, thanks so much for inviting me to participate in this summit today. So, by way of background, my name's Anthony Lee. I'm a partner in the law firm Rosenblatt. I've been practicing I've been practicing as a commercial lawyer, and a lot of that in the technology space for thick end of 30 years. So these developments and this sort of game-changing moment that we have, it's obviously very much at the heart of the practice and the role that lawyers can play. And just sort of, you know, as Peter mentioned, if you look at cloud, for example, that's gone within a few years from being sort of a niche business application to truly moving into the mainstream with many organizations moving from on-premise into the cloud. And, you know, I think it's fair to say that machine learning and artificial intelligence is already very well established, and as Peter said, we're likely to see huge acceleration over the coming years. So I think it's just worth bearing that in mind. You know, it's well established. There are applications across a number of sectors, you know, ranging from financial services organizations looking to make decisions on whether to lend. The sort of Alexa example in the consumer space would be a good one. As people will be talking about later in the day, huge applications in the healthcare and medicine space, such as diagnostics. And as a good example of an application that can apply across a number of sectors, the sort of issues around image recognition, such as facial recognition being embedded into surveillance cameras. So it's very much here, very much here to stay. And the benefits really speak for themselves. Again, as with any product or service, there are potential downsides, and the sort of themes that I'm going to be talking about over the next few minutes would be, you know, who do you blame if thing goes wrong? It's the liability question. The sort of issues around potential misuse of data, particularly when personal data is involved. And I'll touch on it, but I think it's a theme that will be developed during the day, and one that Michael's already alluded to, the potential for AI and machine learning to perpetuate bias and discrimination, and how, you know, what the impact of that. So I think, you know, really to sort of the helicopter view would be the law has a role to play in ensuring that the benefits of machine learning and AI are realized, but at the same time containing the issues that are inherent in that. And I think it'd probably be fair to say, as usual, when looking at new technologies, the law does in many ways struggle to keep up. So at that point, I'm just going to share my slides. They are quite minimalist, you'll be pleased to hear.
I love your slides, they're always brilliant. They're real classics, I love them.
So perhaps I should be saying its key legal considerations rather than key legal issues, but there are some issues that we will need to look at, and then as we can develop later in the day through the panel sessions and the question and answer. Here we go. So the two that I'm primarily going to be talking about, but I also will talk about bias a little bit, are liability and privacy. Who do you blame if things goes wrong? As I mentioned, concerns over potential misuse of data, and the main concern there being personal data, potential issues around privacy, and how that feeds into this sort of issue, this sort of idea of explainable AI versus black box, which Andrea, which we're going to be touching on later in the session, and which Andrea mentioned a few moments ago. So when we're looking at the issues of liability, I think one of the things I just wanted to say is you know, there is obviously the question of what happens if things go wrong, such as a misdiagnosis of a medical condition, and we'll look at that in a moment. But there is a flip side to this coin, which I think tends to get lost slightly, is that you know, for example, with medicine, you would argue that it's imperative to use the most up-to-date and powerful equipment to help to diagnose a condition. So in that sense, it's not all right to hold on to steam-driven technology just for fear that things may go wrong. So, you know, there is an argument there that these technologies should be used, must be used, as long as you're satisfied that, or as satisfied as you can, that it's safe to do so. And the consequence of not using available technologies, provided that it's done so in a cost-effective way, you by definition potentially falling foul of your duty of care. So I think there is a flip side to that coin. But returning to the blame game, as it were, what happens if things go wrong? I mean, I'm going to talk about the existing legal regime that we have in the UK, and there are similarities in other jurisdictions. But the three main areas that you'll be looking at would be the area of tort of negligence, contract, and strict liability. All of those three require an element of causation. You've got to be able to demonstrate that the defect or the issue caused the loss or the damage, and that in itself can be somewhat problematic when you're dealing with AI and machine learning. So just looking, actually I'll talk about tort first up. Now, as I said, the law does sometimes struggle to keep up with technology, and it would be fair to say that the principal case, which applies to the tort of negligence in the UK and many other jurisdictions that follow a similar rule book, is a case which dates back to 1934, believe it or not, it was to do with snails in a bottle of ginger ale. I mean, that's so far away from AI. But the sort of three principles that came out of that, which still apply and will apply in the context of machine learning until we have an entirely different, potentially a different regime, is that the defendant would need to owe a duty of care to the claimant, the person that's been injured, damaged. That the defendant has breached that duty of care, and last but not least, that the breach itself caused the injuries to the claimant, which were foreseeable. And I appreciate that the case that we have there to do with a snail, decomposing snail in a bottle of ginger ale is very far away from this sort of Star Trekian world that we seem to be entering into of AI machine learning, but the law is still good. And I think that's where you again, we'll be discussing this through the day, but in many ways there are sort of more questions being asked at this stage than answers to those questions. But the sort of issues that you'd have in the context of machine learning and AI was the defect attributable to a design in the product, to the programming, to the way it's being used. And then if that product was deployed autonomously with limited or no human intervention, the establishing the causal link, which is at the top of the side, is problematic, as is establishing the foreseeability of the loss in question. But still, there is the potential for negligence claims to be brought in the context of machine learning and AI that goes wrong. So that deals with tort. The next one is contracts, and we have to dial the clock back a bit further here. So the main case on contract law, which still applies, dates back to 1854, Hadley versus Baxendale, but the law is still good. And what in that context, there would need to be demonstrated that there is a breach of an implied or express contractual term. So there needs to be a contract between those parties, which doesn't always apply, obviously, in the AI and machine learning context. And secondly, the breach of that contractual term, that contractual promise, as it were, caused losses, which again, like the tort situation, were foreseeable. Probably the thing to mention in the context of contract law, because I think it applies or it's relevant to the sort of ML AI context, is that there are big debates in the context of contract law over the extent to which consequential losses can be recovered. And when I say consequential losses, I'm talking about things like loss of profit and how that can be addressed in the contract. So again, you can see how in a contractual context, there may well be some debates as to whether there's a causal link between the defect and the damage in question, and the extent to which those losses were foreseeable. So again, there is a sort of a sense that we are in a somewhat uncharted territory here, and at this stage there are quite a few questions that remain unanswered. But again, that is the basic law that would have to be applied to the machine learning context. And then the third limb is the one which is strict liability. In that context, you don't need to show fault, you still need to show a causal link. It's based on European law, and what it does, it imposes strict liability on a producer of a defective product for damage caused by the defect. So again, assuming you can show that the defect caused the problem, a claim could be brought under a strict liability regime. So I think that all said, where does that leave us? As I mentioned, it leaves us in somewhat uncharted territory, but for the time being, those legal principles are here to stay. In the meantime, there is discussion about introducing some new laws to try and adjust it for the world of machine learning and AI. So, for example, this huge tome has recently been published by the European Commission on liability for artificial intelligence. Long paper, but it does look at things like adapting the duties of care, which is something I touched on in the context of tort, allocation of liability, and having some kind of presumption in there in terms of being able to prove causation. Now, as I mentioned earlier in the first slide, we were sort of the potential crossover with explainable AI and black box. So it would be fair to say that explainability or transparency is seen there as a potential vehicle for, in particular, assessing causation. But again, the debate that we have there is that you don't want the explainability to constrain the power of the tool in question. So again, there are some challenges in that context. So that's probably enough said on liability, but it is there is unfortunately you do have to look at the extent to which what law would apply where something goes wrong in the sort of the machine learning context. That's sort of a good example being a misdiagnosis of a medical condition. So the other thing I just wanted to touch on briefly is, as I mentioned earlier, there is the potential for data to be misused, particularly personal data. And in Europe, the main rule book on privacy is the General Data Protection Regulation. It's only been out for a couple of years. It replaces a piece of legislation that came out in the late 90s. It was a long time coming. But given that we're now into this acceleration phase in relation to machine learning and AI, there is a question as to whether the legislation has already passed its sell-by date. But for the time being, this legislation applies. And there are various principles. It's a pretty, again, another weighty tome. But at the heart of it, it has these concepts of accountability, being able to, as an organization that controls data, to take responsibility for that data, particularly where sensitive personal data is involved. And by the same token, be able to demonstrate to the regulators that you've taken responsibility and taken appropriate steps to protect that data. The second one, which I think is in the context of GDPR is another game changer, is this concept of transparency. So previously, the previous rule book said you had to process data. The first principle and the key principle was you process data fairly and lawfully. Now it says the first principle is you process data fairly, lawfully, and transparently. And what that means is that there is a huge emphasis at the first principle level of the regulation that people need to know what is being done with their data, and in that sense, the regulation is agnostic about the technology that's used for that. So, for example, and very relevant in the context of machine learning and AI, is that where a decision, such as a decision not to approve lending, is made used by purely automated means, you need to be able to provide meaningful information about the logic involved. And the Information Commission's Office in the UK, which is the UK regulator, says that would also be considered to be good practice where there is a human in the loop. And again, the crossover there with explainable AI versus black box is the more explainable the decision, the easier it is to fulfill the transparency obligations of the regulation. And again, I recognise there is a tension between, if you impose too many constraints on the technology, then you're not harnessing the power of that technology. So that is fully understood. And I mentioned a thick tome has been written by the European Commission on AI. An even thicker tome has been recently published by the European Parliament on GDPR and artificial intelligence. And there's a recognition that the legislation is here to stay. There's also an acceptance that in many respects it's a bit vague in its application, or this sort of interaction with artificial intelligence and machine learning. And the sort of the gist of it is that a bit more guidance is going to be needed by the various regulators, such as the Information Commissioner's Office, as to, you know, exactly what information are we supposed to provide here, because at the moment it is a bit of a vexed question. And I think the other thing that's worth mentioning in the context of privacy is that AI and machine learning is by definition very hungry for data, which means that sort of data, not just machine learning, but just generally the acceleration of technology means that huge amounts of data are being collected, oceans of data, and that does bring it with the potential for abuse and the potential for the data not being used for the purpose for which it was originally collected. You know, in the context of today, certainly not going to be naming specific businesses, but it's probably worth mentioning that the biggest fine today, which has been issued by in relation to breaches of the GDPR, is to do with personalisation of advertisements. And the concern there was that there was a lack of lawful basis for processing the data, i.e. the individuals concerned hadn't given consent, or if they had, they didn't really understand what they had consented to, and a lack of transparency, which is the point that I made earlier. So again, they didn't really understand you know, what their data was being used for and going to be used for. So again, it's probably worth mentioning that, because there is obviously, by definition, there's going to be machine learning going on behind the scenes there. And the other one that's just worth mentioning, there are plenty of examples that can be mentioned, is the specific concerns about embedding facial recognition, image recognition technology into surveillance cameras, and concerns over that by definition involves biometric data, your face, your data about your sort of medical data, as it were. So that's by definition sensitive, and that is an area that is a particularly protected form of data under the General Data Protection Regulation. So then again, sort of coming back to as I mentioned earlier, coming back to the explainable AI point, is obviously the more explainable the sort of the process or the outcome, then the more it resonates with the transparency requirements of the regulation. And I think it would certainly be very interesting, both in the QA and the panel discussion, to discuss that in a bit more detail. Because what you don't want to be in a situation where it's sort of seen almost as the dead hand of the law. We're in a world where machine learning is here to stay, and for very good reasons, but there are some areas where some controls are required. And then last but not least, the bias side of it, I'm just going to touch on, but you know, as Michael mentioned earlier, that the sort of potential that machine learning has for the perpetuation of bias in society, because it's sort of looking at data sets which exist at that time, and this sort of, you know, we do have in the UK, we have the Equality Act 2010, but there's sort of this idea that you need to start developing ethical frameworks to guard against the risk of the perpetuation of bias through the deployment of machine learning. A sort of good example being, again, I'm not going to mention a specific business, but there was one example I know of where a machine taught itself to basically filter out CVs from women because it had been taught it had been taught in relation to CVs that were largely relating to men, and the language that they used and sort of some of the references. That's what it taught itself to do. That project was binned, by the way, but that would be a good example of that. But again, there is that expression that's been used for years in the context of computing, and therefore applies also in the context of AI machine learning, is this sort of concept of rubbish in equals rubbish out. So again, I think it would certainly be interesting, certainly for my part, to discuss some of those themes around the guarding against the risk of the perpetuation of bias within society. I think probably at this point, if we got a few minutes to jump onto the questions and answers, because
that would make sense.
There are a few other points that we don't have time to discuss those.
Oh, it was fascinating, absolutely fascinating. I have a couple of questions. I'd like to lift in Ambika here as well. Ambi, I think you're out on a farm somewhere?
Not quite. I'm back in the city now. The Wi-Fi is reliable enough.
Okay, great. And then I've got Matt here as well. I mean, there are so many things I want to ask you about, Anthony, but I'll leave some of them till the panel session. But I mean, one of the challenges is this thing where if you have an environment where you have a black box here, black box there, black box there, and they're in different jurisdictions, and you have to prove who is liable, it gets kind of tricky. But Matt, you had a different question, I think.
So there are many questions, and thank you very much for an interesting chat. So I think the idea that something's legal doesn't mean that it's ethical, and I think the broad question is, how can we ensure that everyone benefits from AI rather than just those that create it?
So I think, very interesting question. So I agree that the law isn't, just because it's legal doesn't mean to say it's ethical. I mean, I think in answer to so I agree with that point. So I think in answer to the second question, or the second point, is what do we do to make sure that everyone benefits from AI rather than people who are just set to make huge profits out of it, I think is what you're saying. So I think one of the examples is the one that I touched on at the very end of my talk, is the role really that the law can play, and also the use of ethical standards, because they do in some ways go hand in hand, to making sure that there's sort of one very obvious application of AI is lending decisions, or whether or not someone's going to actually be interviewed having submitted their CV. My view is to create a level playing field, is to drive legal standards and drive ethical standards into the machine learning in some way to guard against that risk. So that would probably be one example of that.
Thank you.
Cool. There's so much I want to ask about, and the touch points between the work that you're doing, Anthony, and the things that Ambi are doing are huge. Not least the point you made earlier, where you alluded to the consequences in some situations of not using artificial intelligence, is actually that you fall foul of your duty of care, which is from someone who, like Ambi, is in the area of medical. Wow, that's a big statement. That's a big statement. I'd like to bring in Ambi now, and Ambi, you have some unbelievable things to talk about, and I like the maths in this. As you know, we've worked on this closely together. Really great fun. Matt, is there one question you'd like to pop over to Anthony, before we shoot on, or Ian, do you have a quick question for Anthony, or shall we leave it over to Ambi?
So I'm good. I hope you're there on the panel session, because there are literally many topics to inquire about.
Well, I'll be sticking around for the panel session, so
fantastic.
Happy to.
Perfect. All right, in that case, I'm going to disappear off the screen, and let's leave the floor to Ambi. Let's see what you've been up to.
Great.
Thank
Thank
you
you
very much, Peter, for inviting me to this symposium. And some of the talks have been really interesting. I've managed to log in whilst feeding my little one breakfast this morning, and it's been really interesting. So I'm going to take things into a slightly different sort of channel now. By way of background, I'm a respiratory and general internal physician. I've just completed my training, for those of you in the US, my residency training just a few weeks ago, and I'm about to start a consultant post in Oxford University Hospitals next month. So I've got a couple of weeks off, which is nice, because I've been working busily on the COVID wards up until this point. And by perchance, I was talking to Peter about some of the work that I did during my research years. I have absolutely no background in IT or in AI, but during my time in research, I was fortunate enough to work with a supervisor who was given a large grant by the Department of Health in the UK to look into how we can utilize AI technologies in early lung cancer detection and in early lung cancer diagnosis. And so that's really going to be the basis of my talk today. The work that I've done is very much proof of concept. The results are all in their infancy, but the work is ongoing. And I guess it fits in really importantly about, somebody mentioned earlier that we don't, as medics, we don't necessarily know how AI works, but in terms of its usage, we can contribute a lot to that. And that's sort of leading on to what I'm going to talk about today. So just as a brief, the slide's stuck.
Let's see what's happening for you there. Let's see. If you go out of full screen mode, maybe it'll work if you hit the escape button on your PC. And exit full screen for a moment. You might find that works better. Ambi, there you are.
Yeah,
it's moving. Please.
So I'm going to talk a little bit about the epidemiology of lung cancer and introduce lung cancer screening studies that have been going on an international front. I'm going to talk a little bit about pulmonary nodules, and I'll explain what they are, but they essentially are the earliest entities of lung cancer, and talk about our work in developing AI in nodule diagnosis, and then we'll talk about some future considerations which can go on during the question and answer session. So
could I just note, so a nodule, that's one of those lung spots, isn't it?
Well, yeah, I've got I've got a few pictures coming up. So to explain
okay. Thank you. Sorry.
No problem. So I've only given this talk to medics. I've never given it to non-medics. So just slow me down if anything doesn't make sense. So cancer, lung cancer, it's a poor man's cancer. It's the second most common cancer in the UK and the most common cancer worldwide. And it's the most common cause of cancer-related death. And for the foreseeable future, we are seeing a rising trend, particularly actually in women as more women are taking up smoking. But the sad truth is that survival statistics are incredibly poor. And over the last 40 years, little has changed in the way of lung cancer survival. And if you look at cancer across all of the stages, your chances of surviving at 10 years are only 5% on average. And this is absolutely astounding to when we look at the statistics for a whole range of solid organ tumours from the 70s. We have come leaps and bounds in terms of breast cancer, in terms of bowel cancer, in terms of prostate cancer. But you can see that with lung cancer, we're still very much stuck at the bottom here. Things haven't changed at all. And the reason for that is lung cancer, the symptoms are often very insidious. You don't have a physical lump that you can feel or a change in things. The symptoms are often fatigue and breathlessness, which have an array of different pathologies. And so people only really tend to present in the late stages, which is the difficulty that we have. And so in the 1990s, it came to force that maybe we need to start screening people for lung cancer. And after a series of proof of concept studies, a large screening trial, which was initiated in the US, recruited over 50,000 patients from 33 centers. Patients were recruited who were deemed to be at high risk of developing lung cancer, so patients of a certain age group, those who had a heavy smoking history, and by 30 pack years, that essentially means someone who smoked 1 packet of cigarettes per day for 30 years, so a fairly heavy, substantial smoking history, were invited to come and participate in the trial, where they were either going to have a low-dose CT scan of their chest or a chest X-ray annually for 3 years, and these patients were followed up to see whether they developed a lung cancer or not. And the results of this trial were astounding, so much so that the trial ended early because they found a 20% reduction in lung cancer mortality in the patients who'd had a low-dose CT scan. And this was absolutely phenomenal, the results, and all very statistically sound and across the board. Europe then followed with a multi-center trial across many countries in Europe and found similar results. There was a 26% reduction in mortality when you screened for patients deemed at high risk of developing lung cancer. And it's not just lung cancer that you pick. When you screen for lung cancer, you also pick up many other incidental things on a CT scan, which may not even be related to the lung, but all of the screening trials actually reduced your all-cause mortality by about 10%, which again is astounding. And in the UK itself, we don't have a formal screening program as yet, but we know that it's actually very efficient to screen for lung cancer in terms of the numbers that you need to screen to save a life, much more efficient in comparison to bowel screening and breast screening. And so this takes me to the nodule. So what are we actually detecting when we perform a CT scan? We are detecting a nodule, which is a small tumor. It's characterized as being 3 centimeters and less in 2D diameter, and it's got to be fully encircled by lung tissue. And the problem is, I've got some other pictures of different types of tumors. They don't always have to be solid. They can also have this ground glass appearance here. And some of them can be a mixture of having a solid component with a little halo around them. The problem we have is that these nodules can be absolutely anything, particularly when they're small. They don't just represent early cancer, they can represent benign tumors, fatty deposits. They can be present post-infection, for instance. So post-tuberculosis, post-fungal infection, they can be, absolutely anything, particularly when they're small. And when you look at trials and across the board and across the world, actually 20 to 30% of people have some sort of nodule if they're scanned incidentally. But out of those, about 1 to 2% will actually go on to have a cancer. And so when we have these entities, there's an incredibly high false positive rate. And this was also found in the National Lung Cancer Screening Trial in America. And just to put it in context, this is just an example of 2 patients, some scans that we have to deal with all the time in our MDTs. These are 2 patients, both smokers, both in their 50s, both presented incidentally with these small nodules, which are about 5 millimeters in diameter. One of them went on to have a cancer, and the other one, it was just an entirely benign nodule. But at this stage, we have to make a call about what we're going to do with the patient, and we generally follow them up. We can't discharge them at this stage. And for those patients, it causes a lot of anxiety because we tell them, well, we've found a spot. It might be absolutely nothing, but it could be an early cancer. And for some people, that can cause a lot of anxiety with having to wait to see if it grows. In Britain, we are advised to use composite prediction models, and they basically allow us to essentially tap in patient characteristics and nodule characteristics, and we are given a probability of malignancy score which basically guides us as to what to do with the patient if their risk score is high or if their risk score is low. And we have algorithms for that. And in the States, similar models are used, which were developed and validated on patients within the US population, again, based on patient and nodule characteristics. And so one of the first bits of work that we wanted to do was to see how well these models actually fare in a real world population, because as we've spoken about, when you're using risk models, they're only as good as the data that you input, but how well do you actually validate it on a completely independent data set? And essentially what we found in Oxford, based on a cohort of just over 700 patients, were that the models created in the US fared slightly better than tossing a coin, and the model that's basically the Williams model was based on a lung cancer screening trial in Canada. They had lots of small nodules in their data set. So the accuracy was about 82%, but still 82%, if that was you, would you be happy with that as a guide to how we manage you? You've got an 82%, this model's 82% accurate. What if you're in the 10-15% non-accurate group? This is basically the variability that you can see with the different models. And this is patient A that I showed earlier, who actually went on to develop a tumor. If we had used the Mayo and the McWilliams model, this patient may well have been discharged from medical care. And so they would have presented a year or two later with advanced lung cancer. And so the reasons why we think these models performed so poorly was because they often underestimated the risk of malignancy in our population. And this is because the development data set that these models were based on excluded patients with a prior history of cancer. And what we know now is that 1 in 2 people develop cancer at some point in their lives. And in our population in Oxford, which is an oncology follow-up centre, we have a lot of patients who've had some degree of cancer in the past, who then present with these nodules, and these models are not applicable to them. And so, and yeah, this slide basically shows the performance of the McWilliams model, which performed reasonably well on average, but when you split it into patients who'd had a prior history of cancer and those who hadn't, the performance dropped significantly. So it's time to dig a little bit deeper, and this is where we paired up with imaging scientists based in Oxford to look at developing another biomarker of malignancy, because at the moment we use size and we use growth, but there's something that we're not seeing in the naked eye, despite years and years of experience. There's something that potentially we could do and develop to help diagnose things a bit better at an earlier stage. And this takes me to talk about texture. Texture basically enables us to look at the tissue parenchyma at a very high voxel resolution. And using machine learning with the data that we input, we can teach the computer to essentially learn and pick out different patterns of the voxel arrangements. And these are very much akin to what we see under the microscope. They can pick up things like irregularity of border, heterogeneity of the voxels, which can be indicative of an early cancer. It can give us a lot of information. And texture is an emerging imaging biomarker of malignancy. It's not just limited to CT scan data. There are lots of studies looking at it in ultrasound and in MRI, and not just within the lung, but also within the brain and the liver and other solid organs. And the way we envisage that it would work is that we would, as clinicians, detect the nodule, because sometimes there are some nodules that we intuitively know we can ignore. So we don't want a computer to just detect it for us. We will detect it, but we'd like the computer to then arrange a region of interest around the nodule, not just within the nodule, but maybe the surrounding area as well. Texture features would then be extracted from that, and that would be mapped onto a nodule malignancy score, which would then enable us to decide at that point, is this highly likely to be malignant? What do we do next? And just give us a little bit of added information, but not replace, as sort of we were alluding to, not replace our clinical acumen, but to aid us further in diagnosis. And so we wanted to create and validate a model based on incorporating texture within this. And for any valid biomarker, we performed one of the first studies looking at the repeatability of texture as well, which is something that hadn't been done before. And just to give you a brief flavor, we used logistic regression on the population of patients in Oxford. All of these patients that we inputted into the data set had a ground truth diagnosis. So they'd all either had a proven diagnosis of cancer because the nodule had been removed, or they had a stable nodule over 2 years. And we know that if a nodule has not grown over 2 years, then it's statistically benign. And we found a few independent predictors of malignancy within our data set, including a prior history of malignancy, which essentially carried quite a large weighting, as well as something called spiculation, which is essentially how spiky the border is, because we know cancer grows in an irregular manner. It doesn't have a nice smooth border. And we've made 3 models, one very much akin to the models I showed you before, looking at nodule characteristics and nodule size. And then we replaced size with a texture score. And then we also wanted to see what texture just did on its own without knowing about the patient and their smoking history, or whether they were male or female, or their age. Now, this is very proof of concept work, so the results didn't necessarily follow what we were expecting, but it was a good exercise to do. And we found that our sort of model, unsurprisingly, had a very high AUC, just with characteristics and diameter. Texture alone had an AUC of 0.8, which wasn't terrible. We're actually getting better results than that now. And when we added texture to nodule characteristics, the performance of the model dropped. I think this was more of a statistical oversight with a bit of data overfitting. But overall, this was a really interesting study because it's one of the first studies to incorporate texture into a model, focusing on patients with small sub-centimeter nodules in an unselected population. And what we learned from this is that we need big data, and this work is ongoing, and we need to prospectively validate, and this is work that is ongoing at the moment, and I'll talk a little bit about this at the end. We also wanted to look at the repeatability of texture, as I mentioned earlier, and this is something that hadn't really been done before. And so at present, our main biomarker of malignancy is nodule volumetry, and we look at something called the volume doubling time. And so we monitor the volume of the nodule, and then we scan the patient again at 3 months. And then depending on the volume doubling time, this helps us to decide whether the patient goes into a surveillance category or whether we need to do something else. Do we need to biopsy them, or do we need to do more invasive investigations? And volume can be really helpful because diameter, particularly on a CT scan, particularly when we're looking at things that are less than a centimeter in diameter, this is an example of a patient where the diameter of the nodule remained at 7 millimeters in size over a year. But actually, if you look at the volume, it had changed fairly significantly. And this very much indicates that this is a malignant process. But the problem with nodule volume is that it can vary by up to 25% when someone is scanned on the same day. And that can be just because of the way that they're lying on the scanner, or their heart rate, or their respiratory rate. So although it's a great biomarker, it is incredibly variable. We wanted to see whether texture also exhibited the same variability or not. And so I did a very brief proof of concept study where I prospectively invited 40 patients who all had nodules and were all going for CT scans. But instead of having 1 scan, they ended up having 2. These were very low dose CTs, so the radiation dose was incredibly low. And they had 2 scans in a coffee break. So they had a first scan, I gave them a cup of coffee, they had a second scan, and then we extracted 20 texture features from their nodule of interest and also looked at their volume. And what we found was that volume wasn't statistically that different. I think it's because it was a controlled study, but actually the texture features were much less variable, and they were also all highly repeatable as well. And so this was really promising work that has been presented internationally because it was the first study to assess texture as a promising biomarker of cancer. We're also confident that it's fairly comparable to automatic volume measurements, which is what we use at the moment. And the advantage of texture is that you can get a one-stop diagnosis. You don't need to bring the patient back after 3 months to rescan them. You can make an educated sort of diagnosis just in one point in time. It'd be interesting to see how texture changes over time, and that's some work that we are going to do in the future. So where are things at the moment? So things have stopped a little bit because of the current climate. But what we envisage is that a computer-aided prediction tool will help to act as a second reader. It's not just about picking up the cancers, it's also about whittling out the benign nodules, because that causes quite a lot of heavy workload and time for us as clinicians. And as patients go for more and more scans, we have a huge workload on this. We need to basically prospectively validate the program that we have at an international level, and that's those studies are ongoing at the moment, and some are pending ethical approval. And what we envisage is we want a usable, easy platform where we can click on the nodule and we can get information about volume measurements and so forth over time. We can also then get a texture score, which can then be mapped onto a probability of malignancy score, and the computer hopefully can give us an idea of what to do next. And this is not so much about the specialist, because tertiary centres like Oxford have specialist thoracic radiologists. This software is really helpful in your smaller hospitals, and this is what we were saying about AI making things more accessible to people who don't necessarily have the specialist clinicians. Using this could really help to aid their diagnosis and help reach the specialist care out to rural areas as well. This is just a sort of slide showing the degree of the problem. We have approximately 1,000 patients in Oxford who present with small nodules per year, and on average they get about 3 scans a year. And if we could save them having additional scans, it would not only save on clinician time, but it would also save the NHS money as well as clinician time, and enable us to concentrate on focusing on the patients who actually do have a cancer. Challenges to the workflow. These are just some of the things I put together that I sort of had, and Anthony touched on some of these things as well, is that you need clean data, because your AI system, your machine learning, is only going to be as good as the quality of the data that you input. And this is the problem with a lot of studies that have gone previously, is that the data they've put in is messy. They don't have a diagnosis, and computers can pick up trends and patterns. They are clever and can come up with great models, but when you prospectively validate, you realize that they're only as good as the population that they were built on. We needed very stringent data sharing agreements between the university, between our industry partners, and then on an international level as well. And so GDPR is incredibly important in this, as well as anonymizing the patient data. We also found that, and I think someone's talking about this, storage is a big problem. We sort of found that we were quickly running out of storage, and outsourcing to other companies, particularly when you have patient data, can often be tricky from a legal point of view. But we do need big numbers. Multi-center collaboration is essential, and what we found is that this was probably one of the first projects where we had clinicians, but we also had computer scientists working together. And I think when you have that multidisciplinary approach, that is what makes the success of this work and the success of this technology. I have a few people to acknowledge. So our funders from Innovate UK, the Department of Health, and then our medical imaging collaborators, Murado and Optellum, who are based in Oxford, as well as my supervisors who helped to supervise my doctorate in this work. And for those of you who would like to come, just the Spires of Oxford, just for a bit of inspiration. So thank you all for listening.
Thank you. That's a wonderful, wonderful, wonderful thing. If I may, I'd like to, I have a couple of immediate comments, but just before I say any comments, let me just add some of the other folks here. So we could, in principle, do 2 things. Either we do a pure Q&A with you, then we do the panel session, or what we could do is we could sort of kind of add people in now, and then we start with that being a Q&A session for you, and then it kind of just morphs into being
general.
the
Yeah.
panel. But maybe that's a nicer way of doing it. Ian is one of my colleagues here, and as I've just added him in. Anthony, you already know, having his cup of coffee. Again. I can see having a cup of coffee there.
I think the croaky voice is set.
And again, the liability things, there's so much, but there are so many touch points between the two of you, it's unbelievable. Andrea, very familiar with these subject matters as well. And Matt has been thinking about these things for a fair while, and actually have a wild card, and this is something that you did expect. Philip, thank you, Philip, for joining us. Philip Anderson, all the way from Boston, early in the morning, your time.
Yeah, no, happy to be here. Really a pleasure, and thanks for the invitation.
It's totally our pleasure to have us here. We've seen some extraordinary things this morning, Philip. There was one thing I noticed in Ambi's presentation, which was Ambi's repeatability picture, which I thought was excellent. I thought that was very funny. And Matt, I think there was something you picked up in Anthony's presentation earlier.
There are just so many things to discuss. I've been scribbling frantically, and I've got sort of many questions for everyone and anyone.
Okay, cool. So great. So wonderful. And so one of the things you mentioned there, Ambi, was this thing, a practical problem of storage that you had in terms of doing your work and so forth. And later on today, Katie is going to be talking about that. So Katie Haynes, and Katie is now CEO for a non-profit organization in San Francisco, and they are specifically set up and so forth in order to help people in your position where you want to do great work, but you just need a lot of cloud capacity.
Yeah.
So, and Philip, you know Katie very well. How long has she been doing this thing, and how is it going, and how open is it for people to use? Do you know?
Yeah, no, I've known Katie for a little bit over a year. They're a relatively new organization that has just gotten started, but they I think they have a really intriguing platform for being able to bring anonymized data to a wider audience of AI researchers. And I think they're to the extent that I understand this, and I want to defer to Katie to explain it in more detail, but I think they are they do have, I think, significant capacity and bandwidth for being able to host data in a way that is both secure and accessible to to approved researchers.
I think that's a big thing. Ian, you've been looking at the incoming questions. Are there anything there that you'd like to sort of mention immediately, or?
I think just a couple really going back. Sorry, unmute myself, right? Yeah, I guess kind of simply going back to the legal contractual side of things and what we're looking at. Obviously, AI, as we mentioned, is playing a more and more important role in decision making and predicting results. From a contractual perspective, does it have to be called out in the contracts we're drawing up with our clients and other organizations? Because obviously it's going to change over time, and if we're not relying on humans now to make all the decision making, is that part of the contractual requirement that we have?
So I guess that's maybe a question for me. Yes, I think the sort of the key thing to do when you're looking at a contract from the outset is a lot of it is down to setting expectations. So, for example, in the legal industry, you could offer a machine learning tool to process a load of documents, but as part of the contract, you could say, you, the client, you can decide whether you want us to drop on those results and validate them, or you want to just rely on the results that have been generated by the computer. So there's quite a lot to be done, I think, in terms of setting expectations about exactly what it is you're going to deliver, whether or not there's going to be a human in the loop. But I suspect there should usually be humans in the loop. just to sort of validate things. But obviously there would be cost implications to doing so. So I don't know if that answers that question. We can then sort of start talking about what happens if things go wrong, and whether the thing that went wrong was because the human made the wrong judgment call. It was something to do with a defect in the tool. And then there's sort of, in edge case scenarios, there's a question of whether there was a defect in there in the first place. It's just pushing the envelope. So you start to get into all sorts of those sorts of debates. But I think at the heart of it, in terms of the contract, if you're setting expectations with clients, customers, you want to be clear about exactly what it is that you're going to be delivering, and if there is going to be an AI component to it, that needs to be understood and articulated up front.
I think in terms of the kind of healthcare industry, how aware are people or patients or people that need care, how aware are they of these new and emerging technologies, and do they embrace them, or do they feel that it's kind of a medical trial and they're not certain? How do you approach this?
I guess that's one for me. I think with patients, particularly when you look at in my lung cancer clinic, patients are just grateful for absolutely anything, and are very, very open, and they trust us. They explicitly trust us as clinicians to look after them. You know, they put their lives in our hands, and I think the way we see the use of AI technology within our institution is it's going to be an adjunct. It's never going to replace the human eye. We did a fun experiment where we put the model head to head with my professor, who's got 35 years of experience at looking at the scans. Still beat the computer. You know, it's not. We don't envisage that it's going to replace, particularly within radiology. It's not going to replace, but it's going to act as an adjunct, and it's going to help centres in particular that don't have the specialists there, because you can't have the specialists, the super specialists everywhere. It's there to aid, but common sense will prevail. And I think that's sort of where we see it for now. We don't see it replacing us at all, because, as I said, the computer is only as good as the data that you input. And there are loads of data sets out there which, you know, AI, people have claimed they've made AI models that are based on, and they're actually, when you look at the data, they're not even cancers that they're inputting into that. So I think we're a long way off from having a computer that can diagnose you, because there's so much more to medicine than just a few algorithms.
And I think with such an important sort of topic, the false positive, false negative aspect. So a false positive result is upset for someone, but probably ultimately a relief. And of course, a false negative may be a much bigger impact. How are those things balanced?
I think that's what we need to look at. So we've been looking at things like cutoff points. So within our model, it's not just about performance, but it's how many false positives can we whittle out without getting any false negatives, and it's looking at that cutoff point, and that's something that we're still working on. And in reality, for a lot of these people, we don't just discharge them from our care. We carry on following them up for the time being, because even if the computer gives a score, we are not confident that that has been extensively validated. And so they're still on our books. It's more of a theoretical exercise. But yeah, absolutely, that's where the difficulty will lie, that at some point we'll have to have a cutoff. And where is that cutoff going to be? And I think it's going to be very much individualized to the patient. And also, increasingly, we do things, we do shared decision making with patients. We're not paternalistic. We don't just make the decision. We talk to patients and go, well, look, we've done this. We've run it on the computer. This is what we're getting. What do you think? You know, and we have a joint discussion. And although it's really difficult to discuss risk with patients and explain risk properly, I think increasingly we will be doing that. And some people, you know, a 90-year-old patient with a nodule might say, actually, I don't want to know. I don't want to keep coming up to the hospital. I'll hedge my bets. Whereas somebody else may have a different perspective. So it's going to be tailored to the patient.
I find it fascinating how sort of if I think about the things that Andrea just spoke about and you spoke about, and Philip, what we've all spoken about together, Philip. So you're looking to, if you look at it from a data operation standpoint, and I'm sorry, so my technology hat on. If you look at it from a data ops standpoint, then you're looking at moving quickly, sure, but that's easy. But you need to move with precision. And when you move with precision, the whole thing becomes more economical to operate, but you also cause a lot less collateral damage. So and when you then start thinking about the data that you need, if you want to act based on data, people talk about companies that are data driven, and what does it really mean? If it's data driven, then you have to trust the data. So the quality of the underlying data, when you collect, when you analyze, you create your insights, your ability to trust your data so that you can govern and plan and act and automate. The sort of the level of care, we almost owe a duty of care to, if I may use, Anthony, one of your terms, we almost owe a duty of care towards the data that we use to drive our activities. And I think, Anthony, when you were talking about next generation legislation, and I know this is something that drives you nuts, I'm so aware, the next generation legislation needs to cover off areas such as negligence in terms of taking care of your data. And because, I mean, Michael, who spoke first this morning, and I'm delighted to say that Michael's asleep now, he spoke about the very first thing he said was that you need required, relevant, and robust data in order to do automation. And Henry, I'm adding you into the stream right now. I don't know, I'm shocking you. Sorry.
Hello.
Hi, Henry. And Henry has written his PhD on data and so forth. He's generalized that into code and data and how you think about those things. And wouldn't you say, Henry, that the way that we manage the quality of software and the way that we manage the quality of data, the processes are becoming remarkably similar? Because if you want the data to drive your business, and if the business is driven by your software, if you want Ambika's clinical care to be driven by these systems, then your level of management needs to be extraordinary, all the way from the data upwards, wouldn't you say?
Yeah, I agree with your points. And one thing that is kind of becoming the next thing, I think, is that the only proprietary stuff that your company has will be your data. All of the software even now is turning into more and more of coupled up from open source and coupled up from many sources. And it's not kind of like your core competency anymore on the software side, but it's more on the data side, and what kind of data are you currently mapping, and how are you using that inside of your organization, and what are you storing? And is it in a format that you can smartly and efficiently use to gain insights from that? And I think that's, as we said, AI is something that can help us pass a lot of that stuff, because nobody has time to go through all the data that we now have available for us. And you need the kind of levels of abstraction on top of that to let humans handle it, so you can offload some of that thinking into the AI systems and not into your cognitive load.
Yeah, Peter, I think you...
Sorry.
Oh, I was just going to say, I think you put your finger on a really, really important point about the quality of data. And I think we and many of us have experienced this when working with different sorts of clinical data, that there's an enormous amount of cleaning that oftentimes needs to happen in data that we're using, and part of that arises from the way in which this data is gathered, and in many healthcare systems, in the electronic health records, a lot of the data is manually entered by people. And this ranges from, diagnostic coding to, a variety of other sorts of data, structured data that are entered. And I think, when you go through this, you find all sorts of nonsensical, negative time intervals and things of that sort. And I think one of the big challenges, as we've just heard, is, given the enormous amounts of data that we're trying to deal with, how do we come up with ways of automating or semi-automating the curation of that data? Because I think ultimately, we have to really curate and figure out ways of curating the underlying data that we're using for these algorithms, or else we run the risk of inaccuracy. And we were talking about the false positives and false negatives before, and so I think this is an enormous challenge. And one of the things that we've been thinking a lot about is how we can, to some extent, automate some of this data curation. But I think, at least at this point, I think there's still an important role for human curation of key data elements. But I'm curious what others' experience has been. But I think you really touched on a key point there.
Yeah. And for example, now my work, even though I'm saying it, I'm an AI and ML specialist, I'm really just a data janitor in like 95% of the time that I'm doing. All of the ML and AI stuff it's just a function call. And that's the easy part. The most difficult and biggest engineering challenge is messaging the data and getting it into the format that I can just put it into the ML function, and that's about it.
I quite like.
After you.
Oh, sorry. Yeah, I quite like Peter's analogy in the legal context, because I think the one place that we can all agree on is the main risk in relation to machine learning is in the data that's being fed to teach the system in question. So if you teach it rubbish, it will produce rubbish or strange results or unintended consequences or misdiagnosis. So all sorts of implications. So with that in mind, I think if you are a user of machine learning tool, as Peter says, you have a duty to make sure that the data that's being used to teach that tool is an appropriate data set, because I think that's sort of the heart of where the potential liability might lie. So I really like that analogy, Peter.
Both on defense and attack. On defense, in the sense that you need to be comfortable that no one can attack you for negligence, but also attack in the sense that if you can trust your data, then you can move at a speed and with precision, which is totally different.
Yeah.
I just thought that, because this issue so the issue that you're all touching on also is being seen a lot in research, and I think the concept that people seem to be raising is that of edge cases. So when it's all well and good having a 99% confidence, in getting the right, say, diagnostic, and what happens to the 1%, and actually there can be very odd correlations in your false negatives, basically, that sometimes actually tell you quite a lot about the mechanism of what's underneath. This paper I mentioned at the end of my talk about the incredibly fast performance in, for example, weather prediction models, there's an important caveat there. It doesn't seem to perform very well for chaotic systems. So where you have tiny changes in initial conditions and they lead to massive consequences, once the system has evolved. And so, in the case of weather forecasting, it's all well and good having an incredibly fast and efficient system. If you miss that hurricane, it's useless. And I think that this is a genuine problem that I think is really being grappled with on the research level. Like, what's the contact with physical reality?
I think there's a couple of things there you mentioned that are really important. So unintended consequences, and I'd like to come back to that in a little while. But first, the correlation piece. So, things like people say short trousers correlate to buying more ice cream, when in actual fact, both of them correlate to hotter weather. How do you get through that minefield of sort of causation and correlation?
Well, one thing that we've been kind of doing is outsourcing the correlation and causation thing into humans and in the models. But of course, that's not the way to solve the problem. It's the only way to hack the problem, in its sense that we can avoid some of those. But of course, the humans can make the same mistakes. And of course, that's a bigger philosophical problem of how to solve that problem. As you basically, how you solve it is with more data outside of the model, basically, because you then incorporate the temperature data and you incorporate more data, and then you can kind of start at some point actually seeing the causations or time variable causations at least. It is a really difficult topic to solve, and we humans ourselves are really bad at it also.
Yeah. And I was trying to link sort of Anthony's cat with Andrea and Schrodinger's cat somehow. So I know she have a fantastic cat in the background there. And in terms of unintended consequences,
the hair.
It's a hair.
It's an amazing thing.
I was hoping it would become a talking point.
We couldn't have gone on without it. In terms of unintended consequences, then, so what economists would call externalities, and I think the not popular, a big example is, for example, passive smoking. How can we become more aware of these? Or how can we sort of, I don't want to get into a Rumsfeld thing, but how do we know what we know and how do we know what we don't know?
That's a deep question, but one question we do have an answer to is that I would like to, I don't have a glass of champagne, but I would like to applaud Ambi for being in the front line of health and having been
absolutely
really something else. You were there in the first month of April for the NHS. I mean, that was something else. And you had COVID yourself as well, I believe.
I did. I knew I'd got it after that week of shifts. But luckily, I'm recovered. But it's sort of, we were talking about this work. I mean, like I said, my experience in AI is so limited. But actually, Peter and I got talking about this work could very much be rolled out to looking at COVID as well, and helping us to better manage patients who come through the door. Because at the time in April, it felt like a Russian roulette who would end up on a ventilator and who wouldn't. There was no rhyme and reason to it at all. It wasn't just the comorbid patients who were getting affected. It was many young, healthy people as well. So I think this is a big minefield and there's a lot to learn. But yes, I think we noticed a lot about causation and correlation and a lot of things that even when we were
sorry, if I can just make a point actually pertaining to COVID, which is something we've seen a lot of at Nature in recent months, and a lot of submissions, a lot of actual debate.
Yeah.
And I think this ties into the whole issue of known unknowns and all the rest of it. Is the UK response to COVID. Actually, I think it's a very big category to sort of analyze, but it basically falls into this, I think, category where, well, we didn't know a lot of things back in March, and people sort of had access to different data sets, different quality data sets. They had different biases, they have different schools of thought, different trainings, and all having to be somehow integrated into a, coherent response, or I would argue not terribly coherent response, at least at the beginning here. And the hard thing to get to grips with is that I don't think you can. I think there'll be a lot of lessons learned from this entire experience in that regard, because I really think there was, there were no right answers at the time because we didn't know so much.
No.
Now we can go, okay, well that worked, that didn't work, and I think one of the things which I think for the first time in human history, we now, we've gone through a pandemic, and we can imagine things like, or technologies like contact tracing. This was impossible, say at the time of the Spanish flu. I think we probably made a lot of mistakes, but I think the lessons that we will learn actually will mean we'll be much better prepared for the future outcome of this situation of this kind. I'm relatively optimistic in this regard, actually, but I think it's kind of fascinating to see how the whole world has got a big lesson in certainty, uncertainty, data, decision making on a global scale on something so important and life and death as an epidemic.
Yeah.
Philip, what's your thought on that?
Well, yeah.
You knew I was going to ask.
Yeah, no, I was waiting for that one. No, I mean, I think the experience with responding to COVID is, has certainly been an incredibly, it's been an incredible learning experience, I think, for all of us. I mean, I've I'm an emergency medicine clinician and have been working since the beginning of March, in the emergency department here at Brigham, alongside colleagues, and we've now, thanks. It's really been eye-opening. I mean, we've actually been fine here in Boston. I think we've seen much more severe and difficult situations in both in other parts of the U.S. and other parts of the world, but I think as has been mentioned, I think we have learned, and I think it's very clear now that there are a number of strategies that in fact are very effective at managing this from a population and public health perspective. And without going into all the details there now, I think we're familiar with what these are. It's about wearing masks and social distancing and doing adequate amounts of testing, contact tracing, and so on and so on. And so it's not rocket science, actually. I mean, we know how to manage this, and I think what we've seen, certainly in many of the hardest hit European countries and in many parts of the US, when we follow these measures rigorously, we can actually get on top of this. Massachusetts, where I live, was one of the early hotspots in the United States, and we also have a lot of healthcare resources and capacity in Boston. But we did. It was a long couple of months in the early spring, but I'm happy to say that that now today the numbers of new cases are dramatically down. Massachusetts is one of the lowest now in the country. Hospitalizations are down, mortality's down. I mean, everything is going in the right direction, and we're gradually working our way through the phases of reopening. And all of those phases are, very tightly linked to public health metrics that we follow. And in many cases, those, reopenings have been delayed because the metrics are not where they need to be. And so I think there is reason for hope. I think that we have learned how to manage something like this. But the challenge really, as we've also seen in the U.S. is having a coordinated national response that's really based on facts and science and learning from our experience, learning from the experience of our colleagues around the world. I think if we can figure that piece out, I think we'll be in a good position.
Amazing. So numerics and data and numerics, and they have to be right. I mean,
you have to follow the facts. I mean, it's not more complicated than that.
Just going back to the sort of the point about unintended consequences, in which can apply in all sorts of scenarios. I think it's I think the law has to be quite reactive in that context. So, for example, people driving in their cars looking at their phone, you'd think that people wouldn't do that, but they do, and therefore, sadly, a law has to be passed to stop people driving dangerously, kind of specific laws. Or the Pokemon sort of situation where people were trespassing as a result of playing the game. So you do get these unintended consequences, and the law unfortunately has to be quite reactive in that context. Would be my observation on that. And also, again, to the point made earlier that whilst there might be a general framework for assessing liability, given that we're entering into essentially a new world, making sure that, for example, the spotlight is very much on the data that's being relied on, and the law being quite, as an example, the law being quite specific about that, so that everyone knows where they stand.
I understand. Cool. Well, we're coming up to 11:57, and we have a beautiful video from Objectivity that we would like to show you. We've made it ourselves. We're very, very proud of it. It's at least 22 seconds long, and after that video clip, Philip, I think we'll go into your presentation if that's okay, and
sure.
And then let's play it from there. Let's see, Piotrek, do you want to turn on that video, or how do you want to play that thing? There we go, and we're coming to your presentation, and I've just added your presentation to the stream here. So I think probably the best thing I could possibly do would be to remove myself and disappear for a little while. So I'll just disappear and enjoy, Philip.
Okay, well, Peter, thank you so much, and yeah, it's really a pleasure to be here with all of you to talk with you a little bit this morning about some of the work that we've been doing in our group here in Boston at the Brigham and Women's Hospital. I'm going to go fairly quickly through this because I know that we want to have some time at the end to have some questions. So my background, as I'd mentioned before, I'm an emergency medicine physician by training, and I've been working clinically for about 25 years. And for the past 15 or so of those years have been spending a lot of time working with healthcare quality and system optimization, and have had the great pleasure to work in a number of different countries around the world with our external facing group, which we call Global Business Strategies, where we collaborate with healthcare systems in different places to help them develop their acute and unscheduled care delivery systems. Just as a financial disclosure, I want to mention that I'm also a co-founder in a company that has been formed, which is commercializing one of the things that we came up with that I'll mention very, very briefly as we move forward. But I just wanted to make that disclosure up front that the Sharpic platform is something that we have a company that's working on. So what I want to just get right into is to try to map out the problems that we have been thinking about, and which I think are kind of relevant to this whole conversation that we're having today. And so one of the things that in our work with healthcare systems, both here in the US and elsewhere around the world, is this whole question of sustainability. And what I mean by that is the ability for healthcare systems to be able to deliver high quality, affordable healthcare to the whole population that they serve. And I think one of the reasons why this is a big issue and a big challenge is, as you all know, we have aging populations that live longer with a variety of chronic diseases, and that increases demand for services. And also there's always, new diagnostics and new treatments that are coming along, and people want to have those. And how do we continue to provide access to all of that without sort of ruining our economies from excessive healthcare spending? And so the other
Hi there. I can't hear you at the moment. Hold on. Let me see what just happened there. Matt, can you hear me right now? Matt, I'm just turning you into the image here. Can you hear me? So you can hear me all right. But Philip, I cannot hear you right now. So let's see.
Hear me now.
Oh, I can hear you now. That's perfect.
Is that better? Okay, I apologize. I don't know what happened there. Okay.
Just suddenly when these things do happen. Okay, I'm going to disappear out again.
Okay, I will continue here. So we were talking here about the issue here that I think is of interest is the relationship between demand and costs in healthcare. And so on the one hand, we have this unsustainable growth in healthcare spending, which is linked with I would say a generally poor understanding of costs in most healthcare system, and oftentimes a conflation of costs and more of a focus on revenue. And I think one of the ideas that we've been very interested in is how do we reduce costs? And I think traditionally there's a focus on in many systems on reducing access to resources and care as a way of cutting costs. And what we're much more interested in is trying to think about ways of reducing demand. And I think this is where the whole issue around machine learning and predictive modeling comes in. And I think all of this is complicated by the problem of fragmentation in healthcare. Healthcare as an industry is incredibly fragmented. And this fragmentation it tends to be based around the silos of care delivery that we see really everywhere in the world. It's actually quite similar. And this fragmentation extends beyond care delivery itself, but also to data gathering, analysis of data and finances. And so what I would describe is the ideal future state, or at least kind of one version of that, is one in which there's much more of a widespread adoption of what we might call fact-driven management. And what I mean by that is a system in which there's really much greater data transparency for the healthcare system leaders, which allows them to really much better understanding of relationships between the utilization of care, the outcomes of care, and the actual costs of care delivery. With this, it's possible to be in a much better ability to prioritize the different opportunities for where to focus improvement efforts based on variability analysis. And then very importantly, to be able to prioritize new initiatives, the implementation of new structures or processes based on an understanding of what the likely impact is going to be on outcomes and cost. The second thing is being able to really reduce demand for acute care services. And what I mean by that, this really gets to the core of where I think AI predictive algorithms can play a really important role moving forward, is to be able to predict healthcare outcomes where there's a possibility for intervention, either in terms of actually preventing the outcome for individual patients, but also potentially just in mitigating the severity through earlier intervention. And I'm going to talk about some examples of how we've been doing that and where I think we need to focus more. And then I think lastly, there's an opportunity for optimizing care based on a much more systematic delivery of evidence-based care, which we know a tremendous amount about, but which it turns out we don't really have a good sense at the population level of the degree to which those are implemented appropriately for patients. So I want to just hop right into our work that we have carried out in Region Holland in Sweden. Our journey in terms of trying to address some of these questions and issues led us to Region Holland, where we worked with a number of the leaders in the region there. Marcus Lingman, who was not able to join us here today, is the Chief Strategy Officer for the region. Kjetil Iverson was the head of the primary care system there, and Martin Engström was previously the head of the hospital system, now the head of the whole healthcare system there. Region Holland's a relatively small region in Sweden. It's one of the 21 regions that own and operate the healthcare system. They have a population of about 300,000. And we work together with them to try to address a number of common challenges that we face. In both of our systems, we had the common problems of aging an aging population with rising costs, and tended to have a very specialty-oriented and hospital-based approach to acute care delivery, which is a very high resource-intensive approach to providing that care. And we also had challenges with data. We had lots of data in all of our systems, but really a limited integration of that, and a limited ability to really kind of understand the whole acute care system, to kind of get our arms around all of that, to come up with better tools for being able to understand and improve acute care delivery. And so the technical challenges that we needed to try to solve and figure out, we really needed to have a way of understanding the whole care delivery system in a different way. As I mentioned before, this fragmentation problem means that the data that we gather and analyze about the system tends to be oriented around the vertically integrated silos of care delivery. And when we're making strategic decisions and delivering care, we need to be able to understand what's happening at the patient level or at the population level, which is more of a horizontally integrated approach. And so what we needed to be able to do was to pull together all of the structured data for all of the healthcare encounters that were produced by the system, for the entire population that was served by the system. And we needed to be able to link both the clinical data, diagnostics and treatments, as well as operational, as well as cost information. That was a very important piece. And we needed to be able to do that at the patient encounter level, so that we could understand things from a patient perspective. And it needed to be done in a way that was anonymized and compliant with all the relevant patient safety regulations. And so we had to come up with this data model. There was a lot of work that we had to do with getting access and permission for linking all of these data sources. We had to come up with methodologies for quantifying capacity, which is extremely important if we're trying to understand cost. And then I think lastly, and very importantly, is we had to be able to transform existing financial information into cost information at the patient encounter level. And this could be a whole topic, for discussion on its own. So I'm not going to go into this in great detail, other than to say that, we had some great help from some of our colleagues at Harvard Business School and financial controllers in the Swedish healthcare system, and came up with some scalable strategies, based on the whole notion of activity-based costing, to be able to accomplish this. So the solution that we came up with is what we have now come to call the Sharpec platform, but is a platform in which we pull structured data from all of these different domains that you can see above, and then clean and transform and curate that data to be able to address a number of really key concerns, both at the healthcare management level, you can see down over on the left, but also at the patient care level over on the right. And I want to give you some examples about each one of those. Just to kind of frame this in terms of the impact or the consequences of using data in more effective ways. Region Holland, in our work together over about a 3-year period, this was a time frame in which their population increased by nearly 5%. They were able to save nearly 2% in their healthcare system spending. Their annual budget is about 8 billion Swedish crowns, or about €1 million per year. And they were able to reduce that by nearly 2%. And at the same time, were able to be in the leader position, really, in terms of productivity and quality amongst all of their counterparts within Sweden. I apologize, this is in Swedish here, but it's from a report from the Swedish National Health Authorities. This was a remarkable achievement, I think, on their part, and they attribute this to being to this greater adoption of using data in the way that we've described. So how did they accomplish this? I'll give you a couple of examples. One of the key ones was around being able to prioritize new change initiatives. And so the challenge that healthcare system leaders face is, how do you prioritize which new healthcare processes to implement? I mean, those are kind of the major tools that you have and the levers that you have to really improve healthcare delivery. And so we came up with some methodologies for being able to analyze a specific process to understand both the current state in terms of their outcomes and cost within a given process, and then to model how that could look in the future. And so then to be able to look at the difference between those and come up with a return on investment and estimates of what the clinical outcome would be based on literature and expert opinion. And when we do that for a number of different new potential proposed processes, we can come up with a value matrix that can inform decision making. And they use this to great benefit within Region Holland, and we're able to kind of reorganize a lot of the care that was delivered with a goal towards shifting care from high resource intensive inpatient care to more lower resource intensive outpatient and emergency department care. Another area that was in this area of population health and personalized precision medicine, where there's many evidence-based guidelines that describe how care should ideally be delivered. We've been able to model many of these and to then be able to determine what the eligibility is amongst the population and the compliance of care with each. This is just one of many examples having to do with atrial fibrillation and anticoagulation, where we were able to look at a population level and determine the degree to which this guideline was being implemented, and to identify opportunities for improvement and cost savings throughout the population. And then I think lastly here, I want to get into the topic that's more relevant for this conference, which is about AI predictive modeling. And this is one example of how we have been using this whole system, whole population data set to try to predict a variety of different outcomes of interest. This is one example looking at the rising incidence of mental illness in young people. And there was a great interest in Region Holland for being able to identify people aged 20 to 30 who were at increased risk for having a new first-time mental illness diagnosis within the next 12 months. And so we developed, the team in Region Holland developed an algorithm that was entirely based on demographics and their clinical profile, looking at all of their interactions with the healthcare system that we had in the structured data. And this was quite accurate, it turned out. We were able to predict with a 94% accuracy the individuals who were at increased risk of having such a diagnosis. And this information was then used by mental health workers to reach out to this at-risk population to be able to start earlier interventions. And one of the really interesting things is that all of this was able to be predicted. None of the data that went into this had to do with contacts with the mental health part of the healthcare system. With psychiatry, this was all pre-diagnosis, right? So they weren't really connected with the psychiatric system so far. And I think one of the implications of this is that the target of investment and intervention is earlier. It's in primary care, in the school system, and social systems. So I think this can provide some insight into how to intervene at a system level. In addition to that, there's a whole range of different topics that we've been working on in terms of different healthcare outcomes to try to predict, and the list just keeps growing, and the opportunities are endless. These are a couple, you can see here a couple of the publications that have arisen from this, but there's a wide range of opportunities. And I think what we see is the opportunity going forward is to have, potentially hundreds of these predictive algorithms running in the background, within the electronic health record, to be able to provide expert assistance really to clinicians for being able to recognize populations that are at risk. And to some extent, although it's maybe a bit overstating, it's a way of diagnosing disease before it happens, so that we can have an earlier opportunity of intervening for our patients, and then by doing so, being able to reduce their demand really for acute healthcare services within the healthcare system, and then as a way of and having that be a way of really reducing cost, which can then be those resources that are freed up can then be reinvested in other areas to pursue greater access to care for other underserved populations, or to increase the ability to take advantage of new diagnostic and treatments as they become available. The next steps in terms of where we're headed with this, right now we are continuing to work with Region Holland and one of the local technical universities, Halmstad University, to develop what they are calling a healthcare data factory. And what the vision for that is really to have located in one place complete EHR healthcare systems data for a large population, 5 to 10 million individuals, also with patient encounter level costing information, as a resource for research and AI algorithm development. We've been able to put together an ecosystem of different groups with different expertise that are needed for being able to do this, including academic partners from a number of different universities, both in Sweden, the US, the UK, with data scientists and analysts who are able to guide the algorithm development and the data cleaning. We also have a number of healthcare systems which are necessary for testing and validating these algorithms. We have access to great clinical expertise from different systems to guide the prioritization and development and then subsequent implementation of these. There are commercial partners involved who can provide the necessary support for logistics and implementation. And I think most importantly, we've engaged legal expertise to ensure that we're able to do this in a way which has the necessary regulatory compliance and data security. And lastly, I would say that this data set that we're putting together, there are also tremendous opportunities for also doing real-world evidence-based studies with life science companies. So there's a lot to do here. We're very excited, I think, about the next steps here, and really see this as a way of trying to address a lot of these challenges and concerns that I mentioned at the beginning, and to really bring AI algorithms to play a much more central role, I think, in bringing about optimization and improvement in the way that we deliver care, to help us, reduce demand, and really to make ultimately healthcare delivery more sustainable at a global scale. So I will end here, but happy to take any questions, and very, very happy to correspond by email if you're interested. Thanks very much.
Thank you. And I'd like to comment on one thing. You mentioned about your work with Marcus there for a while, Marcus Lingman over in Sweden. And one of the things I found so refreshing, both talking to you and to Marcus, was the way that the numeric approach to thinking about your challenges is similar to so many other things that we're working on. If I just add for a moment to the stream a couple of slides here. So these are some slides that the consultancy folks over at Objectivity use on a regular basis, where we're trying to think about the different metrics that apply to a particular problem, where you can start drilling into the income that you know you're going to be getting, and there are different ways of thinking about that, how effective your sales and marketing is, the lifetime value, if you're from one perspective, from your perspective, from Marcus's perspective, the lifetime cost, and how you're planning that for a patient, and thinking about how long people are going to stick around, if they're going to move to a different health environment, and so forth. And so there are a couple of sort of standard, really good ways of thinking about these that together create sort of core financial metrics around which you can build variance. And I was fascinated to hear from Marcus how similar that thinking was to even companies like PokerStars, and Michael Short's going to be talking about PokerStars later on today. There are so many touch points between these things. So once you start making your company really numerically driven, or the way you think, numerically thinking, the methods become remarkably similar.
Well, no, absolutely. And I think one of the things that I would say is that, when we think about, when you look at, other industries, and you mentioned several there, where thinking about cost is just so fundamental, and the sophistication in terms of the metrics for thinking about cost are enormous. And I think one of the somewhat embarrassing things to acknowledge or admit about healthcare is that I think healthcare as an industry is not at all sophisticated when it comes to thinking about and understanding cost. And this is true in the US, but it's true, frankly, in most countries. The focus of financial analysis in healthcare is to a much greater degree on revenue than it is on cost. There's a much greater understanding of revenue streams than on actual cost. And to the extent that cost is focused on, it's really at the department or service line level. It's not at a patient encounter level. And although that may seem like a subtle difference, really, if you think about the kind of the manufacturing analogy of a Toyota factory producing Priuses, you in that sort of an industry, everything about the cost of every part and every detail and every step in the process, and we just don't have that level of understanding in healthcare. We know what we spend on the Department of Cardiology or the Department of Emergency Medicine, or what do we spend on drugs last year. We know that absolutely, but how much did we spend on taking care of patients with congestive heart failure last year versus patients with diabetes? No clue whatsoever. And so if you're trying to make strategic decisions about the healthcare system to decide where do we want to invest in order to improve the health of the population, that would be useful to know, because we don't. And so we really wanted to try to make a contribution with this approach to make it easier for healthcare systems to have a much more granular understanding of what their actual costs were, and to be able to use that and factor that into strategic decision making.
Ian and Matt, I'm sure you've seen some questions pop up.
Yes, and I've gone through the most enlightening presentation there as well, because I've learned an awful lot there, which kind of takes us, I guess, into the right direction. I'm seeing like the concept of the healthcare data factory and the power that can have. One question I have is kind of, You've mentioned there that data came from different data or information silos initially. You were involved in quite a lot of processing and cleansing that data. As part of the work you were doing, was there any work done towards coming up with a standard, a data format standard, or kind of how is that data presented, just to make it more easy to use and more effective going forward?
But by the way, I'm adding Sami into this call right now. Sami will be doing the next thing in a few moments, and it's highly relevant. So, but please, Philip, do take that first question first.
Yeah, no, absolutely. No, I think the whole question of having, you know, data standards is extremely relevant and really important. I guess I would answer that in a couple of ways. So I think part of this, the challenge, I think, from a technical side, was coming up with a data model of, you know, of what, you know, what data, what structured data are we going to use and bring into the model, and how do we structure and organize that? And we've used a couple of different formats. We initially were using a Microsoft SQL kind of platform, but then we were using tools like, you know, SAS or SPSS or R to you know, run analytics on that. What we found quickly, though, is that as the size of the data set got larger and larger, the speed with which it could carry out those analytics got slower and slower. And so we had to adopt a different approach. And we've since moved over to a graph database model for how to organize the data, because it's just much faster. Mm-hmm. In terms of the data standards, I think we are.
So actually, if I may interject, so the data operations are actually entirely fundamental to the way you think.
Absolutely.
Yeah.
Absolutely. No, because I think part of the, we didn't really get into talking about the details of this, but I think one of the ways in which, you know, we achieve this goal of helping the organization to become a much more data-driven organization is that you have to make the data accessible to people who are not data scientists and who are not, you know, sort of epidemiologists and have, you know, statistical programming ability. You know, typically in most healthcare systems, you have a relatively few people with those skill sets. And so, but yet there's an enormous number of people. You want everybody to use data, everybody in a leadership and decision-making capacity. You want them to be able to use that data. And so part of this approach really is to create a front-end sort of BI user interface that allows people to navigate the data without requiring that level of statistical programming ability. And in order to run something like that, it has to be incredibly fast, because otherwise people don't, you know, they get very quickly bored if they have to sit around for a few minutes waiting for the results of queries. So speed is absolutely essential.
Yeah. Wow. Sami, in principle, it's 12:30 now. Now, Michael Short is with me, and I would really like to just introduce Michael to Philip. Do you mind if I just do that before you start the presentation?
It's okay. No problem.
Okay. Michael, this is the team here. You've got Philip from Boston. You've got Sami on IP from Finland. You've got Ian and Matt. And Michael, I was just thinking that you have a deep background in medical. And you're now doing some fascinating stuff with AI at PokerStars and have been doing. Goodness, I mean, the touch points numerically, you have a lot in common.
Oh, thank you, Peter. Yes, it's fascinating to hear the talks this morning on the medical intervention and how we're going to use data in the future. And you know, I think several speakers have made the point, and I think it remains true that garbage in is garbage out. And that pathway between data to form information and then using information to make knowledge and inform good decision making is never more true than in the medical space. Whether we look at drug development, whether we look at genetics, whether we look at planning for pandemics, whether we look at disease causation and understanding environmental and other epigenetic factors, these things are really essential to make sure that you you can really interrogate a database properly, but then how are you using that data so you don't get false positives and causation is properly aligned?
Fascinating, fascinating. All right, back to reality. Well, okay, let's look at the intellectual property side of this. Who owns what? So,
are you talking to me or to the rest of the group?
No, I'm talking to Sami. Sami is about to rip into that. And so, Sami, I think you probably have a presentation you want to go through. And,
Yes.
And I shall make myself disappear from here, along with the others here. Here we go. Here we go.
I hope you can see my.
There it is, and perfect. Okay, perfect. Philip, I hope you stick around for the panel later on today. We have a panel session that starts at 3 o'clock UK time, which is what, 10 o'clock your time? I don't know if you're available for that.
Perfect. Yeah, I should be able to be there.
Would be wonderful. Okay,
great.
Thank you, Philip. Thanks.
Thank you very much.
Thanks. And okay. I shall exit and give the floor to you. Okay.
Thank you, Peter. So good afternoon, everyone, and morning to the US participants. It's been a pleasure to follow the presentations today and see the common good that everyone has been kind of giving to the society. Ambika and Philip working with the kind of COVID things and creating systems for benefiting the general public. And now I'm going to talk to you about IP and patents, which basically is a way to prevent others from using something. So it's totally opposite. So I'm bringing the view to this discussion from I would say quite different angle than the previous presentations. I'm not an IP. I am an IP expert. I'm not an AI or machine learning expert as such. So my background is that I started as a patent attorney, moved to Nokia, like most of the Finns at that time. I was running their patent creation portfolio, patent creation and managing the outside attorneys, preparing the applications for Nokia, moved from Nokia to startup to build our own VC-funded portfolio, which was sold, moved back to corporate world, and then, like some of my former colleagues say, I moved to the dark side of IP, and I moved to entities who only owned IP, only owned patents, and tried to monetize those patents by licensing and doing litigation. And now I'm doing consulting. So basically, during the time when I grew up as a patent attorney, believing in IP and believing that everyone respects those, I'm now much more realistic in understanding what's the value of patents, what's the value of IP for a company. And I'm hoping to bring in some of those aspects during my kind of 20 minutes presentation. A few words about Condico IP. So basically, my colleagues and I, we set up this Condico IP as a realization that world is changing and companies should be thinking differently about IP. And basically, we are trying to help our customers to face the challenges they are seeing. We are not patent agents, so we are not drafting patent applications for our clients. Neither are we lawyers, so we are not working with kind of contracts, etc. But we do work together with them and many other across the market. And basically, our business idea is to help companies define how IPR can support their business most effectively. So basically, I will start from this angle. So basically, it is true that artificial intelligence, machine learning are testing the limits of IP protection. So basically, last year in August, a team led by Professor Abbott, he's from University of Surrey, they announced patent filings for AI-generated inventions. The AI concern named Dabus was created by Stephen Taylor. And Dabus, this AI, had invented a flashing light that uniquely draws the eye in emergency situations. And according to its inventors, Dabus relies upon a system of many neural networks generating new ideas by altering their interconnections, and a second system of neural networks detects critical consequences of these potential ideas and then reinforces them based upon predicted novelty and salience. So basically, what was the new thing here was that applications list the Dabus, the AI, as the inventor instead of any person, and the Dabus owner as patent applicant and the prospective owner of any issued patents. So basically, the idea was to test, can AI be an inventor? Basically, at the moment, not. So in April, US Patent and Trademark Office rejected the applications based on the fact that US patent law had previously only specified that eligible inventors had to be individuals. And basically, the US decision followed similar earlier decisions from UK and from the European Patent Office. But this is not the core of the presentation. I see this debate as an academic. It's of course very important from validity point to list the actual inventor as the inventor, but for me, this is not the core fact that companies in AI machine learning field should keep in mind. The fact is that AI machine learning systems have assisted inventors for a long time already. And the new tools help everyone to play with the data and come up with new, innovative, and counterintuitive findings, leading to new patentable inventions. However, we should all keep in mind that IP is only valuable when it supports your business. And unfortunately, some patent attorneys and academics still think that it's important to patent your invention. The reality, however, is that patent which is unenforceable, for example, no one uses it, or infringement is impossible to prove, is useless. It's waste of everyone's time and resources. Especially in the field of AI, machine learning, IP portfolios are transforming their shape from patent-heavy portfolios to give more weight for trade secrets and more selective patenting. I will be saying this later today, but I'm saying it now. It is often a good idea not to file a patent application. If we think about the kind of issues companies in this field are facing, they are basically facing a dilemma. Data and the algorithms are essential components to developing products based on these technologies, but it's really difficult to protect them from an intellectual property perspective. And in this slide, I have some typical kind of risks or situations that companies may face in IP. So basically, first category is choosing wrong IPR avenue. And what that means, it might be that company has wrong sort of IPR. As example, publishing an invention via patent application enables others to implement similar solutions and services. So basically, when you file a patent application and it gets published, everyone sees what you have invented. Another way of having wrong sort of IPR is that you have been patenting a system that is globally implemented. So we live in the world of cloud implementations, and if the infringement happens all over the globe at the same time, one step in different countries, it's really difficult to ever enforce those assets. Second problem is that I have seen a lot is bad patent quality, wrong patent scope. So basically, claims have been written to cover the invention, which includes the server, user devices, and lots of things happening in every separate individual. That is the invention, but from patenting perspective, it's impossible to enforce because there's no single entity which acts all of those steps. Patents might be too broad, so they are likely invalid, or they are too narrow. There are too many steps that no one implements all of those. One thing that is really important in relation to AI is wrong geographical coverage. So basically, you might have good patent. It covers what you are doing or what your competitor is doing. It's single entity claim scope, so there's basically single server infringes the claim. But in today's world, it's relatively easy to move a server from one country to another, and then you are not infringing anymore. That's something to keep in mind when thinking, should I protect my invention with patent or not? And then invention is successfully stolen, so no matter if you have an NDA or anything like that in place, someone might still steal your idea. So relying solely on NDAs is not always the best idea. Or your invention is stolen by competitor recruiting your employee, and employee discloses your secrets. One risk that kind of everyone with patent faces always is invalidation. Someone might come and attack your patents trying to invalidate those, but that's relatively low risk. Bigger risk, if you get kind of successful, is that there will be enforcement matters. So basically, third party may claim that you are infringing their patents, or they accuse you of trade secret theft. And these kind of assertions may lead to litigations, which are then painful in many ways. So basically, what I want to point out here is that I'm not listing as a risk the use of AI, the use of machine learning, use of low code, or anything like that. Those are risks, like everything you do in your business, it's always a risk. But those technologies or solutions to create code have risks, but low code risk management doesn't differ that much from practices companies have implemented for use in relation to open source for many, many years already. So basically, don't believe if someone says that using low code as such is naturally a big risk. what I have learned when talking with my clients and potential clients, with the management and with the IP people there, is that unfortunately their viewpoints towards protecting companies' IP is still rather narrow. People still prefer to concentrate their efforts in patenting their core ideas, which often actually are not that well protectable with patents. They forget that there are two possible approaches for protection. You can apply for a patent, or you can seek trade secret protection. And when it comes to AI models and algorithms, the latter is better route. Patenting publishes your invention, and if the invention relates something you want to hide in a black box, you don't want to open that black box by filing patent application disclosing it. So basically, as it has been discussed and like Henry pointed out during the panel session, previous panel session, there's lots of data and there's problems in how you categorize that data so that it's usable. The challenge is how can you transform the data to information and then information to knowledge that can be used. And those things typically are in the core of what your company is doing. So you have some algorithms, you have AI models, you have lots of other data and code, you have know-how, and typically those are best protected with trade secrets. One thing that has been kind of an eye-opener for some of my clients is the fact that since having the data, having the best potential data is key, one good place for IP protection relates to the enablers. So basically it can be platforms used for collecting data, it can be data formats or how the kind of data is transferred, it can be tools. Those are good things and good places for patenting, as well as are the results. So if you are planning to publish something in kind of glass box context, it's okay to file patents for those because those get published anyway. Tangible products and other products are good source for patent protection. Trade secret protection is the thing that I'm trying to say here makes sense. And basically, trade secret protection is simple in theory, but there are some challenges and key questions to be addressed. How do you prove ownership for something? How do you prove the secrecy? And how do you prevent erosion in a world where big data is increasingly digitally accessible? And how can you identify, how do you define a trade secret when, as in AI, dynamic and changing variables are a key feature of the algorithm or a dataset? What are the reasonable steps you have to take to keep data secret? And how do you document all of these so that you can prove for someone that, yes, this was my trade secret? One big thing is that IP position relies on people creating it. So basically, whatever is the company's IP position, it depends on the organization's capability to understand role of the IP for your company's success. And to be successful in trade secret management, it requires that whole organization understands the value and importance of managing trade secrets properly. And it's important to remember that you should not manage only your own trade secrets properly. Also, you have to manage trade secrets of third parties, of those companies you cooperate with. And no policy is effective if it's not followed. AI, machine learning, brings in some topic-specific nuances, but it's not black magic, not even in this context. So basically, I don't have a formula for defining, okay, what is good IP position for an AI company, because the value of IP, being it patents, trademarks, you name it, varies depending what's the core purpose of the company. And traditional old way was to rely solely on patents and copyrights, but right way and the way where world is moving is to balance the protection using trade secrets and patents depending on what are the circumstances the company is working in. And there is no one-size-fits-all portfolio model. And something that my patent attorney friends doesn't like, but I'm saying it again, patenting should not be a target as such. It's often okay not to patent anything. Thank you.
It's amazing, Sami. I really love that presentation. And it's so if you look at the way that people structure their IP thinking, it has really shifted over the last 10 years. There's a big change, and looking ahead, you see that structure happening even more. And do you see also a trend where it's even more the case now than before, that every single person needs to understand what you're protecting and what you're not? Because if trade secrets are a big part of your IP portfolio, then everyone needs to know which ones we're protecting and how. And I mean, it's a process thing. The way you.
Yeah. So basically, the importance and the kind of fuss over trade secrets has increased a lot during the last few years, and that's basically based on the fact that people have realized that how difficult it is to use patents in real world, and trade secret is good way to do that. And there has been lots of kind of trade secret theft and kind of cases. Big corporations are claiming that you stole my idea, and that has basically bring up the attention. But what people should remember is that trade secret is not a trade secret in the eye of court unless you have took some steps. You have to have processes to recognize what you consider as your trade secret and why, and then you have to keep those and handle those as trade secret. So there's a room for learning for corporations.
So you have IP operations in that sense. I'm lifting in Ian and Matt into this call as well, and I'd like to lift in Antonia and Michael as well. Michael's speaking a bit later on, but I know that Michael's been thinking about a lot of these things. So this is the full team here. I know Matt and Ian, you've both been sort of hearing a few questions during Sami's call about this. Is there anything that pops out that you'd like to mention specifically? Your microphone.
Sorry. Hi, Sami. I think one thing is sometimes I see people sort of trying to diversify an area and try and protect it before something actually really happens. Is this something to be mindful of? So Apple, for example, may file 100 different patents for technologies that aren't actually being used yet, just to try and cover a space that may later become valuable.
Yeah, it happens all the time. And actually, when I mentioned about the fact that we built up that one portfolio, it was VC funded, those patents were actually acquired by Apple. And then there was one Finnish reporter who called me asking, is Apple bringing this technology that you patented? And I said, no, they just bought the portfolio. so it is happening. So people are patenting lots of stuff, and the figures, the filing numbers are increasing, and our message from Condico IP to our clients is that you don't have to follow the route necessarily, just patent when it makes sense in business wise. And of course you have to keep those tens of thousands of filings when considering your own exposure, but there are so many patents that if you don't want to do business, then because of those patents as such, then don't do it. but of course you have to respect IP rights. I'm not saying that you shouldn't care about patents, but today's world is so full of patents that just do it. One investor actually said some years ago that if the companies he has been invested in has not been sued for patent infringement in 3 years of time from the filing, from the kind of setup, it's a failure because it hasn't kind of gained any attraction.
Amazing.
So I guess tied in with that as well is kind of, whilst there is some level of, I guess, of global protection around patents, obviously with a trade secret, you don't want to divulge too much of it. So how do you protect your trade secret?
So basically, trade secret protection is well defined, especially in US and Europe, and basically it requires some steps, and you have to kind of be able to identify what is the trade secret and why it's valuable, because it stays as a secret. What are the steps you have been taking to ensure that it's not available for everyone, and how do you kind of manage that kind of trade secret portfolio? And you cannot say that everything you do is a trade secret, but you have to be kind of cautious and have processes and proper handling for those. So that gives you good starting point. Sometimes people are saying that trade secrets are the ones that you rely on when your pants are wet, but I think the attitude is changing a bit.
So, Antonio, I'd like to, if we just move your presentation a little bit like this, just stretch it a little bit. Do you mind if I just ask one more question from Sami, please, if that's okay, Antonio?
It's okay.
So on the, you've handled many companies, and you've looked at many companies and the way that they handle trade secrets. So looking at that, can you give an example of someone who you think is handling trade secrets well, looking 10 years ahead? So who is well aligned? Who is doing it well? Who's doing a good job in terms of handling trade secrets? Because just keeping everything secret, rock hard, that can lock down the company, and suddenly you don't have a company. Your secrets are well kept, but you're dead. And so that's not very useful. So there's a balance there. You have to be smart.
Yeah, I think it's practically impossible to say which companies are doing it in a proper way. There seems to be cases where the companies have not managed the trade secret kind of portfolio management in proper way, either by the fact that they are sued by stealing someone else's trade secrets, or by some other things. But I think it's really difficult to give any good example, because trade secrets.
Isn't it more a question of culture than process?
I think it's more. It's you have to have proper processes in place, but it's definitely a culture issue, starting from recruiting people and kind of ensuring that they understand why it's important for the kind of company's success, and ensuring that every level of the organization knows why we are doing what we are doing.
Sorry, Michael, I know this is something that you've been thinking about as well, a lot as well. Would you like to pop a question to Sami now, or would you like to keep it until the panel?
I'll wait to the panel. Thank you, Peter. I think I could spend all afternoon talking to Sami.
Indeed.
But my background, Sami, is also in drug development, so that's why I'm fascinated in what you're talking about.
Perfect.
Matt, any more questions to Sami?
I think we'll keep it for the panel. There are many to ask.
Okay. In that case, shall we say welcome to Antonia from Lisbon? A beautiful thing that you're going to be talking about.
Yes.
Low code and speeding things up. It's going to be really good fun. And let's see if I can see your presentation. If you share your screen, if you wouldn't mind sharing your screen for a moment, and I'll be rude and I'll drop myself and the others out here in a moment.
Let me see if I can share my screen. Okay, do you see it?
It's there.
It's full screen, right?
That's it. It's looking good.
All right, let me just pull up the, hang on. All right, I think everything is set up. You can see me, I can see the screen, you guys can see the screen. Hi, everyone. I'm Antonio. Can you hear me? Great. I'm Antonio. I'm head of AI at OutSystems, and I've been doing research and development of AI and data-intensive products for over a decade, from analytics to fraud prevention, and now in automating software development, which I really believe is one of the new frontiers for AI.
Antonio, I think maybe the connector is a bit loose on your microphone, because some of it sounds perfect and some of it sounds a bit surprising.
Really? Should I remove it? Maybe it's not working well.
It's good. Hold on. Keep going. I'll just jump in if it happens again.
Okay.
Okay, cool. It's perfect now. It's perfect now.
Let me know if it goes bad, and I'll take it off.
No worries.
All right. So I'm starting with a single number, and I think this number tells a big story. So this is the number of unfilled software development positions in the US predicted for this year, as reported by the Wall Street Journal, from federal jobs data, and also from the code.org nonprofit. So also the lack of talent is really the number one concern and obstacle that CIOs identify as keeping them from achieving their objectives, according to a recent Gartner study. Now, this issue, which makes it even tougher, is not distributed evenly. So you have the top tech companies, many of which represented here today, that are able to really acquire the best talent and pay generous wages. But a lot of other companies that are not originally tech companies, but need to become ones, they struggle to keep up in that area, and they compromise their competitiveness by not being able to achieve and get this talent. And so this is one of the key areas that OutSystems aims to help. It's by lowering the skills barrier to software development and to enabling every company, and not just the Silicon Valley tech disruptors, but every company, to become what we call a cloud software company. So we enable our customers to create, these amazing customer experiences, to be extremely agile, and to build their digital platforms with modern and extensible architectures with no technical debt, just using the best technology. And we've seen time and time again, OutSystems customers modernizing their digital fabric and doing projects up to 10 times faster. Things that took, several years, they now can do in a few months. And you see people get trained and onboarded also much faster. What's interesting about this is that we see that our customers are not limited as well. So it's not that it's easier and it's faster, but they're also not limited, and they go and build mission critical, enterprise, super complex systems. And one thing that is really, I really like to see is that IT departments feel really more confident and the business feels empowered. And you have, customers saying that they're feeling like Calimero, always complaining, always feeling bad because they couldn't deliver value to the business. And now they feel confident. They walk with their chin up in the corridors, and they can deliver very fast to the business. And one of the key things that characterizes these cloud software companies is having top talent. So people that are able to be effective and productive creators. And we really want, from our strategy and vision, really want to expand the available talent pool. And the way we do this is by reducing the needed skills. And we've done this already, but we really believe we need to go further and really achieve the next level in software development accessibility. And so that poses the question that we pose ourselves is, can we make software development 100 times faster with zero training? And that leads us to a secondary question when we start asking ourselves, how can we do this? Is what if we could essentially embed an AI tech lead, bundle it up inside a product? What if we could use AI to learn about the many different tasks and the many different domains, from design to development, testing, and operations, the full life cycle, by analyzing millions of data points and projects at scale and leveraging that to augment developers? And so that really kind of gelled into our vision that we have right now, which is to make every developer a top talent by creating a virtual expert that we embed in the product and that amplifies every developer's effective skill, their speed, their agility, and the quality of what they do. And we do this, and we believe that the right way to do this is by powering up everyone, augmenting everyone, leveling up the playing field as we do that. And of course, we see this having a bigger impact on the novices, the people that really haven't done this yet, but also powering up the experts and the masters at a different level, but also empowering them to work better. And we are working to achieve this by leveraging these AI on code capabilities to essentially provide developers with guidance, automation, and validation of their work. So if you think about it, these three pillars of assistance, they really kind of encompass the big technical roles tech leads have in the teams. So they guide novices, so they teach them the best practices, they show them around the code base, they talk to them about components they should use and where. They get them out of stuck moments, they have an error, they don't know what to do with it, or they never built a screen. That's one of the things that they do. Another thing that tech leads do is really valuable is that they actually execute some of the more complicated tasks for the novices. So they take that work out of them. And they also do the code reviews, and they validate the quality of the software for the more junior members, but for the overall team as well. And so this is where the OutSystems AI group, which I lead, comes in. So this is a really an integrated R&D group that we're building and we're growing at OutSystems with AI researchers, software engineers, product designers, product managers. This group is really capable of taking ideas through research and into users' hands. And it's one thing that is really powerful is how all of these different skills can work together to really create new technology that is actually usable and is impactful and is able to really augment the people we're working for. So we're pushing the state of the art forward in this area. And we're also collaborating a lot with the AI community to accelerate the evolution of these technologies all around the world. And so I'm going to give you a glimpse of a couple of capabilities we've worked on and for which we've seen a big impact in how novices are able to learn while doing, but also making experts more productive. So the first thing I'm showing you is a capability. What you're seeing on the screen is essentially the OutSystems visual programming language. So when you code in OutSystems, you use this visual programming language to just code your business logic or code the logic in your screens, all of that. And what we did is we trained, actually we have over 7 machine learning models online working in Ensemble to give you these predictions. And these models and this AI is able to understand the intent of the developers, and it's able to suggest based on the best practices, based on looking at millions and millions of code patterns, able to suggest what is exactly what the developer needs. And it's able to tell it what's the next step, autofill the parameters, understand the intent, and really, in some cases, automate the complete experience for them. That we are able to achieve such high accuracies because of the novel machine learning and deep learning architectures we're using, that in many cases, we are able to understand ourselves. The product is able to understand it, has a very, very high likelihood of getting it right. So it kind of proactively tells the developer, and the developer is just able to go through with it quicker. We're already seeing next level learning and productivity gains. So we have almost half of the developers of our developers using this actively and recurringly. And here, the example you see here is, a developer has created a screen, a mobile app with a screen where they want to search by a scan barcode. And this is the logic associated with a button when you click to scan a barcode. So our algorithms are able to understand this context by analyzing all of the UI and all of the code the developer is using, matching it with the learned pattern that it has seen in the wild. And then it sees, okay, probably this developer wants to implement the check barcode pattern. So it immediately is able to suggest that and autofill everything. So this includes error checking, providing feedback to the user, all of these things that many times developers forget, they're not following the best practices, all of that. And so this is really interesting. And we've seen a lot of great quotes and testimonials by our developers, which is great. So this is not just a cool demo, this is actually something they are using. So when the developers saying that some things that took 5 minutes repeatedly now just takes an instant, and it guesses exactly what she wants. And it also helps them with their repetitive strain injury issues, which is great. We're actually helping in the health. Another perspective we've heard from developers is that this capability also helps them think more clearly and plan better what they're trying to do by reducing the cognitive overload. And so they actually said that they consider this to be their own personal rubber duck, where they can just kind of interact and understand what they can do and what are the possibilities here. Another capability we've been working on is around data modeling. So data modeling is one of the tasks novices find most difficult, and it's usually done by tech leads most of the time. It's also surprisingly where developers spend a lot of their time. So around 30% of time in development is spent on designing, iterating, and adding more things to the data model. And in this example, you see how we were able to learn from data models seen in the wild and automate the creation of the database entity. So completely automating the creation, what's the name, what's the data type, all of that. One interesting thing that emerged from these models was that they were able to learn to deal with different languages and context. So if you're creating an entity, and you instead of saying customer, you say client in Portuguese or in Spanish, it would actually adapt and give you the attributes in Spanish. It's something that we did not program for, but it kind of emerged from that, which is interesting. We're also, you can see this capability also being used in another OutSystems tool. It's more of a no-code tool for you to create very simple workflow-based applications and forms, and where we can give you a guided experience to automatically suggest the right fields for your application and for your form with the data types and all of that. Now, this is just a glimpse of what we're working on. And we have a lot more in pipeline, which you will see as time goes on. Another thing we value really is the collaboration with top research groups, such as Carnegie Mellon University, where we're exploring in a long-term project how to create a new level, a new custom development experience with no programming. And so this is not a no-code development experience. It's actually a programming experience where you're going to have custom code for your app, but where you're actually not going to be programming directly. You're probably going to be talking or giving specifications. So this is a deep research project. We're working with them. It's very exciting as well. So this brings us to the question, how do we train the AI tech lead and what are the challenges? So this is actually a big scientific and engineering challenge. This is why you're not seeing, tectonic changes in software development just yet because of this. Compared to other industries like financial industry, where you have AI really automating a lot of the processes. And this is because there's big scientific and engineering challenges here. And there are just a few R&D groups really trying to push the envelope on this area. One of the big challenges is that code is complex, the domain is very big, and the flexibility of code is incredible. And there's a huge variation in how everyone does things. So in this sense, this is way more complex than natural language processing or image recognition. And so it really requires us to think differently than these classical AI applications. But let's look a little bit more carefully at the top 4 challenges in this area. So the first challenge that makes AI on code applications harder is that the data sparsity is really, really large and big. Right? What does this mean? It means that you have all of the code, although there are some similarities, there's a lot of custom things. There are a lot of every team names the variables a little bit differently. Everybody does things sufficiently differently. There's a lot of neologisms, which means there's a lot of terms that your team might use in your code that has never been seen in a training set, right? And the code is full of specific idioms. Every team has their own way of doing things. And in that sense, it's much worse than natural language, where there's variation, yes, but there's typically a little bit more standardization in the overall discourse, right? Some solutions that researchers and companies have applied to this is really invest in data normalization, investing in trying to really create language equivalence rules so that you can convert different pieces of code into the same thing. Like a trivial example of this is if a team likes to do their if statements in a positive way. So if a positive statement, then something. Some teams like to do it in the negative, if not something. So you could normalize this so everybody kind of has more similar code. You can also try to augment your data, so get more data, perhaps leverage data from other programming languages. We also augment our data sets with high code for certain use cases where we can verify equivalence. Another thing that a lot of companies have been doing is to train specific models for each team, right? So there you have everything, every term, every variable name for that team has been seen in the training set. So this is kind of an easy way to tackle that. Then you have other scalability things. Another challenge is the semantic complexity of code. And one example of this is what is called a referential sparsity, which means that in code, each variable, each function can be used in a widely different place of the code base and of the project. And typically in text, in natural language, when you're mentioning something, that something has been mentioned before in a relatively close setting compared to code. And so one thing that is really important to do is really explore new neural network architectures, such as pointer networks, graph neural networks, and a few others that are gaining traction. Also leveraging multimodal kinds of data, so not just code, but also using comments to really understand the semantics, and really try to encode the structure of the code and feed that into the machine learning model. So not just considering code as a sequence of text, and really try to encode the structure there. It's something that's really important, and it's a research track going on. Another big one, I think this is one of the biggest challenges, is that machines really want code to be valid and correct, right? So although these methods are typically probabilistic, you really want the code to be correct. You want to produce valid code. Programs must compile. Machines are very strict. But also, we want to learn from the best practices, not the bad ones. One thing that people always ask me is, oh, you're learning from all this data, but most of the people perhaps program in a very bad way. So aren't you just learning incorrect ways of doing stuff and just giving that back to people and kind of making it worse? So that's a great thing, and something we also kind of go into. And how can we give transparency to these models and explain what they're doing so we kind of evaluate this? So there's a lot of work we're doing around this area in terms of really trying to learn what are some good patterns and bad patterns, and learn the equivalence so that we can replace the bad patterns with good patterns and really provide a correct experience. Also, not using just machine learning, but using other more classical AI capabilities together with it is also a way to deal with these challenges. And one of my favorite challenges is the user experience. So this is such a big challenge that we have more AI capabilities than what we know how to effectively create experiences for. So we have a lot of models and things we can do, but sometimes the challenge is how can we really put this in the product with the right user experience so that novices can use it, but also experts. And there's a lot of resistance from expert users. And this is not something we see. We've talked with, for example, the people at Microsoft that are working on some of these things. And even internally, they see a lot of resistance of developers using these AI capabilities for code generation. Experts think, oh, this is just for the newbies. But when we kind of reach out to them and teach them and create the right experience, they actually leverage that and they become more productive, which is really interesting. So another thing I'd like to show you and just very quickly go over is what are other companies and researchers doing? So OutSystems is doing a lot of work here, but I think it's also interesting to see what the rest of the community is doing. So one common example around AI automation for software development is called program synthesis. So actually, without programming, generating code for you. So Excel has for a few years this thing called flash fill, where you just fill in the example of what you want that column to be, and it will automatically create the expression, the code that will concatenate, in this case, the names. More interestingly, Google is shipping a similar capability, but the interesting thing from Google's that differs from the Excel's one is that it actually is able to show you transparently the expression it generates in the expression. So in Excel, it's a black box. It just generates these expressions. In the Google Sheet Smart Fill, it actually shows you what it generated. So research trends here are around pairing machine learning with program synthesis methods and really using many different types of specifications, examples, text, images, all of that. Another very cool example that has been going on in the social media is from OpenAI's, the latest huge GPT-3 machine learning model trained on text that is really able to generate some very convincing code. Just by you start writing what you want, you can write a comment and it will generate the rest of the code for you. And it's really impressive. It's really impressive. I really suggest you look at it. There are some caveats. It works very well for cherry-picked examples, but really not in real-world ones. But it does show promise for future research and for further research. You know, there's examples going on for automatically learning to fix code based on the error messages, which is really interesting area for validation, automating the validation of code. This is an example from Dr. Repair presented at ICML this year. Another one from a startup called Deep Code, where they're actually learning from all of the pull requests in GitHub, and they're seeing what people are changing in the code. All right, if people are always changing this set of code to this, it's probably a fix. So we're going to learn that, and if someone has the same original code, we're going to propose this in the code review process. So they kind of infuse themselves in the code review tools, and they give you these suggestions, you know, based on learning from GitHub repositories. So interesting thing as well. So here, the research trends around this area is really learning from diffs. So learning the code changes and the bug fixes from diffs, learning how to explain these, and really key how to reduce false positives and really give these alerts right when the developer is writing, not after a few hours in code review. Facebook is really interesting. So what you're seeing here is an automated testing system called Sapiens, where it actually tests their Android applications automatically, looking for crashes. And one of the things that they're doing, which is even more interesting, is that they actually have an end-to-end pipeline where they are detecting bugs automatically, they're suggesting bug fixes, they're testing the software automatically, and then they are learning as developers or their automated system fix these bugs, they're learning to be better as time goes by. So the Facebook team has some really cool stuff going on there. It's a really cool example on how you can use AI end-to-end for the quality ecosystem. So generally, I'm just finishing up, where is AI on code research going? What are the kind of the top research trends and things you should be looking at to really understand what is going to change? So the first thing I mentioned a bit is the kind of this concept of multimodal specification. So this is not just learning from code, but learning from comments, from code, from user stories, maybe from mockups, from images. Multimodal just means learning from multiple types of data and being able to create models that are able to ingest many different types of data. The other one is really interesting is new neural architectures. So classic architectures like convolutional neural networks, recurring neural networks are really not a great fit for code because code is such a complex web of dependencies. So you're seeing things like pointer networks appearing, graph neural networks appearing, and other kinds of methods that are appearing that are really being applied and really taking us to the next level here. And finally, one theme you're going to start seeing more and more is not just using machine learning. And when at OutSystems we say we use AI, we really don't just use machine learning. We use other classical AI techniques together with machine learning and deep learning, and these complement each other, and they give a really powerful mix for doing code generation and understanding. So essentially, our goal and what we are believing we're going to achieve is really to take this number, slash it to 0 by augmenting, just giving Iron Man helmet and assistance for every developer. So thank you for being here. looking forward to your questions.
That's an unbelievable show you just put together. You totally blew my socks off, I must say. Really cool. I'm going to drag in Michael into this as well, because there are a couple of angles here that really relate to Michael as well. Matt and Ian, you know very well since a long time back. I have a bunch of questions, but I don't know, maybe I need to put that in the panel session. Matt and Ian, I trust that you have absolutely nothing to ask.
I'll make a change.
I think one question, Antonio, is, that these low-code technologies are absolutely fantastic. There's no doubt. But still, some professional engineers and developers kind of steer away from them. They think it makes it simpler. They think it somehow removes their expertise. How do we make sure that the technology complements the engineers that are actually building these platforms and solutions?
That's a great question. So what we see is that a lot of resistance from kind of classical developers around this is that one, they feel like they lose a bit of control and understanding what's going on behind the hood, and so it feels to them that it kind of takes away their expertise, and kind of the expertise of the game is not being helpful. What we're trying to do from an experience standpoint is really to give some transparency of what we're suggesting, really, and try to remove as much of the boring work, repetitive work. And I think that's where the delight comes in. And when you feel that, you kind of feel more productive, and you can work at a higher level, right? So you're working, instead of being worried about just repetitive things that are really boring that the machine should automate for you, you can just focus on designing the great architecture or focusing.
I drew a whole sort of flow chart here of the effect on society of what you're doing, because this is actually a really big thing that you're talking about. Because in the past, people would have their workplace, they would have their career, they would have all the facts they know, and then they have the methods. Okay, what we're seeing now through the cloud, through DataOps, through DevOps, through low code, is that those three things, they disappear. So your workplace, your career, and the facts you know, they kind of, okay, skip that. Focus on the methods you know. Okay, that gives you anxiety, and that means that two things. So one is on an individual level, the other one is for your surroundings. On an individual level, you need to go through a learning path that you've never gone through before. It's going to be so fast. On your environment perspective, you need to allow your colleagues to change. You need to not give them a hard time when they change color, because they will need to change, because that's what is happening. So we need to allow each other to grow as human beings. We need to allow each other to change in a manner which is different. So it has an impact on the environment and on the individual. And on the individual level, if you're doing these things so quickly without a cognitive overload, and if you're not part of a 3-year project to do something, if you've just finished it and you don't have visibility beyond 2 weeks, anxiety, how do you handle it? So there are big changes in the way that we feel about ourselves and in the way that we enable our colleagues to grow and so forth. There's a whole new dynamic. And Michael, I know your talk, Michael, you're going to be talking about the human side of AI. And,
yes.
Michael.
Well, what I wanted to ask Antonio, which I think is fascinating, because I'm.
Your microphone is failing you, Michael. We cannot hear you. I cannot hear you.
Is that better?
That's better.
You're back.
Yeah. Yes.
Sorry. I'm trying to use my earpiece, and that's not working. So the question I had for you was really one of, so I think we're talking about psychological safety in many respects for high-end software engineers. And so, it's something that I'm going to talk about quite a bit, obviously, in the next part of this discussion. How do you overcome, or how do you address, or what is it that you do to make really experienced, high-paid people feel psychologically safe that what they thought up to now was their future is not now their future?
What a question. Antonio, come on.
It's a great question. I think now, currently, we have more skepticism from those people than actually being afraid of that, right? So I think we haven't reached that tipping point yet. But one thing that we do, I think we do from a design, like from the beginning, is we work with product designers and we talk with users, and we have the user-centric approach from everything we do. And we really spend a lot of time in understanding how can we make an experience that is good for novices, but also something that is appealing, doesn't get in the way of the experts, but is appealing for them. So one of the things we really try to do is, for now it's optional. Like if you want to take advantage of this, you can take advantage of this. If you don't, you don't. And what we see is that as they try it, they kind of start gaining confidence, and they understand that it's not actually taking their job, it's actually freeing them to do more rewarding work.
Fascinating. All right, Michael, I think what we need to do is hand over to you now. We have a big panel session starting in 1 hour from now, and Ian and Matt, do you mind awfully if we move the questions till then? Because if that's okay. So Michael does his session. Then we have Rose Luckin, which is, I thought she's so incredible. And then after that, we'll do a big panel session. Cool.
So, do you want to share screen now, Peter?
Yeah, if you can do a share screen, Michael, that would be terrific.
Right, can you see anything? Yeah,
I'm not saying yet on the shared screen.
Are you seeing that presentation?
I am not seeing a presentation yet. Let's see.
Hang on a second. I asked it to share screen, so share screen. Okay, hang on a second. I know what it is. There we go. You're seeing that now, though.
Yeah, there it is. Whoops, sorry, I double clicked on you then. Cool, wonderful.
So
right.
Can you still hear me, Peter?
Can hear you absolutely perfectly. This is perfect. This is great.
Okay.
And I will disappear.
Okay, great. Well, it's great to follow Antonio, because a lot of what I'm going to discuss is not the technical side of what we can do, but what is the human side of what we can do. And one of the things that's always amazed me is, if we look at organizational development in this area, is we completely forget that we've massively increased, and earlier this morning Michael was talking about this, the ability to deliver and what we can deliver and how fast we can deliver it and the speed at which we can compute. And yet the human brain has remained the same. So what I'm going to talk about is how PokerStars showed me that, even with AI and ML, it's about the people. So a little bit about Culture Works Consulting. We focus on building leadership teams. We focus on building purpose with those teams. And then we look at organizational design. So some of the things that Antonio is referring to in terms of T-shaped people and that sort of stuff. So that's the company. I'm just going to give you a bit of context, because I don't think we've really talked about it in this area, because this project was done in gaming, casino and sports betting. It's a massive, massive industry, huge. I mean, just to give you a sense that GVC recently entered the FTSE 100. You won't possibly know GVC, but you'll see, Ladbrokes, Coral, Foxy. This is a company that's now bigger than M&G, Pearson, Royal Sun Alliance. Then we look at Flutter, who have just acquired the business I was working for, the Stars Group and PokerStars, and Skybet, Paddy Power, Betfair. These are in the top 100, but they're above RBS, above Sainsbury's, bigger than BAE. So this is a massive, massive industry. And it's also an industry that is either grow fast or go fast. So if you're not growing, you are leaving. And I don't want to put names on this, but there are a number of companies in this space who've dropped out the FTSE 100. And it's difficult to see how they're going to really recover within the current space. it's a massive data-driven environment, particularly with the US opening. It's all about how do you manage your customer relations. It's about the regulatory environment, which is different between different geographies, and it's massively content dependent. If anybody tells you that gaming and casinos is about smoky betting shops or dimly lit room with old men and others dressed in really smart clothes, they're in the past. If you're not learning from this market, your competitors really are learning from it. So what's happened? When I started, and I'm 58 now, I hate to admit that, but when I started, databases and customer management were at the center of the world. And sort of analytics and big data sort of floated around the outside. Well, this Copernican revolution has absolutely put customers at the center, and that their customers at the center are through their data and their analytics. So we talked earlier about IP. This is, for me, where IP is really going to be useful, and I need that in the broadest context. Customers are not interested in being managed. They're interested in getting what they want. And I think that if you look at how that is changing, the model you're offering, being offered, is a strategic choice and a competitive advantage, not an imposition on you to have to conform. If you're not doing this, then it's strategic suicide. So we looked at BSP, which is the BetStars, stands for BetStars pricing model. And why did we set out on this sort of model? I came to it very late, but I inherited it, and it was about reducing costs. It was about improving margin, increasing productivity by reducing the number of people we had making prices, and that's a significant, and making markets, that's a significant part of gaming. That improves margins and reduces costs. Nice virtuous circle there. And then there's this massive explosion in product and combinations of product, things like player props, in-play betting. These are all things that massively derive and depend upon big data and the learning in real time, so machine learning and as well as AI. Geographic tuning, believe me, there are 50 states in the US. They're not all going to have a gaming business. But when you look at the states, it's federated. You can't break the wire act. There's lots of things I'm not going to go into here and now, but you have to have geographic tuning, and that requires you to have these highly specialized tools. Regulatory and compliance, just take another country, Brazil. I opened up Brazil, but I could only open in Buenos Aires, and the area outside of Buenos Aires is a different regulatory area and has different compliance. And the answer is, yeah, so what? Well, this is all about providing better experience. We keep going back to this. It's using data to make information, to make better decisions. An always-on responsive product is what customers want, and that's what keeps them. So I'm not going to go into great detail over this slide. Believe me, I'd take at least 4 hours. I sat through many presentations on this, but it's complex. It's incredibly complex. The data flowing into this from outside, the data flowing out and back in. I just look at this. There are 1, 2, 3, 4, 5, 6, 7 different third-party suppliers, and that doesn't include the human interfaces. And actually, if you look at things like PAM Wallet in the bottom left, that's almost like a separate financial management process that may also be outside. So but it was a great concept to say, okay, how do we create this value? Let's do a pricing model. So let's be clear, we had no technical issues. We had great quants. We'd gone for the Erlang Alexion model, which was all about these issues, about it was stable, it was scalable, it could deal with a massive increase in volume we were expecting to see both in the US and, as I said, in betting products. And it was simple code, so it was much easier to both develop and maintain. So it was scalable for the foreseeable future, and I mean massively scalable for the foreseeable future. So when we start to look at that, let's think about how people interacted with the strategy and tactics. Environments and languages, great choices. The strategy we were pursuing, you've seen the diagram, was perfect. The tactics were being employed were responsive. So purpose and strategy, unfortunately, was being delivered at the tactical level, and strategic level was just tactics. So we couldn't keep stability within the strategy. And this was about people. We hadn't brought the appropriate executive on board. We hadn't brought delegation and not abdication into this. There was inappropriate funding because the right sales had not been done, the right comms, the right people involvement. And also we had within the team, because of these issues, leadership instability. In fact, I was brought in last July to try and, July 2019, 2018, to bring stability into the program. And finally, the big thing for me is people, for some reason, had said we're going to deliver the big bang, not to deliver incrementally, which is a basic tenet of working in an agile way, in a way in which you learn as you go rather than trying to pretend you know everything up front. How did this failure manifest itself? As I said, it wasn't a technical failure. So we had a lack of purpose-driven alignment with a strategy that really made sense. We lost the CTO, the chief architect, all these people, and this senior ownership of the strategy is absolutely critical. If you don't have a senior player in the management board who understand exactly what you're trying to deliver, then what happens is responsiveness from that level of the organization becomes very tactical. Just to sort of summarize that, also the acquisition of Skybet allowed that product to suddenly drive sports betting, and they were doing something very similar to this product, and said it was a lot further forward than this one, and it turned out not to be that much further forward. And GSTP, as far as I'm concerned and aware, which is the product they went with, is still not fully functional. So it was about people. How do we sell to the people? How do we take them through what the product is? So, as I said at this, I wanted to title the talk this, but Peter sort of persuaded me not to. It's all about the people, stupid, and it will remain about the people. It's not about technology. Technology we can fix. Technology we can develop. Technology we can build. Anybody who denies those facts has not looked at this industry for the last 30 years. It just is. I can remember seeing the first Singer computer in Guildford when I was about 12 or 13. We have moved light years on from that. So we had the right product. Strategically, it was a great fit, but we didn't have the right comms and executive sponsor. It's interesting. People often talk to me about high-level technical expertise. You don't need technical expertise. What you need is an understanding of what the technology is going to deliver and why it's important. It's the why, it's the purpose, that's really the gel that allows someone to back you and give you the funding. Secondly, because of what I've talked about in terms of it was a period of acquisition, there was a lot of infighting, poor delegation, and particularly there was a massive amount of abdication. Just, we've given it to them, they'll do it. Well, that's not quite the way it works. And it was not prioritized. And what I mean by that is systematic prioritization is essential for people if they're all going to work together and do something together. The important thing here is it's not about one group or one team or one individual delivering what they consider their priority. It's about the company delivering what are their priorities, and everybody understanding. And again, the people thing, if you're not delivering the most important thing, you're not delivering anything. It's about creating that area of psychological safety that we just had a brief discussion around. So it's not rocket science. It really isn't. And if you're not familiar with the term, companies in this age of change and massive evolution, we need to understand what agile budgeting is. And I don't intend to go into that here, but effectively, it's about funding to deliver the most important answer next. It's not about setting a budget that you keep to from 15 months ago. It is about looking at the results, and I'll come on to the learning triangle in a moment, and that will help people to see where this fits. Massive dichotomy here. I am really, really personally fed up with hearing people say they're responsible. What I want to hear people say is that they are accountable. and they are very different things. And accountability is about we all rowing this behind this together, not I built an empire and I'm responsible for all these things. People need to know the story, and I've talked about that, and they just didn't know enough. Comms, and oh, did I mention comms is a sort of take over somebody else's phrase, you know, location, or education. But it is about comms because it's about people. If you don't comm to people, how are they meant to know where you're going? The worst thing is if you comm badly, you create vacuum. Once you create vacuum, that won't exist. It'll be filled with misinformation. And when I say misinformation, generally 99.9% is misinformation. You've got to therefore, in the communications to the people, fit product to the strategy that you are performing. And you've got to deliver it in a way that is incremental, what I would call agile. I'm not interested in people talking to me about safe, less, DAD, a Scrum, or DSDM. I'm interested in not the language or the deck chairs on the Titanic. I'm interested in incremental, prioritized value delivery as fast as possible. And let us not forget the agile mantra. Individuals and interactions over processes and tools. So often forgotten in my experience of working in this area. I just want to quickly cover off psychological safety in a bit more depth. You've got to create an organization. We have something we call the fluid enterprise model that we help companies to adopt. But you can see there's 6 areas of responsibility, and this really does give roles and responsibilities, and most importantly, where they're going to be accountable. So where are people going to be accountable? The CEO, she is going to be accountable for growth. CXOs, they're going to be accountable for capabilities and also with competencies and how the company ensures it has those to deliver the strategy. And finally, teams are going to be responsible for innovation, product development, product renewal, and also the tail of product, the wind down of product. What we're talking about here is the insights. So how do we use insights to create opportunity from our customer, and also are those insights deliverable at a cost that we can afford and in a risk profile that we want to acknowledge? Finally, what I want to talk about very briefly in this area is also to go and talk very quickly about the learning. The top of this chart, of this figure here, talks about actions and results. This is about the organization's people ability to change, not about speed, size, or anything else. What will they do? What are the actions they will take? And it isn't about the results, it's about how you got to the result. If you don't know how you got to the result, it's not repeatable. Eventually, that will become an experience that people will believe, and you move people from doing to being, because that becomes part of their intrinsic behavior. And then there's a positive reinforcement model on the right. So in summary, it's always about the people. You've got to think about their psychological safety. You've got to ensure that they understand the strategy. You've got to ensure that if you're replacing their role, that you're looking to make them more T-shaped and therefore have broader expertise, or use them in a different way. And you may have to let some people go. And it's also about commitment. If people, they all have what I call noses. And the noses, they can smell when the organization doesn't believe in what it's doing. So don't pretend that you're doing something if you're not. Explain it, get behind it, and make sure that there is leadership over management. It absolutely must be a led process, certainly in this area of AI and machine learning. It can't just be a management of a process. Again, we've talked about accountability and over responsibility. And finally, strategy drives tactics, not tactics become strategy. And I think that's a massively important issue in terms of aligning people, but also in terms of how companies take forward these ideas. If you don't have a learning organization, you don't have psychological safety. You just don't, because learning is all about accepting that you're going to do something different, accepting that sometimes that'll be wrong, and accepting that we've all worked hard to get to this learning, not we've all worked hard to make an error. I'm going to finish with this last sentence because I started at the top of my talk. Albert Hubbard, great, interesting guy. Look him up and do some reading on him if you haven't. But he said, one machine can do the work of 50 ordinary men. No machine can do the work of one extraordinary man. And as we look at this, and as we take Antonio's previous presentation, it's absolutely critical that as the work, like the Luddites, as the work that the machine done is taking the place of boring, ordinary work, we make sure we use the human resource in an extraordinary way to deliver value across AI and ML. With that, Peter, I'll thank you and back to you.
I am just blown away, Michael. I thought that was an incredible presentation. Matt, I think you probably feel very much the same. And Antonio, this links into so many of the things that you were talking about there.
Definitely.
I'm sure you agree. And it's what
the one thing I'd add that I didn't put in the presentation is the inability for people to engage in really experienced, and this is obviously a bit of a pitch for my company, but people spend millions, hundreds of millions on this sort of stuff and don't coach anybody. They don't help people understand that interface. They don't help people change from management to leadership. They don't help people to understand how the organization is going to evolve to their own lenses. And that comes from coaching. And people just don't do enough. And partly that's probably because they don't want to spend the money, and partly because they don't believe that coaching can actually be beneficial in this area, which is just rubbish.
Well, you're talking about people's identity here. You're talking about people identifying themselves as being someone who is an individual with power to do things, who interacts with other people primarily, as opposed to being an individual who operates a process or operates tools and can push things away and someone else takes care of it and it's not right. You're talking about very, very deep cultural things here. And Antonio, you must see this every single day in the way that you, when it's obvious to you that low code would help, you still need to overcome.
Yeah, but I think that's kind of, every new technology that transforms how people work has to go through that path. So I think it's on us. Even so OutSystems has people from the sales process and the customer success process as kind of value consultants, like people that help customers rethink, how do they do digital transformation? It's not just buying a low-code development platform. You really need to rethink holistically how you work and how you leverage this technology. So I think that's kind of true for, especially for AI and ML. For low code it is, but for AI and ML, it's kind of, you have to really shift how you think about things. It happened with, computers a few decades ago as well.
I think just really building on, like I said, the last few presentations, certainly I see the big advantage of AI and ML now giving us the correct prioritization, very much looking at people, process, and then technology supporting them. It's actually removing some of the day-to-day drudgery, letting us as humans focus on the important things and actually have that insight. I think as the medical guys pointed out, actually kind of using AI as a tool, but it still comes down to that human interaction and value judgment. And I certainly see with what we're seeing today and with the industry overall, that I guess overall approach of people, process, and technology is really what I see the big benefit of AI being.
Amazing.
Yeah, I think my experience is things fail because of comms and ownership, leadership, accountability. They don't fail because they can't be done technically. And people seem to want to really struggle with evolution. They don't get the fact that we need to evolve rather than go for revolution. Revolution is claret on the carpet and very and gets a lot of people fired, and organizations go to the wall. I mean, just look at the turnover of organizations in the FTSE 100. The lifetime spent in any major, or NYSE, any major, or NASDAQ, any major indices is just very poor. And that's because, it's either grow fast or go fast, and people haven't understood the evolutionary necessity to not wait, but to actually try little things, to experiment, to learn yourself from your market.
Yes. I'm introducing Rose here. Rose Luckin is joining us, CEO of Educate. And,
hi, Rose.
Rose is doing some really quite extraordinary things in terms of understanding ourselves.
Yes, trying.
That's a hell of a statement, but I actually do mean it. And so, Rose, we're going to leave the floor to you in a moment, but just so that you can, so you know who's in the room here, right next to me there, I have Matt, who is he's a physicist at heart, but he did maths for his degree when he was a kid, and he's an absolutely extraordinary fellow in the area of software. And Michael, deep background both in medical and consulting, people, wow, so many things.
I love that phrase about one man, one extraordinary machine, 50 men, but that's perfect. Completely agree.
It's so true. It's so true.
So true.
Straight below me here, Anthony will be joining us for the panel as well, and looking at all the legal aspects of this, which is a fundamental part of empowerment. Because if you're running an organization and you're empowering employees to go do things and do the things that Michael spoke about, where he spoke about individuals, interactions, and so forth. If you want to give people the confidence to do those things, then they must understand the legal position that they're in and what they're going to do in the companies. So these things become concurrent and connected to each other. Ian has experience in AI, and I'm not going to go through his whole CV. It's really extraordinary. And Antonio is deploying AI for automatically generating software, so that systems automatically guess what needs to be done and then they do it, and which then has big psychological effects on people who develop those things and use those things, because the speed is just totally different. So really incredible things. Anyway, I think we should make a room for you. Rose, if you could please share your screen.
That.
Wonderful. And as these things happen, I shall start rudely exiting people. We'll see you on the panel in a few moments' time. So there we go. And let's see. Now it is the three of us here, and let's see if we can get to your presentations. Are you
now? Can you see that?
It should turn up any moment. So you should. It's the share screen button, and then you go into the application.
Yeah. And you should just be able to see the slide rather than the presenter view, I hope.
Yeah, at the moment, yes, it should do, but it's not happening right now. So if you go back to your browser for a moment, please, and try it again, and just press that share screen button at the bottom first. Let's just see.
That's screen 2, share screen.
There is. I'm sure the problem was on. I'm sure the problem was on my side of the screen.
No, I think it was me. Now can you see the PowerPoint slide?
They are. It's there.
Yay! Is it just the slide, not the slide deck? Just the slide saying connect our learning to understand ourselves?
Just the front page. It's beautiful.
Fantastic. Perfect. Thank you.
I shall disappear for a little while. I'll jump back in, as you know, if things good. Wonderful.
Thank you. And thank you for inviting me to speak. I've really enjoyed the presentations that I've heard. And I think the way that you've put people together, Peter, is really interesting, because we're moving from, how AI can help augment software developers. And I was really fascinated by how people who are more expert don't want to be helped. That's a very human reaction. And then what Michael was saying about the importance of the humans, and the humans being fundamental to making the right changes happen. And earlier in the day, we were talking about humans in the loop and various other things that have really struck me. But who am I? So, my name is Rose Luckin. I am a professor at University College London. I have a background in artificial intelligence, and that I started artificial intelligence at a time when machine learning was only a very small part of the curriculum. And so it was very much a sort of cognitive science as well as the sort of theoretical computer science. It was very interdisciplinary. And I've been interested in artificial intelligence and education, and particularly human intelligence as well as artificial intelligence. And I also run a spin-off company called Educate, which works with small businesses, startups, SMEs, who are working in the educational technology space, particularly ones who are using artificial intelligence. But we have a program of what we call AI readiness that is aimed at any business, or indeed any educational organization, school, college, university, which is about helping people get ready for AI. And this is very much in line with much of what we've heard today, particularly the emphasis on the importance of data and really understanding your data and how to organize your data and what it can tell you. And then the core reason why you might use AI. So that's very much where we sit. But what I really want to talk to you about today is human intelligence. Now, I got very, very intrigued when we first started hearing about the fourth industrial revolution and what it was going to mean for the world of work, and then also what it would mean for the world of education. And I started to look at the various different reports. There's so much out there, whether it's about predicting which jobs will go, how many will go, what the skills we need in the workplace are, how much more time we're going to have, lots and lots and lots of different reports. But for me, they weren't really asking the fundamental question. And I think the COVID-19 pandemic has made this question even more acute. And so I prefer to think of the situation as being a bit like this picture. It's as if we're driving along in a car, and I'm afraid it's not a self-driving car. It's just an ordinary car with a human driver, in very thick fog along a road we don't know. Now, at that point in time, having a map is not really a heck of a lot of use. And yet I felt that a lot of the reports and the analysis that was being done with respect particularly to education and skills when we first started looking at the fourth industrial revolution was basically trying to create a map. And so I wanted to take a look at human intelligence and think about the situation slightly differently. So I saw the situation of being one where we as humans are faced with dramatic change, and even more dramatic change now because of the COVID-19 situation. And so rather than trying to do this prediction about precisely where the AI was going to hit, because as we've heard a lot today, humans can make a difference to how that AI is used and how it gets appropriated in the workplace or in our lives. You can't necessarily predict just because a technology is going to be able to do A, B, and C, that people will appropriate it in the way that means A, B, and C are precisely what happens. And so I wanted to think about ourselves as humans and actually what we needed in order to cope with these uncertain times. And so I did a lot of looking into what it means to be intelligent in the sense of human intelligence. And I came up with various different thoughts about what kinds of intelligence we have as humans. And I don't mean these are separate intelligences. That's not where I'm going with this at all. What I wanted to find was a way of talking about human intelligence that made it clearly distinguishable from artificial intelligence. And so I looked right back as when I first started studying artificial intelligence, when of course we were very much looking at intelligence, because how could we build something artificially intelligent unless we understood human intelligence? And then looking at what had been done in terms of understanding human intelligence subsequently. And so came up with this model of human intelligence that's a complex whole of interactions, obviously, but that has these different elements. And so we have our interdisciplinary academic intelligence, and that's something we very much need to build more of, both in our schools and in our training sectors, in our universities and in business training. Because if we look at the big problems we face today, such as the pandemic, really you need people who are able to communicate across disciplines if we're going to solve the big problems. And then a second related point was this notion of what I call meta-knowing intelligence, which is another way of saying cognitive epistemology, but that's such a mouthful. Nobody really wants to say that. But what I mean is understanding what knowledge is. Where does knowledge come from? What's good evidence? Why should we believe something to be true and something else not to be true? So it's really understanding much more about knowledge. And incidentally, when work was first done on this notion of personal epistemology or cognitive epistemology back in the 50s at Harvard, it was found that actually the majority of students really had quite naive personal epistemologies and still adhered to the view that actually knowledge was something that could be given by somebody wiser, rather than realizing it's something that you have to actively construct for yourself. Then there's social intelligence, which is something we prize much more these days, particularly when it comes to things like collaborative problem solving. We definitely need to have very, very sophisticated social intelligence. Metacognitive intelligence, understanding of our own cognition, something we can do very well, very hard for artificial intelligence. For humans, we can do it well. We don't naturally do it, but we can learn to do it, and we can learn to do it very well. Same with metasubjective intelligence. This is not just about being emotionally intelligent. This is about understanding how your emotional intelligence is developing, and indeed how the emotional intelligence of the people you're working with is developing, because then you're much better able to do the collaborative problem solving, to bring in your social intelligence, your interdisciplinary academic intelligence, because you have this good metasubjective intelligence. And then we have the notion of metacontextual intelligence, which I think is something that we completely underestimate when we think about human intelligence. You know, I know, not at the moment because of the pandemic, but in theory, I can travel anywhere in the world and arrive in a place I've never been to before. And with a bit of luck, I'll be able to find my way around. I might not speak the language, but I know I can call on tools that will help me. I can probably go into a restaurant. I can order a meal. I may not get exactly the meal I wanted, but I know I can do it. I can estimate how nervous I am when I'm ordering that meal. I can then realize how pleased I am when it arrives, if it's what I ordered and it's something I like. That being able to move in different environments, interact with different people, do different things is very sophisticated. And I think we completely underestimate it in our human sense of ourselves. And I think if we get all of these together, particularly those meta-intelligences, those 4 meta-intelligences, which are all about self-understanding, then we really get to the sort of gold of what it is to be human intelligence. And this is this accurate, perceived self-efficacy, where we really understand ourselves incredibly well. We understand ourselves so well that we know how to set goals, we know how likely we are to achieve them, we know that if we don't have the knowledge and expertise to achieve it now, we know how to get that knowledge and expertise, we understand how we're feeling about it, we understand how other people are feeling, and we can really be self-effective in the world. And I would suggest that actually only the numbers 1, 2, and 3 of these ways in which humans are intelligent are really accessible to AI at the moment. I mean, yes, we can, of course, build AI that can mimic emotions, but it's not the same as that metasubjective intelligence that we can have. And so I frame this as an interwoven human intelligence. It's not separate elements. They're all essential parts of our human intelligence. Some people will excel at some more than others, but they're all essential. And we can consider 5 of those elements, if we include that accurate perceived self-efficacy, about being about meta-intelligence. And I'm always struck at this point by Noel Yuval Harari's final book. Well, maybe it's not his final book, but the last in the trilogy of 3, where he states quite boldly that we really must make sure we understand ourselves, because if we don't understand ourselves, then the machines will understand us better than we do, and that would be a big mistake. So it is absolutely about differentiating human and artificial intelligence. That's what I'm keen on. And a lot of the work that I do is in education and training, and much of it is trying to get across the message that we need to frame our education and training around the things that we can't automate, not the ones that we can. But I also think there's another step to this, and a really important step, and that is this idea of building an intelligence infrastructure. I was very struck earlier by the statement that we need humans to understand the AI, right with our first speaker this morning, and I couldn't agree more. But actually, we need our AI to help us understand ourselves better, because we can. Now, if I look at learning and training at the moment, there's lots of artificial intelligence products out there. They're not used by a huge percentage of learners at the moment, but they will be increasingly. Of course, people use Google search, that uses AI, they use voice activated interfaces, and they use AI, but I mean products specifically designed for education. But there are an increasing number, and we can think of them a bit like the one in the picture here, where you have some kind of system that's trying to help you learn about something, in this instance about English language. But if we move beyond the stage we are at now in the evolution of the way that we use our AI to help us learn and to help us teach, and we think back to what we've heard quite a lot today already about data being a fundamentally important thing. And I always love this notion of data being the new oil, because just like oil, it's really dirty, and you can't learn anything from it until you clean it and you process it. And so we must remember that. But I think we also need to remember that that data is really the power behind understanding our human intelligence. And so I'm just going to give you one tiny little example of the sort of thing that I mean in a learning context. So yeah, we can collect data, as you all know. We can collect data observationally, we can collect it about how people are feeling, their heart rate, we can do facial recognition of emotions, we can map how people are moving their hands, their bodies, we can hear what they're saying, we can hear changes in their tone. There's so much data that we can collect. It's a huge ethical issue that we mustn't forget in all this. But for the moment, in terms of what we can do, we can collect masses of what I call multimodal data, slightly different to the early use of multimodal, in that I mean really broadly multimodal, so every modality of human interaction. And so if we take a situation such as this, where we have three people, these are university students trying to build an interactive toy, they're working together, we can collect bags and bags of data about what they're doing, where they're looking, where their hands are, what they're saying, what they're inputting into the computer, what they end up building. But actually, that data just in and of itself is an unstructured mess of lots of different data streams. And really, what we need to do in order to understand that data in a way that will help us understand more about human intelligence and human learning is not just to clean it and process it and normalize it. What we also need to do is to learn from the way in which, whilst the human brain has not changed in the last few decades when AI has made such huge advances, our understanding of human intelligence has developed enormously. And so we now understand much more about human intelligence and about how humans learn. So what we need to do to get the most from this data is to look at what we understand about human learning and then use that to design our algorithms. So for example, very crudely, there's various different pieces of research within psychology that demonstrate that synchrony of action can be very helpful when you're trying to solve a problem together. So looking in the same direction at the particular thing you're working on, or at each other, having your hands in the same place or pointing in the same direction. So being synchronous basically can have a real impact on how well you work together. Well, that's very easy to analyze automatically. We can collect data about where people's eyes are, where their hands are, and certainly when we did this, we found that groups of students who had been categorized as high in their skills for collaborative problem solving by a human, looking at them working, indeed were more synchronous than those who were considered low in terms of the efficacy of their collaborative problem solving. Now, obviously, I'm not trying to say that that's enough in and of itself to say, well, that group of students are working very well together. It's one little signifier. And of course, we can collect hundreds of signifiers. And now we have very good AI algorithms that can bring data together and can map different signifiers together. You can start to understand something quite complex about collaborative problem solving. And so where I think we're heading and where we need to head in this combination of artificial and human intelligence, bearing in mind we really want to focus on those elements of human intelligence that we can't automate, is this notion of intelligence infrastructure, which is comprised of that carefully selected data from multimodal sources with the algorithms that have been designed with what we now understand about how humans learn. And so we process that. And then the other element of this intelligence infrastructure is the humans. You know, I can't agree more with Michael. The humans are really, really important because they can interpret what the AI is saying and they can help the learner to understand themselves more. The human who understands the data can mentor the learner so that they can start to understand what the AI and the data are telling them about their learning process, their progress, not just the product of their learning. And if we build this intelligence infrastructure, then we can power all sorts of learning and training interactions, not just those that use technology as the tool for the learning, but just conversations between a teacher and a learner. If it's powered by this increased understanding of how that learner is learning, and that teacher has at their fingertips advanced understanding of the processes that that learner is going through, then they can provide much better human support. So I really feel it's this intelligence infrastructure that we should be focusing on. And we need, of course, to move through the evolution of the way that AI technology is making its way into learning and training. And it's a long journey. And if anybody's interested in what I've said about human intelligence, I wrote this book a couple of years ago that summarizes the research behind it. Just don't be put off by the fact it's a small girl building a robot, although I love that picture. It's about adults as well. It's about human intelligence, basically, and learning and training. And just to complement very, very much what Michael was saying when he was talking about needing to bring humans on board, and particularly the senior executives in a company. One of the things that Educate that we do a great deal is this program of AI readiness, which is absolutely about that. It's getting people to enthuse their organizations about AI, to get everybody on board and to focus on the data and the key imperative of any AI that you're going to use with respect to that data. So there's some free webinars if anybody's interested at that website. So thank you very, very much for listening to me and for inviting me to be part of this event today. It's absolutely fascinating. And I hope that that's added something of interest to the amazing bevy of ideas and thoughts that we've had so far today. Thank you.
Oh my God! I mean, there's just so much in what you just said that it's like I can see Matt jumping up and down. But I have one immediate thought. So, an uncle of mine, I'm afraid he's passed away now, but when he was a kid, he was a professor of psychology at Hamburg University, and he spent his career studying learning. In two areas, partly bilingualism, multilingualism, and also hawk about highly gifted children. And then the next area that he looked at was learning as a function of age, where there is this correlation that the older you get, the more difficult it is to learn. And that correlation is just like the correlation between old females and very few rats. That in the Western world, the more, if you have a high proportion of old females in the population, then you have very few rats. And there's a factor in between that explains it, and it's cats.
Yes, I love it.
But the correlation is there. But yeah. you could easily explain it by saying that it's because they eat rats. Yeah, I would explain it, but it's not true.
It's not true. Yeah.
Something else. So similarly, in terms of age, you could say that it's because people's brains become cubes that are disconnected from the outside. That's not true. It would explain it. Or that people's brains become hard. And
yeah, that plasticity.
Yeah, which is physically not true. They don't become hard. Yeah. So it's not. And the thing that Herr Dr. Professor Wyczekowski, the thing that he found was that the cat in the equation was attitude. And he was able to show this, that people come out of school and they stop school, or they stop university, or they get married, or they have children, or they get a promotion, das Peter-Prinzip, or they begin to draw a pension, or what have you. And people hit these things, and he was able to show that you get this psychological effect where for each big life event, there's a probability that you say, oh, I can't be bothered no more. And then you have an exponential decline. And if you take the sum of all those exponential declines from people who say, I can't be bothered, then the net effect is that you do get that correlation where the ability to learn is higher and then goes down. However, and this is the example that Billy did on me, sorry, Dr. Professor Wyczekowski did on me. What he said was, look, take yourself as the example and ask yourself, compared to yourself at the age of 16, if you have two identical pieces of work and you need to nail it, you have 10 hours standing start, would you now understand this faster, or would you, as the 16-year-old that you once were, understand this faster? Who wins in this 10-hour race? And for most of my friends, certainly everyone on this thing, I spoke to Matt about it just the other night, no brainer. We now as older people would wipe the floor with us as 16-year-olds. So our attitude, I know with Matt, his attitude has never changed. This man here that you see next to me, he will remain a kid for this particular life.
Well, that's good. Curiosity.
Mm-hmm.
Yeah.
So,
childlike is good.
So the human side, as you say. Sorry, and I've sort of just jumped in and said what I immediately felt, which is a bit unfair because I know that Matt has a bunch of questions. And Ian has a bunch of questions, and I know Tony will have questions about this as well. And I know Michael is a very shy type, so he's very unlikely to say anything. But I don't know where to begin. Matt, do you want to say something?
I think it's just such a fascinating conversation and sort of topic. And as you were talking, Rose, I was thinking through things like Daniel Kahneman, and his System 1 and System 2, and will we ever get near to System 1? And if we, on our work with sort of digital assistants, we're looking at things like, we can get them to tell us what the weather is, but irony, sarcasm, and humor are just so far away. And it's sort of, will we ever be able to bridge those gaps, do you think, or is it just something that it will always differentiate us from machines?
I think it will always differentiate ourselves. And actually, Kahneman's System 2 is subdivided into two versions. And I think it's there that gets really interesting, because I think the kind of algorithmic thinking we can automate, but it's that meta level, that self-understanding, and that understanding of others in that empathetic, having experienced it kind of a way, that is very difficult for AI. And I mean, you could get into a whole conversation about consciousness, which is not something I think we should do, but obviously that comes into the equation as well. But no, I think it's just earlier there was the example of the Go algorithm that DeepMind built, and I often think about that and think, yeah, the AlphaGo, brilliant system, beat least at all at the game of Go. But my understanding is that Go as a game is actually a cultural game, and part of the object is the relationships you build with the people that you play. Well, I suspect AlphaGo didn't do very well at that. So it depends on how you evaluate things. And I'm also struck when we think about these examples of how, I was at university when Deep Blue beat Garry Kasparov. And I remember the excitement of that. And then a kind of realization that vision was so much harder than playing chess. And yet we took so much for granted. And I think we're still in that space where we take a lot of our human intelligence for granted. But I think a lot of our education systems have basically focus on the things that we can automate. And it's understandable because we want to be able to assess in a way that we understand. And in a way, we break things down to such an extent that, of course, you can automate them. So it's a bit chicken and egg, but we need to move away from just focusing on the things that are so susceptible to automation and work out, well, of course, things like literacy and numeracy are fundamental. But above that, what are the core things you need to know in order to be an effective learner? So that then, well, I might not know that now, but I know how I can learn that and how I can use AI to help me learn that. So I think it's a mindset as ever. We need a mindset shift.
I think the two things that come to mind for me is that Picasso probably said, using a different language, that computers are useless, they can only give us answers, which I thought was very good.
Yeah.
And I think also someone the other day said that we've now got something like the highest prime number had 2 million digits or perhaps more. And I thought, but a computer can't prove that there are infinite primes. And Euclid did that way before any computers came along. So these are the things that fascinate me.
Yeah, yeah. And I think that's what we need to remember. I always say I love AI, but I love humans more. And I think we need to really remember that.
Well, I was talking to Andrea from Nature about these things, and the Einstein's second law of thermodynamics is a silly little thing which proves one little thing. It proves that time goes forward, and it's the one that's not reversible, and that's a kind of a significant thing to prove. And so time can stand still, it can be variable, but it will not go backwards, it will not go forwards. And that's what that thing says. And that's the sort of thing that it's such an anomaly that I don't see, but that's probably just me, I don't see how it would be possible to use AI to gain that insight. Where sequencing the genome, with all due respect, it's hard work, but it's kind of hard work. It's not sheer brilliance. Michael, the quote you had, this extraordinary man quote.
So good.
Thank you. Yeah, it's what started the white paper that we wrote on Fluid Enterprise. I'm particularly interested in what you said about people's ability to learn as they get older, and what Matt really referred to the issue of system-wide system thinking. What about pattern thinking and the ability to,
Michael, would you mind putting in your microphone or headset or something that you had earlier, please, because the audio on that was.
All right, sorry, how's that?
Something has glitched. Might be the connector into the PC itself, which is a bit loose or something. I don't know. We can hear you, but
is that any better, Peter?
It's okay. It's like a 1930s radio.
Come back to me.
There's a soft crackle.
we will fight them on the beaches. Okay, we'll come back to you in a second.
So, Rose, I'm really interested in what you're discussing there regarding this intelligence infrastructure and also personalized learning. Do you think maybe too early at the moment, the actual crisis we've all gone through on the last 4 months or so, and the way that teaching's had to adjust to being remote and offering sometimes a more personalized experience, can you see that moving forward as a common way to teach and educate?
I think it has to. I mean, the answer to that, in all honesty, is it depends where you are in the world. Mm-hmm. It seems to me the most likely scenario for the next few months, possibly years, is some hybrid situation where some children are physically at school, some children are at home for part of the week, for all of the week, and we're going to have to work in that way. So we have to use the technology effectively. And I think a lot of barriers have been broken down when it comes to a greater acceptance that technology has a useful role to play in education, because I think education was one of the, if not the only remaining sector where people didn't think technology was necessarily a good thing. And so I think it's helped with that. But in the UK, I can see us pulling back to where we were previously, rather than thinking, no, this is the moment to do something bold and different, because we can do something bold and different in a crisis that would be actually really difficult to do. And so we've broken these boundaries. You know, I thought it was classic that Oxbridge colleges started making lectures available online, something students had been asking for years. And they were told, no, it can't possibly be done, copyright, blah, blah, blah. Yeah, it could be done overnight. You know, we've had a lot of examples of that, which has been great. But now I'm slightly concerned we're sort of pulling back into our comfort zone and missing the opportunity. And particularly to rethink how we help learners, trainees, workers in disadvantaged communities, which is where I think an AI augmented approach could really, really help. I mean, thinking about that stat of 1 million software vacancies unfilled, you know, thinking about people who need retraining, thinking what we could do if we used our AI smartly to help those people retrain is where I think we should put energy, whereas I don't think that's what's happening everywhere. It is in some places, you know, there are some lights in tunnels, but it's hard to get people to do something radical. And the argument against doing something radical is always that there's a risk that it would damage the people that you experiment on, which I completely understand. I thought before the pandemic we were at risk of damaging people because we weren't doing something radical. Now we've had the pandemic that's created a context in which we could do something. It feels like now's the moment. But it's a bit like, I think, what you were saying, Michael, when I think about leaders in education and training, and I don't mean individual head teachers, I mean top leadership, particularly in government, there's no understanding of this stuff. There's no vision that understands the power of AI in this context. So it's hard to move forward.
I think, Rose, you're making a very good point. Can you hear me now, Peter? Is that working well?
Perfect.
Much better.
Yeah, just... I think there's what I was saying was I recognize the system one, system two thinking, but also I'm very much aware of pattern theory. And I think a lot of what you're talking about is based around the inability of people to give up vested interest. That's where people sway towards management over leadership. It's a very... Yes. Leadership's a very, I like most of you, I've run companies, I've been a CEO. It's a very lonely place to be a leader at times. And I think that the warm blanket of patterns is incredibly inviting. And
yes.
Yeah.
And leadership's scary, you're right, and lonely.
Yes. The biggest, I always talk about the F word in the boardroom. And you can see people shrink back, especially if I'm in a FTSE 100 boardroom, and they think I'm going to swear, and I say fear. And you can almost palpably see the fear disappear, but then also return almost as far.
Well, the F word in education is Finland.
Yes.
Oh, really?
Yeah.
And why
Well,
would you
because
say
they're
that?
so good.
Ah,
And so if you say to anybody in educational policy making, well, if you look how I don't want to hear about the F word.
well, what do you think about their latest experiment in Finland? They've reshaped education very recently, like last year or so.
I think it's bold and it's brave, and it'll be interesting to see how that works out. I think there are also really interesting things happening in Estonia.
Finland's dropping down the rankings a little bit after
it
that
is,
change.
and that's interesting. I was talking to Andreas Schleicher at the end of last week from the OECD, and he despairs of the UK because we won't take that risk. We won't take that risk to try something bold. So Finland may drop down in the short term, but it will more likely pull up again in the long term. I also love the way that Finland has the 1% approach to helping the population understand AI. I'll just imagine if that was here.
You've heard about that.
Yeah, because
I was supposed to say that. That was my secret.
Sorry. You know, I think if we were doing that here, it would be, we're going to get 2/3 of the population. It would be something completely impossible. So we never reached it. Whereas 1% is just perfect.
But
and then you get another percent.
They've done it. They've gone over. So they've gone over 1% of the population who have completed an AI course, and I've also completed it. And it's not a trivial course either.
No, I've done it. It's good.
It's incredible. It's incredible. But so I mean, the UK is in the middle of its big experiment from 1951. I think it was this big idea with doing A levels. We have 3 subjects at that level, which was a radical move, and as opposed to, say, the baccalaureate approach where you have 12 subjects or whatever. What's your take on that? I mean, how many subjects should kids study?
It's a very good question. As I said when I was speaking earlier, numeracy and literacy, absolutely sacrosanct. You have to have those. I would add data literacy to that as well, increasingly, because I think you really need to understand data, to understand the world, to understand yourself.
Wow.
Now, when it comes to the other subjects, I would say it's more about understanding how the other subjects are related to each other. So you need to see a broad spectrum of the subjects that exist and why they're there and how they've evolved, and then select the ones that you are interested in. But in order to make that decision, it's this business of understanding yourself that's really important. I have this dream that if we get it right, we'll have people who don't have a set of qualifications. It's much more of the, if you like, the portfolio, but it's much richer than that. It's something they own because they own their own data. They understand their own data. And so if they're going to a university, they know what to tell the university. Well, here's what I'm going to select from what I've done, because that's what you need to know in order to know that I can complete the course. Or if you're going to an employer, you say, look, this is what I've achieved. I've done this, this, and this is why I can fulfill that role. So it's kind of changed. Now, we're a long way off that, obviously, but I think it's much more about understanding how to learn, understanding yourself as a learner, but also accepting that you're going to have to learn throughout your life. It's not going to stop because things change quickly.
Yeah, I think that's a major change, Rose. I think
it's huge.
It's moved. We've moved significantly from, the phrase "job for life," where you learnt what you needed to learn. 40 years later, you were still doing it.
Yeah.
Well, hello, I've changed my career 5 times. I'm 58. I'm not a chicken anymore, spring chicken anymore. But that I also did a master's degree without doing a first degree, which was almost unheard of, and I did it at a Russell University, not some Tim Pop sort of false private university. So what I would agree absolutely is this: people need to engage with self rather than they engage with news or fashion, and I mean that in the broader sense, not in the clothing sense only. And I think that's a challenge for the UK. I think we're a very fashion-led, immediate environment. That the last time we went through any major change was 1939 to 1945. And most of those people, I think that's why we hang on to them for so much, because those people were the last people to really change in this country.
Yeah.
Everybody else has sort of been massaged along like a piece of putty and not really evolved.
I had a couple of sort of wonderful experiences when I was in Vienna about 5 years ago, and I was talking to someone about fashion, and they spoke about fashion in the 1870s, 60s, and how that evolved. Women's clothing changed very, very quickly because of the big parties that Franz Josef was, der Kaiser was doing. And he had the equivalent of raves, where they had 5,000 or 10,000 people at these big balls. And that was then the Strauss music for all these waltzes and so forth and so forth. And that was a part of, historically, of him taking money from everywhere and building Vienna into his view of what a fantastic capital should be. He redid the river, redid everything, opera, everything else. And sort of listening to Strauss music without the context of the clothes and the way people danced and the conventions around that, and without the historical context of him really trying to make that into the center of the world, but doing it without innovating, which then meant that when Bismarck came along, he was able to win those battles because they had not innovated from a technical standpoint. So Bismarck was able to win the battles easily, simply because they had cartridges for their rifles instead of top-loading them because of the culture. So all of these things were linked. And so the thing you said there, Rose, about connecting these different things, I wish they would have, because I remember as a kid when I did history at school, all these dates, they mean nothing to me. But if you talk about Beethoven.
Oh, hello.
Peter, you cut out there, Peter.
Yeah, sorry. When you think about Beethoven composing some of his music while the guns of Napoleon were outside Vienna, that's extraordinary. That makes it very different, and it puts a totally different color on his music. So I like the thing that you said there about connecting things. I think there's a lot of validity to that. How do you do that, though? How can you implement that in reality?
Well, it's very, very difficult. Now, I went to a red brick university as an undergraduate. There weren't very many universities that had AI courses, so I went to Sussex, and I went to Sussex when it was truly interdisciplinary. And that was wonderful. But it disappeared, and I became a pro vice chancellor there. And I remember sitting in senior team meetings with people going, "Oh, how do we differentiate ourselves from all the other universities?" And I can say, well, we were different. We were interdisciplinary, and we didn't like it because it was different, and it was difficult to sell to students. So we changed, and now you want to be different again. Yeah, but so putting that aside, the reason that it changed was because it was difficult to sell to students, because students at school studied subjects, and then you expected to do a maths degree or a physics degree or an applied physics degree. And then I remember similarly having a conversation at a research council review meeting where they'd had a program of interdisciplinary research, and the review committee was asking various different questions about what the challenges were, and the various principal investigators from the research projects were saying, well, we've built capacity, we've now helped train researchers to be interdisciplinary, but there's no jobs for them to go to because people advertise for an economics lecturer or a maths lecturer or a physics lecturer. And so there's both ends of the spectrum, we're kind of stuck in this very disciplinary state when it comes to the teaching part. And I think one country that's made a very bold and interesting move in this respect, and it's something we might learn from, though we do things differently, so we can obviously, you can't copy one country, but you can learn from them. And that's Taiwan, where they changed the qualification that takes you into university. So they altered that and made that more interdisciplinary, because then both ends have to change, because you've changed the important thing in the middle. So it was very smart. And I'm not saying we could do exactly that, but I think we have to think innovatively, and this ought to be a moment to do that. I mean, to think, well, what is actually fixed? What has to stay the same, and what could change?
I must say, I love the way you're thinking, Rose, because one of the things that I've spoken to Antonio about. Sorry, Antonio just joined us from OutSystems. He's working on low-code. And so we've been talking about sort of, okay, so how do you prove and how do you benchmark, and how can you sort of on an individual level grow, and how can you as a company grow, and how can you make all these interactions more efficient and so forth? And Antonio immediately just said, okay, well, you can look at this one, this one, this one, this one, and you can look at that one, that one. That's good, that's nice, that's awful. And the way that Antonio sort of floats around these things is he doesn't care if it's from any country or anything. He's just looking at what works and what might work in the future. And that's 100% where you're coming from as well, Rose, if I read you correctly, that it doesn't matter where it comes from. Give me a good idea and I'll take it. I'll copy it. I'll be proud to copy.
Exactly, but you have to recognize that there are cultural differences, and you can't just import it. You have to see how it integrates and how it works for you. But I think it's obvious. So obviously, sometimes I think it's not worth saying, but I will, and that is, of course, the tail that wags the dog is always the qualification. And as a parent, you want your children to have the thing that's going to get them to the next stage. So changing the qualification is a really difficult thing to do, but it's very powerful, because that's why so many things are done the way they're done. It's a cheap thing.
I'm fascinated by this phrase, because someone a long time ago said to me, you'll meet very many clever people in your life, Michael, but a lot less intelligent people. And what he meant was that, what he meant was that, I'm telling an educationalist, what he meant was, people who can learn and absorb stuff, do the 3 A levels, go to university, become a doctor or an astrophysicist or whatever. But people who can actually take known information and apply it to novel solution conceptualization. He said that's pretty rare. In fact, the very few of those. And I think if we as an education system, as a continuous learning organizations, which I'm very keen on, it is about, have you created the environment where people can experiment and apply intelligently things they know to things they don't understand how to solve.
And sometimes they fail.
Yes.
And that's okay.
Yes.
But unfortunately, it often isn't okay at the moment. So that's problematic.
That's psychological safety, or other.
But I think there are softer ways that we can progress. I mean, I think the power of the intelligence infrastructure that we could and should build is also that it provides a mechanism for assessment and evaluation that means that perhaps you can gradually move away from those exams and tests that do make it difficult to change. So you're kind of putting something in, you're backfilling to try, because I'd much rather do the bold radical thing, but it's not going to happen. So you need to kind of give people some security. And I think that might be one way. But yeah, the fear of failure amongst leaders on this kind of thing is
you're using my F word again.
I'm sorry.
Stick to Finland.
I think it's one thing that we look hard at. People are allowed to make mistakes. You just need to learn from them and perhaps do something a little differently the next time. Because when you jump on errors, you stifle creativity, you stifle thinking, and it just disappears forever. And people get so afraid. And the concept of leaders eat last, but sometimes people are so afraid to put their hand up and suggest something because someone else may say, well, that's radical, or that won't work here. And it just stifles creativity, especially in a software industry that needs it more than ever.
Yeah, that's so true.
I have a little game I play when I coach senior execs, and I say to them, right, I'm going to sit in meetings with you and say, and count how many times in a meeting you go, no, but, however. And it's a really clever, and not invented by me, which is why I'm saying it's clever. It's a really clever tool. Hi, Henry.
Henry Terho from Finland. Just joined us here, Kentinel. Sorry, Michael, I didn't mean to interrupt.
Yeah. So I think that analysis, it goes back to what I'm talking about coaching. You know, not enough people are coached, and coaching isn't about teaching you something. It's about getting someone to polish more of their own lenses to look at how they behave. Now, that may require some mentoring at some point, but coaching and making people really reflect on how they're applying their models, how they're applying their patterns, how they're thinking at different times, I think is fascinating, because it's clearly a problem for a lot of very senior people.
I think going back to what Antonio was saying earlier on, Sydney, with the low-code platforms, there's a huge opportunity there to get other people into the software industry where perhaps you don't need totally robust software engineering background if you can apply your application knowledge and business knowledge. And I think that's certainly where, from a software industry perspective, we're seeing AI starting to have dividend now, in that we're broadening our capability mix in actually bringing other people into the industry. Antonio, I don't know, what's your view on that? You're seeing it for first.
Yeah, it's 100% aligned with where we want to go. That's kind of the key driver for us in using AI here. So low-code platforms generally are already doing that. They're already bringing people. You have some amazing stories of people that came from different backgrounds. They weren't software engineers, never thought they would be doing software development. We have people saying, "Oh, I always thought that doing software development was for those people," and we actually have quotes like this: "Those people that wore glasses, were the top students at math. Never thought I was going to do this. I was unemployed. I maybe took a course that doesn't have a lot of demand on the market, and then I just saw an ad for OutSystems certification. I took it, and now I have lots of demand in the market. I'm having so much fun." We believe, and we see this a lot with STEM backgrounds, like people from chemistry, architecture, lots of people kind of changing kind of careers. We really want to bring that even lower. We really want to bring the barrier of entry even lower. And that's one of the opportunities we see for leveraging AI and kind of allowing us to rethink what could we take away from the developer experience that does not require you to have developer expertise. Like data modeling is an example. Like people have to know about foreign keys and all of these things. What if we could take away of that? Could AI fill in the blanks or help you have a more natural kind of interaction with the system to get to your goals? That's kind of what we're trying to achieve, really.
Peter, I was going to hop off and let other people come into your studio.
Okay. Sure. Let's see. There we go. No, I think. Okay, Michael's gone off for a while. All right.
I can do likewise, Peter. But before I go, not really a legal point, but I do sort of Rose's sort of idea that not only is AI being used to basically do menial tasks and let the sort of the extraordinary power of the human sort of interpret that in the right way, but sort of looping back and the idea that you use artificial intelligence to empower human intelligence even more. So I really like that concept, Rose.
Thank you.
Yeah. So on that note, I think I'll make room for other people in the studio.
All right. No worries. Thank you, Anthony. Fascinating thought. We have two people from Finland here in the room at the moment.
Hello.
And we have one sort of fake Finn as well. So we have Sami, who is very senior within the world of intellectual property, and we have Henry, who lives in the world of thinking about data and code testing and changing and how you manage those various flows and so forth. And I'm kind of a fake Finn as well, because I am Finnish, but I've lived in England for a little while. I keep the accent as strong as I can do, but it is being challenged by living in England for a while, I must admit. And we also have Malika here, Malika just joined us from Microsoft a couple of seconds ago, which is wonderful. Malika's going to be talking in an hour from now. Hold on, is it now?
It's in half an hour, I think, Peter.
Half an hour from now, exactly. I thought it was good. So cool. Now, I just wanted to explore this sort of Finland angle for a moment. So, Sami and Henry, you guys live in Finland, and one of the things that I love and hate about everything Scandinavian is that everyone always has the same opinion.
I disagree.
That's the same opinion.
Once you come inside the country, you realize it's totally not true. But the media impression, when you read the media, so the media tends to be very, very much in line with each other. If we asked individuals to go, yeah, that's just the media. but so you've had some revolutions in education here over the last year, 2, 3, 4, 5. So from a position where you were totally overperforming and so forth, you decided, okay, ditch that, let's try something totally different. What's your take on that? What's your perception of that?
Well, I, of course, having the university background and I've been teaching in the university, I think it's a really bad thing that they really shifted the money from education to somewhere else. And I think that's going to hit us really hard in 5 to 10 years. As now is time that we really need an educated workforce, and now they've decided that higher education isn't really a priority in Finland. And for example, myself, I left the university because of those changes, pretty much. So I have a pretty hard opinion on that it was a shitty idea.
So that's a slight criticism. If I read between the lines, that's a slight. I love it. Bang.
Yeah.
Sami, how do you see it, Sami?
Yeah, I agree with Henry, and my opinion is based on the fact that I have 3 teenage kids in high school. One who just graduated from high school and is now starting university life, and having wife in as an academic in Finnish university. So I have seen from very close all the effects of cutting the funding and overall making lots of efforts by the politicians to ensure that everything looks nice on a paper, but in the real life it doesn't work. And like I'm opposing the new initiative to basically increase the mandatory school life to 18. That's not going to solve the issues that they have in the middle school and kids dropping out from the kind of further education. So yeah, I'm opposing those.
And so, I mean, cutting the funding is obviously not a good move, but what more was behind that? Because Finland was doing so well. What was the thinking behind the changes? Do you know, other than financial?
I don't know. Maybe it's because that we were doing so well. Maybe we were overspending on it or something like that.
Oh, okay, so they thought they could do it for less.
The average salary of Henry, the average salary of Finnish teachers 10 years ago was significantly below most European countries and significantly below the UK.
And it still is.
Interesting.
Yeah.
So it's not the salary.
Yeah. I'm afraid that it's the same reason that's why so many well-functioning organizations are doing organizational changes, just because there's someone who wants to do something on their free time.
Yeah.
There's a slight criticism in there as well. Somewhere.
Slight. There's been a lot of this like glory hunting kind of thing, that restructuring the Finnish universities to get better stats, just for stats and not for actual results, like combining universities to get into higher standings because of the amount of publications, and kind of trying to
play the game and starting to play just the numbers and not the actual results. As university education is something that's a long tail effect, so you don't get the effects until 10 to 15 years, and they're typically quite major effects. Looking at some of the research that's been done, most of the successful companies that have been founded, they're always founded next to universities or highly regarded technical universities. Of course, in the US, this is pretty much Ivy League that does it, but in Europe, it's actually quite democratic, and also in Finland, quite democratic, built around a lot of the universities. And I'm kind of afraid that this effect is something that's kind of going away. And also one thing that just came into my mind is that what we are actually doing is standardizing our university systems to the European standard. Previously, we had a bit of a differing system that we actually our master's thesis took 6 years. Now we've standardized it to the US 5 years. And the same with med school. It used to be 8 years. Now it's been standardized, I think, to 6 years now. But we're still trying to cram all that education in there, and that's always been a big problem also. And kind of changing the way that we do things just to conform with the European standards, I think is also one of the drivers behind there. And I'm not going to say if it's positive or negative, but I think it's one of the drivers for change. For example, we used to have what amounts to technical universities and then universities, where technical universities operated on the mandate that we train highly technical people for the workforce of Finland. And of course, that differs totally from the generic mandate of universities, which says that we want to offer people high level of education and public, what's the word that I'm looking for? Kind of we are not doing it for the money or for anything else. We are just doing it for the public good and the education of people. Whereas technical universities were totally focused on training people for the companies.
Yeah,
that's amazing. Philip just joined us 2 seconds ago, so you'll see him further down there somewhere. Philip's in Boston, Harvard. Philip, you just caught the tail end. Did you hear the last of that conversation there? We've had some blistering discussions here about education. Rose is thinking about how to model the UK's education going forward. And Finland is seen as being a role model in many ways. However,
well, it's seen as being a role model. I think it's before the change, to be fair.
Before the change, okay.
Before the change, before the change. But I
think we are still doing okay on basic education, but on higher education, we are not doing that well.
But I also think it's interesting that whether it's the right change or not, there's a boldness about being willing to make a change in Finland that we just don't have here.
Yeah.
And that's it's that lack of, it is, I'm going to use Michael's word again, he's not here, it is that fear in leadership that I think means that we can't do that change. That dramatic change.
Is it also a question to some extent of learning the wrong lesson? I look at school uniforms. So my beloved children, they've gone through their school uniforms. I have one still in uniform. And I look at those uniforms, and you're looking at leather and wool. And 200 years ago, those materials were selected because they were the best. So they selected leather and wool because it was the best. Now, 200 years later, we've learned the wrong lesson. Instead of learning the lesson that we should be selecting the best, we've selected to learn the lesson that we should choose leather and wool. That's silly. Because the right materials today are not leather and wood. If you look at a normal 4-year-old playing out on the playground, they're stupid materials. You go to any shop and you can buy better. You go to any Zara shop or H&M and you can buy better materials in synthetic for kids. So is it the case that when we think about education that we're sometimes learning the wrong lessons, and we're judging based on our own identities? We feel that I did physics when I was a kid at the Royal Institute, and for that reason I feel that my kids need to do the same, because otherwise I chose the wrong thing and that would make me a lesser person. So what are the psychological trips here? I mean, you must be wrestling with this, Rose. What's going on?
Well, I think you're right. You've hit on something that absolutely is the case. I think everybody understands education because they went to school. And I think educational professionals haven't necessarily done themselves any favors by not, particularly in universities, by not communicating more effectively to the policymaking space. And so you do tend to get people who feel, and they probably feel it for the best of reasons. You know, I had an education that was like this, that's done me well, that's what everybody else should have. And it's very difficult to get people to move on from that. So it is that comfort blanket. It is that, well, we know how this works and we know how to assess it, and I've done all right on it, and therefore why should we make radical changes? And I think that's where there's a real difficulty. I do think we don't necessarily, it's a bit like the point we were making earlier about the two most important things being the data and why you're using the AI, what you want the AI to achieve. I'm not sure we're always clear on what we want the change to achieve. You know, in the UK, we've got a history of changing the structure of our education systems. Most people who make a change bring in a different sort of school or a different sort of funding mechanism. And that, I think, feels like something you can do, but it doesn't actually really address the core issue. So I think there is perhaps the other thing, and this is something I find deeply frustrating, is that we don't look at our own data. We don't learn from data. We really, really don't. You know, with the AI readiness webinars we've been doing, we always have a guest from a school or from a college for the educator track, or from a business for the business track. And it's really interesting when you talk. We had a wonderful head teacher who's had a brilliant career as an advisor, and she had lots of data at her fingertips, but it wasn't ever really used to understand the bigger problems in the way that a data scientist would use it. And I think if you look at the higher level, that we don't do that. So we don't really use the data that we've got. We don't collect the right data either to really understand what the problem is. And therefore it's hard to know what the possible change that might be. My guest last week was an ex-principal of a further education college and now a chair of governors at FE College, and I wanted to talk to him about data. And I said, well, what data do you have? He said, well, we only have the financial data that we have to have because we're legally obliged to have it, and anything that we have to deliver for accountability purposes for standards.
I think in many ways, Rose, it can also be even worse. So, for example, I've spoken to many people and said, "Oh, you sure this is the right approach? Should we think about it more?" And of course, you can go to Google now and use confirmation bias. Google is the best platform for confirmation bias. So they come back with 100 reasons, and they're all good reasons. And then the other person comes back with another 100 reasons. And somehow we're in this sort of data cesspit where you can confirm anything you like if you look in the right place or the wrong place.
But I think you've got to start with what the challenge is. You know, what's the core thing you're trying to address? And then what's the data that will tell you about that core thing? And is it the right data? And what can you learn from it? And we just don't do that.
So, I mean, this is so similar to the discussion we had with Philip earlier this morning. If we think about, so Philip is trying to, there's a tiny little task he's undertaking, which is to work out how to make healthcare affordable 10 years time from now. Because if we continue to just simply add personnel, then we will need to reduce the level of care. So somehow he needs to crack that, and to do that, Philip is using vast amounts of data in order to make healthcare more precise and to a great extent revolutionize the way that evolutionize maybe, but it's at quite a fast speed. I mean, Philip, the changes you're making are fast, and your reliance on data. You were talking about it earlier. I mean, your data must be good.
Well, I think the comment that Rose is making about not using data really to its fullest extent, I think that absolutely resonates with healthcare, and perhaps I think healthcare may be somewhat different from the educational sphere, in the sense that we generate enormous amounts of data. So the data is available. It's not that we're not gathering data. We're gathering, geometrically and exponentially larger amounts of data all the time. The problem is we just don't use it. We don't analyze it to its fullest potential, and I think it's a lost opportunity that I think we have the opportunity to turn around. It's just that we need to, I think, adopt a sort of a paradigm shift in terms of how we approach this. And I was sort of smiling when you were talking about the example of the educational institution that only kept the required kind of financial accountability data and the metrics that they're held to account for by the regulatory bodies. And I think to a large extent that's also how many healthcare systems function. We're both kind of in highly regulated industries, and so we sort of follow those requirements, but that's kind of where it stops. And I think that we have to be more ambitious.
Yeah.
And I think that we need to sort of ask ourselves, what is the art of the possible? And I think that I think that data really is leading the way, or represents the future, and how we can really have a different kind of a paradigm shift. But it really does require, I think, that we have to kind of really consider a lot of really fundamental assumptions that we've operated with for generations, and try to look at things from a different perspective. And I think in the case of in healthcare, we need to think more like other industries do. And I know many of my physician colleagues are deeply offended, when we sort of use like manufacturing analogies, that healthcare is not, healthcare delivery is not like making widgets, and I agree to that to a large extent. But I think that there are some important analogies whereby I think we need to, on some level, think about the care encounters that patients receive do represent the production of the healthcare system. And I think that there is some inherent value in thinking about it from that perspective, and then adopting more rigorous approaches to understanding how we do what we do, because frankly, I think in many cases we just don't know, because people, it's so complicated. We haven't really taken a rigorous approach to trying to understand how we do what we do from a manufacturing perspective. So I think there's a lot that needs to be done, and I think that data really, big data really represents a way to get there.
Yeah, there's a lot of interesting stuff going on in Finland. The healthcare sector we've now pretty much transitioned into a centralized healthcare data repositories, and that work is still going on. But looking at you said like the manufacturing efficiency type of stuff, we have Coxa, which does a lot of hip surgeries, and they only do that, and they have applied a lot of lean principles and other stuff on the way that they manage that kind of operations, and they've gotten really good benefits out of that. Even though managing doctors is always a difficult issue.
Absolutely. No, but on the topic of Finland, I just want to call out, I think one of the really important things that's happened in Finland within the last couple of years that I think other countries should be looking at, and that's that there was legislation passed at the national level in Finland defining the secondary use framework for healthcare data. Because I think what the challenge that we see in many countries with GDPR and with other data privacy regulations is that there's oftentimes conflicting and overlapping legislation that on the one hand defines the patient's right to privacy and data security and creates a mandate for protecting that. But then on the other hand, there's oftentimes a mandate for the healthcare system to use its own data to, for quality assurance and continuous improvement. And those two things directly conflict in many cases. Sweden is a good example where we've done a lot of work. and they have these overlapping legislations that kind of creates it's almost a paralysis in the public space about, well, what do we do? Because you have some people who are saying, well, if you're linking data and analyzing data for patients, that's violating, the sort of the data privacy rules. And on the other hand, you have people saying, well, but we have a mandate from the government to use that data to improve things. So what do we do? And I think Finland, it really deserves a lot of credit and for the leadership that they've shown in terms of clarifying this. And so I think that's a great example and something that I think can really help serve as an example for other countries.
People take it very seriously in Finland, in my experience, and I really like that. And I think, I've lived outside Finland now since I was a kid, since I was 11. So I am a Finn, definitely, but that's not going to be washed out of me ever. But I must admit I'm slightly diluted, I find it fascinating to listen to Sami and listen to Henry. Of course, this is cheating because they're friends of mine, but it's fascinating to listen to how seriously they take it and how driven by facts, and so the personal experience and the facts and what should we do. And there's a very strong awareness among people, in my experience in Finland. People really are thinking about this. In the general population, you can have a reasonable conversation about education with people that you've never met before, and I think that's quite interesting. And it's people take education really seriously. I like it. I think it's a wonderful characteristic.
I agree. I think that's so valuable because you have to take it seriously, and I don't believe that we take it seriously enough. But it is difficult to get people to move away from what you were describing as the wool and leather. The thing that you've always had, numeracy and you've forgotten the reason. Yeah, but I think that it is about getting your assumptions out as well. I was intrigued by what you were saying about the changes to the Finnish system, and if I understood correctly, when I asked about the fine, obviously the money was cut. It sounded as if you were saying that there was the thought that the system was costing too much and you could do perfectly well with less money. And that's kind of a really interesting assumption. And I think often we don't make our assumptions clear enough, as to why we're doing things a particular way. And that can get in the way of change as well, because we've not actually externalized those assumptions and got them out there as a specific influencing factor, and then perhaps realize they're wrong.
Yeah, and I think that one thing that kind of, in addition to the fact that people prefer to stay in the current situation and keep up doing what they have been doing 200 years, but now what I see as a kind of a dangerous aspect in the changes proposed is that, okay, now people are starting to use data, but they are using data selectively, and there's no clarity on and no kind of visibility on, okay, how trustworthy is that data, or have you been selecting data to fit your political purposes or your viewpoint of the world, and not really trying to learn from the data, but use the data to support whatever opinion you had before looking at the data.
Yeah, this happens a lot, also not maliciously, but accidentally. For example, one case that, because I've been involved in the Finnish startup scene for quite a while, there was this really big scientific article that Finland is doing really well because in the years 2010 to 2014, we had a lot of new companies being founded, and using that data from that time frame to justify that. But what actually was happening at that point, but that was the time that Nokia laid off a lot of people, but they gave them 1 year of salary if they founded a company. So everybody was, of course, founding a company who was leaving Nokia. So it's again, this like externally these that kind of ruled that data set that you didn't see from that data set if you didn't know what was going on behind the curtain. it's the same thing that then was happening, that, hey, why do we have so many companies failing in 2016 to 2020? Well, because nobody really meant to found any kind of companies anyway. They just want to get the company to get the bonus, or these are the kind of effects that you cannot get from just looking at the statistics, and that's always dangerous.
Yeah, it's amazing stuff. It's amazing stuff. Wow. So we have a few minutes left here. In 9 minutes' time, Malika is going to tell us about artificial intelligence in financial services and cloud migration and things like that. She's a rock star in that space. So, but that's on the other line, on the other link that starts in 9 minutes now. I actually love the way that we've sort of gone here from a purely numeric world into human beings, and now we're sort of back in numbers again, because ultimately, if we want to make this better, then it will be driven by statistics to a great extent. A bunch of human beings that need to be described in numbers. And if we're going to start describing human beings in numbers, then we had better get the numbers right. And so it sort of comes back to data operations and treating things with real respect and real care. It's these are big things we're talking about. Really big things. Really big things.
Peter, it's also getting that appreciation of data across all the different professions. It affects everything we do now. It's not just down to one area. So no matter what you do as a profession, data and numbers are an essential part of what we do. And at the moment, I still get the impression it's still focused in some areas, kind of the mathematician, statistician type route, but actually in the medical profession, across many other professions as well, you need that awareness of data and what's good data, how to avoid and take out bias in data. You have to understand what you're dealing with. If we said before, garbage in, garbage out, and got to find and educate people what to look for in that data set to start with.
Yeah.
And I think of equal importance is this notion of the imperative of the AI. You know, what it's being used for. Why are we using AI? Because I think that sometimes that also gets forgotten. You know, and so we could have the same data and almost identical processing, but the reason for one is clear, and the reason for the other it might be clear, but quite a negative reason. You know, we need to be really clear about why AI is suitable to tackle this challenge and what it is we're going to achieve with that AI. I think that's something that people outside of the world of AI and machine learning don't really quite understand. They're more concerned that they don't understand the technicalities. Whereas actually, if they're a decision maker and a leader, it's more important that they understand the imperative than the technicalities. Do you see what I mean? And I think that's something that it's really hard to get across. That, you know, in education, I always use the example of emotion recognition in learners. You can have a system that's, you know, designed to produce a very supportive environment where you're watching students as they're learning and giving support to those that are looking concerned or anxious, etc., etc. Or you could have the same system, but the reason you're using the AI is to get the ones who are looking anxious and concerned out of the group because you don't think they're going to be learning fast enough. You know, it's that imperative that I think is really important, as well as the data.
I think the actual modeling itself, and to some extent the data processing, is becoming more and more democratized. But I think a lot of people think there's a magic green button and you press it and the world transforms.
Yes.
And I think we have to think more about the beginning. What are realistic outcomes? How can we measure success? What are our success criteria? And then when you have a model and some information, if you haven't got a business process to pop that into, then its value is really questionable. So the beginning and the end is arguably more important than it ever has been.
Yeah. It goes back to fundamental principles of hypothesis setting that you're trying to evaluate and test something. So you need those criteria to start with to understand that when do you get to your finish point.
Yeah, for me, the initial hypothesis is typically something that's kind of left out when people start designing something new or creating something new. And I think it's coming back now because like the lean startup methodology and everything else brought the hypothesis and the leap of faith hypothesis back into the fold. So it's getting better.
Yeah,
I think another one of the issues that I think a lot about and that I worry about is the impact of bias in sort of hidden and unseen biases, when we're developing especially predictive algorithms in healthcare. And I think this goes back to, I think, something we were talking about before about, data cleaning and curating the data to really, make sure that there are not hidden biases in the data that we're putting into the system. One of my colleagues and mentors in AI is Ziad Obermeyer, who's was previously with us here at Harvard and is now out at Berkeley. But he's written a lot about this and done some really interesting work looking at the presence of bias in many of the algorithms that are out there, and it's really it's eye-opening and something that I think we really need to take seriously, because we for all the potential good that we can do with this, there's also the potential to do harm, and I think we need to guard against that.
And I think sometimes just the business goal can be the most biased thing, and sometimes we divert our attention to the data when actually looking at the goals and what we're trying to achieve is where the bias starts in the first place.
Absolutely.
I think to that point, I think this. Sorry to have had to have left out on the sexual call I made. I think that part of what you're talking about is also this experimentation process. Do you actually look at doing small experiments, and it's not whether what's the result you got is almost less important. It is less important than understanding how you got there, and that is part of that cycle of starting to sift through what are the methodologies you're using to define your algorithms. And if you're using a methodology that defines algorithms in a way that you can test and be happy that you get rid of them because you don't like the result because it doesn't do what you want it to do, then everyone's comfortable with that. I think this big, as I experienced, this big upfront investment just means that people don't want to let go. They don't want to design systems. Got to be.
We need to move on to the other stream. So I'm going to go over to my other machine, and let's move on to the other stream because Malika is just getting ready. So everyone,
thank you.
Love you for being on.
Thank you.
Do join us on the other show, and see you shortly. Thanks, bye.
Great, lovely. Thanks, Peter.